Selva, can you check both things?
Yeah, I will check both.
No, right now it's live.
It will be okay. I will check. I will go to mute. I will check and I will come back.
Okay then.
Because I have to check the volume also.
Right.
If Vasagam sir has arrived, we can start, I think.
Google, I'm just putting the mute all so that you need to unmute everyone. So whenever you are about to speak, so right now the people can't themselves unmute them. Is it understandable? Yeah. Yes, I'm just muting them. Google, can you unmute yourself? Google?
Yeah, I can unmute.
Okay, so you just try Sivathanu Pillai sir or Pandian sir.
Sivathanu Pillai sir is unmuted. Pandian sir is also unmute.
Okay, you just try it once.
I have tried for you. Yeah, I have tried for you.
Okay, fine. Great. Thank you.
You are co-host. Okay, it's not happening.
Yes, you are throwing the request so that if I say yes, it's yes.
Okay, great. I think yeah, we are on time.
Okay.
So I think we welcome our Praveen sir also and Munirat.
Google, your network is very poor, I think so.
Who's mine?
Yes. No, it's going down, so that's why.
Hear me properly. I think I got a call.
Oh, okay.
So you can admit. I think people.
Yes. I have already admitted. So I'm doing. So, I'm on process.
Karunagaran. Ramdas sir, can you talk to Vasagam sir?
Google, we are starting by 9:30 or Google, we are starting by 9:30 or we just want to share any videos there.
I think we can start. Balamurugan, please talk to Vasagam sir. I think there is some error with search thing. We will start. I think maybe he can join.
Oh, okay.
Is it okay, Balamurugan?
Okay. Can you share the number? Can you share the number, Gopal, so that I can do it?
Yeah, I'll tell you now.
Okay, fine.
Bala, please make live on to YouTube. Till now, it is not live, Bala.
No, I could see this. Sir. You just check it out, sir. It's live, sir. Are you able to?
IGEN live.
Yes, sir. It is also live. You just check it out, sir. Right now, it's live.
Okay. So you can start here on exact time.
Yes, Google, you can go ahead.
Can we ask our okay, Ramdas sir and Sundaram sir, are you okay? We can start. Balamurugan, can you unmute the photo?
Google, you have the rights. You need to Google. You need to manage the things. You need to unmute whoever want to speak, and then you can go ahead and introduce them.
Yeah. Okay, all are okay. Unmute only.
Okay, fine then. You can just proceed.
Sundaramurthy sir, I'm getting it is unmute, but he's on mute.
No, both of them are trying at the simultaneously, so you just try it once.
You have done it.
Okay.
Okay, I think okay. Maybe we'll reach that.
Yes, but my screen I'm seeing still Dr. Pillai's presentation material.
Yes, sir. Yes, sir. It is there, sir. So you can
Fine,
also.
fine. Okay, no problem, no problem. See, I just wanted to make the.
No, you can change the view, sir. You can change the view on the top right corner, so you can change the view to gallery view, so that you can also see the people on the right hand side. So all the people would be in the scroll down box.
Okay, okay. Yeah. Yes,
Yes, sir.
I'm seeing.
Okay, great. I think we shall start with now. I think IEA and IEA chairman was there and vice chancellor was there. But definitely, I think Bala, you can stream on YouTube, so we can.
Yes. It's already live, Gokul. So you can just go ahead and make your presentation. Yes, Gokul. Thank you.
Can you hear me?
Yes. It's perfect. It's perfect. You can just go ahead. Thank you.
A very good morning to all present here. It's an immense pleasure to invite all our eminent speakers as well as the panelists and our delegates who are watching inside this room as well as in YouTube. So it's an immense morning, Saturday 30th May 2020. The first time the lockdown period we are organizing
Sir,
an international online conference.
அதே சேனல்ல தான் வருது.
It is being organized by
Okay.
Institute of Engineers, Tamil Nadu State Center, along with the Institute of Aeronautics, Astronautics, and Aviation. We are so happy. I think we have come to a challenge of now past 10 days to achieve this conference. We are humbly happy to receive our Padma Shri Dr. A. Sivathanu Pillai sir, also Padma Shri Dr. R.M. VASAGAM sir, who is going to join this article. So definitely, I think without staying the sport of Abdul Kalam, as a young citizen of India, armed with technology, knowledge, and love for my nation, I realize a small aim is a crime. I will work and sweat for a great vision. The vision of transforming India into a developed nation, powered by economic strength with value system. I am one of the citizens of billion, only vision will be billion. I have entered into me. It has entered into me. The ignited soul, compared to any resource, is the most powerful source on the earth, above the earth and under the earth. It's a quote given by our Bharat Ratna Dr. APJ Abdul Kalam. With that, I initiate this conference to be considered. So we welcome all our speakers, panelists, eminent guests, as well as the delegates for this conference. It is my immense pleasure that I am Gokul and the convener of this conference to host this program. So I would like to bring our chairman IEA, Dr. Engineer R. Ramadas, who is also like a very dynamic person who has given a lots of freedom to organize this conference from IEA Tamil Nadu State Center. And Ramadas, Engineer Ramadas is a chairman for IEA for past 2 years before he was an honorary secretary. So he holds a mechanical and production department, and he is holding a CEO of a startup company. So I would like to invite our engineer R. Ramadas to deliver his welcome on. So please. So your voice is low.
On behalf of Institute of Engineers India, Tamil Nadu State Center, I welcome today our chief guest, Dr. A. Sivathanu Pillai sir, and then our Dr. R.M. Vasagam sir, and other Sundaramurthy, Vice President of IEEE, and then Karnagaran, and then Praveen sir, and other dignitaries in that first kind of online international conference in the topic of challenges and opportunities in aeronautics, astronautics, and aviation. The IEA, the Institution of Engineers India, is a 100 years old body. It started in 1920 in Chennai, and then later it's moved to the Kolkata. It's a headquarters. Now the headquarters is Kolkata. Now we are entering into the centenary year. 100th year, last year, September 13, we started the 100th year celebration in Chennai. This year we are going to conclude in the Kolkata for the centenary year celebrations. And other EA have a 15 division, that is all inclusive of right from aerospace to textile engineering in one umbrella. And then we are doing regularly, we are doing the online, this type of conference in physically in one of the city or any one of the cities. This is the first kind of online international conference. And then we have tie up with Springer journals. We are releasing that series A, B, C, D, that 5 series book regularly the tie up with the Springer journals. And then we are doing regularly that 1-day seminar and 2-day seminars and international conference. And then apart from that, every year we have one national convention in the each division. That is 15 divisions. 15 divisions have a national convention. Any one of the city, any one of our local center is hosted. Actually, we have 124 centers in throughout India, and then 6 foreign Dubai, Abu Dhabi, and Nepal, and other countries. 6 other countries also we have the centers. In 32, all the state centers also have 32 state centers. In Tamil Nadu State Center, it's around 1922 it started. Now I think next year, 2 years, we are going to celebrate that centenary year. In under Tamil Nadu State Center, we have 16 local centers. Here, only one center have more than 15 centers. That is 16 local centers in one state. Next one is Bombay. From 10 center is there. So apart from that, we have different kind of that is institutional members, colleges and suppose companies. They are the member in the Institution of Engineers. Totally 540 members in the institutional member in Institution of Engineers. Now more than 110 institutional members from the Tamil Nadu State Center alone. All the way, only the membership is second position, and then rest of the things, everything, the Tamil Nadu State Center is top of everything. 2017, we celebrated the Indian Engineering Congress hosted by Tamil Nadu State Center. That time, President of India, Govind, is participated in the validity function. The last year we celebrated the centenary inauguration center. The governor of Tamil Nadu is participated. Like that, many of part of programs we are regularly conducting. This once again I welcoming all the dignitaries in that international conference. Once again, I welcome everybody. Thank you, and all, Mr. Gokul. Now,
Yeah. Thank you so much, sir, for your warm welcome address. So it's an immense pleasure to initiate this conference with a welcome from our IEA chairman. I would like to invite our Dr. Sundaramurthy sir, who is an vice president of IAA, which is an Institute of Aeronautics, Astronautics, and Aviation, and he also was working in as an eminent scientist in ISRO, and he holds lots of position and he contributes various activities in the aerospace industry. May I invite our Dr. Sundaramurthy sir to deliver about the conference and why we have initiated an objective of conference. Sir, please.
Good morning, everybody, especially Dr. Sivathanu Pillai and our walking encyclopedia of our space, Dr. VASAGAM, and then Pandian, and Okay, Dr. Ramdas sir, Balamurugan, Gokul, Karnagaran, everyone. I think what we have done in a very short interval of time, I think it is not even, 3 weeks efforts, it has now culminated into this program of what we are going to see post this lockdown period. Prior to that, I just wanted to tell how we had the idea of forming a association for this. When we were thinking of an idea of making a kind of an association for aeronautics, astronautics, and avionics, we were grooming this for the past 5 years. Finally, it has culminated in 2017. We have formed the association, and then from then on, we were doing a lot of activities in the colleges, promoting this aero modeling as well as promoting the aerospace activities and that kind of things, and a lot of lecture programs we have arranged, a lot of demo programs we have done, and in fact, in one of the program where we have done our bottle rocket competition for all the Indian students. I think our competition got entered into the India book. So that is one great thing which we have done 2 years back. And the activities what we are going to do is mainly we wanted to make a niche in the aerospace field like what people have done in automobile. That was the main, from that automobile thing only we have got the inspiration, and then we started this aerospace. We wanted to promote. Now, presently, what we are is already there are a lot of opportunities and avenues are available for us, especially in the aerospace domain, because you people are already seeing in the days to come. I think what in 2000s, what IT boom has taken place, similar to that, we are expecting a aerospace boom in the coming days. So what we thought was it is a very apt thing to have this conference of aerospace in defense sector. I think this is the first time, probably in the past decade, what we can see is that one great change has taken place in defense sector. Now it has been allowed to have private participation, as well as in the aircraft industry, and then now a lot of academic institutions are also coming into the picture. So we mainly divided this into 3 panels of eminent speakers like and all are going to be there. They are going to discuss about mainly on defense side, one panel, and then Aero on another panel, and then academia, how we are going to support it. These 3 panels are going to be supported. So with this, I think for all the speakers, and they have voluntarily agreed, and then with so much of difficulties, they have agreed to participate in this and then share their knowledge. And then with this, we hope this will be of immense use to the students community. I once again welcome all of you. Thank you so much.
Yes. Thank you so much, sir, for your overbriefing about the content and why we are doing it, the objective, also the panelists. So we thank your presence as well as delivery as a part of IAE. So without waiting much more time, I think we have our eminent chief guest. I think we are immense pleasure to invite him, which is none other than our Dr. Sivathanu Pillai sir, who is the Padma Bhushan and Padma Shri. But definitely, I think India, like a nation, our Pillai sir is one of the key person, and along with Kalam sir, he has worked a lot. Definitely, we are so happy, sir, so much delighted for your presence, as well as such a time you have given for this conference. And definitely, I think the participants, delegates who are watching inside and outside, We are very much delighted to see you at this forum. So before we take up our inaugural address by our chief guest, so let me introduce our chief guest in a short brief. Dr. A. Sivathanu Pillai sir is an Indian scientist who formerly served as an honorary distinguished professor at Indian Space Research Organization and an honorary professor at IIT Delhi in the Department of Mechanical Engineering and a visiting professor at Indian Institute of Science. He is the president of Project Management Associates and he is the former chairperson of Board of Governors of National Institute of Technology, Gurukshepur. He was formerly served as the Chief Controller of Research and Development from the year 1996 to 2014 and held in the rank of Distinguished Scientist from the year 1999 to 2014 at the Defense Research Development Organization as the Minister of Defense of the Republic of India. He is also founder, CEO, and managing director of BrahMos Aerospace Private Limited. He has received so many awards that is like Padma Bhushan and Padma Shri, which itself like applaud him. That is the biggest achievement for our nation. And he also served his initial career in ISRO for a period of 20 years. So we are so proud at his presence in ISRO as well as in defense and in BrahMos. He's a very close friend of Abdul Kalam sir. So both of them have defined lots of projects for our nation. And I'm so proud, sir, in inviting you for this conference. I think our team of IEA and IEEA is immense pleasure in inviting you. So I would like to invite our Sivathanu Pillai sir to take up this session. Sir, please.
Good morning to all of you. First of all, let me wish you good health in this difficult time. I am thankful to Mr. Gogol for putting me into the conference because he is a close friend of mine. So VASAGAM is yet to join. He is a highly respected person. I am the organizers of the Institute of Aeronautics, Astronautics and Aviation, and the Vice President, Dr. T.K. Sundaramurthy. Then the IEI, TNC President Ramdas, who is known to me because we have got a MOU signed with him for joint conferences from the Project Management Associates. So we work together. So and all other good speakers who are going to be there in the panel, then students, teachers, friends from various parts of the world. For all of you, my greetings. Now, you see that this is a very important topic you have chosen, the challenges in the right time. It is whatever problem we have is going to be there for a few more months. But I think that man cannot be defeated. We will come back. And whatever lost will be compensated. So our future is going to be good, particularly in the aeronautics, astronautics, in the space, and the aviation. So please be sure, please be confident that we are having a great future. I would like to show you some slides to highlight to you. Yes. Yes. I'm just showing to you a video of Carl Sagan.
That's home. That's us.
It's very
On
important.
it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization. Every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet, it's a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
Was it clear to you? This audio, everything is clear?
Yeah, very clear, sir.
Now let us see that, people think small. What did I just now, Google introduced Dr. Kalam's slogan, that small aim is a crime. See, a great person like Kelvin, the president of the Royal Society, declared that man cannot fly. Wright brothers proved he is wrong. Within 86 to 93, within 10 years, they proved Kelvin was wrong. Same time, in 1896, another man came, Konstantin Cholsky from Russia. He says, what can be more fantastic than to land on the surface of the Mars? A new great era will begin in astronomy from the moment using rocket devices. The rocket was not known at the time, but he is visioning that man will land on Mars. Of course, man has landed on the moon, but there's definitely, we will be seeing in another 10 years' time, the human being will go to the Mars. So we have done a lot of work in the area, aeronautics. We have done LCA is operational. We are now getting into MCA. It's a big program which is coming up. And we have got a lot of helicopters. Attack helicopter has come recently. So we have done good work in aeronautics, but a lot of things to be done. If you look at the space, of course, we have done wonderful. We are the fourth in the world in the spacefaring countries today. Remarkably, we have done, our ISRO has done a great job. And the Chandrayaan-2 just missed, but the effort was great. And the missile area, if you see, that is another aerospace area where we have done well. We have got a strategic systems available, Agni with 5,000 kilometers with nuclear payload. So we have also got the supersonic cruise missile, BrahMos, which is the fastest in the world in the cruise missile category. And we are number one in the world. So there are many things we have done in the aeronautics, astronautics, and the aviation. And we are now looking on to the planets as well as to new area called hypersonic plane. So I will talk to you about that in short time. Now, space, we are self-reliant in space technology. We are now supporting the launching of various countries' satellites. More than 250 foreign satellites have been launched by ISRO. So the thing is that we are cost effective and we are highly reliable. Today, PSLV stands in terms of reliability of launch and the lowest premium in the world. So we have got a good opportunity to go in a big way in the space program and in the market. And then you see, we look at now the new technologies like nuclear propulsion, because we want to move fast, 9 months to Mars. So we want to do it by using the nuclear propulsion. It will take 3 months to reach. But still, there's a program launched by NASA that 39 days for Mars is going to be exciting in terms of technology. Second thing is lunar exploration. The lunar exploration is necessary because the moon has got exotic materials. So we want to explore that. Then other planets like Mars got a very good opportunity. People say that Mars, there's a living opportunity in Mars. Once Mars was a green like Earth, 1 billion years before, they have retraced back NASA to say that Mars was a beautiful planet 1 billion years before. Got dried up, no water now, but you can see the trace of all these developments in the Mars by the analysis. So we are going for a lunar exploration. First thing is to put the man in the space. So the people have been selected now. They are undergoing training in Russia. So two of the first one person will go, and then number of people will go in the orbital vehicle to the space and come back. That will soon further into the landing on the moon, finally establishing a factory. From 2025 onwards, we will be seeing a lot of activities on the moon from US, Russia, and China. We may join them later, but we have to go in a long way to reach that point. And our people, ISRO, is capable of doing that. So why we are interested on the moon? Two things. One is, moon is a good launch pad for future launches. Gravity being less 1/6 of the Earth, it is giving an opportunity to have a smaller vehicle compared to that what we have on the Earth. So that is one thing, the launch pad for going to Mars or other planets or exploring the asteroids and other far off planets, including the moons of Saturn. There is a moon called Titan, which is believed to have living conditions. So we have to explore that. Second important thing is the lunar dust has got a very interesting material called regolith. This regolith process will give helium-3. Helium-3 is a non-radioactive material for generating nuclear energy by fusion. So the helium-3, if we can be processed on the moon through this robotic system what has been shown here, and then brought to the Earth, and then using the fusion technology reactor, we will be able to generate energy. 1 gram of helium-3 is equal to 100 grams, 100 times better than uranium, and it is non-radioactive. So it is going to be a big boon for generating energy for the whole world. So how do you generate energy out of the helium-3? So that's why we are joined with other nations, or 7 nations are joined under a program called ITER, International Thermonuclear Experimental Reactor, being built at France. We have joined as a 10% partner into that, and the whole cryostat, that big structure what you are seeing, is being built by us. Half already assembled. This reactor is going to come to generate 500 megawatt of power using the fusion technology. This is our learning ground. Each country has got their own tokamak. They have done a lot of trials, but this is going to be a joint program to share knowledge on the fusion technology, because fusion technology is the future compared to the fission, which is generating a lot of radioactivity. So this is the reactor what you are seeing, and the partners, you see 7 partners who are contributing for making this reactor. 2025 is the target date for the reactor to be ready. So by 2030, India will be having the fusion reactor. 2030, we will be able to bring helium-3 and then we will be processing. So you will see from 2030 to 2040, there's going to be a new way of generating energy linking with moon. Then comes Mars. You have done the Mars mission. Our satellite has done well. It has lived long, and we are having a lot of data which has come. Is giving clue of what is there in Mars. NASA has published a lot of data on Mars. So putting together, there is a possibility of man landing on the Mars in the near future. So there are a lot of technologies to be proved for the human being to go to the Mars. One is the nuclear thermal energy to take us in 3 months' time. Then refueling technology to be introduced. Multi-mission space exploration vehicle with suit probes, laser communication, additive manufacturing. You can make things on the move. That while you are traveling in this vehicle to the space, you can make your own products in space. So 3D printing is coming into the space manufacturing. Then finally is landing on the Mars. NASA has a big program. This what I have put is the NASA program, where they are trying to go for a good system. Elon Musk is working on that. The idea is 2030, the man will land on Mars. This is the goal they have, and it's going to be a very interesting thing to see the progress. So overall, if you see the space program wise, we are energizing competitiveness now. We are in the global market. ISRO is forming out a fantastic organization which will be integrating the industries, and we will make space industry complex. Then the R&D is going to be in the new dimension is going to come for manned mission, new propulsion technology, getting into hypersonic, electric propulsion, plasma propulsion, laser communication, laser propulsion, new materials, because we are going to deal with high temperature, new guidance and control simulation. All these technologies are going to come. We will also support the space program, will support the national security. This is also very important, joining with DRDO. So the international cooperation will also increase, because we are talking about human space flight and joint research on the moon. So the countries, India, US, Russia, they are all joining together. Japan is also in the loop. France is coming. China, we will be joining together to do research on the moon and other planets. Possibly later, cooperation in lunar factory, then International Space Station, removal of space debris, fueling and repair of spacecraft in the orbit to extend its life, solar power satellite, then exploration of helium-3 on moon, asteroids, Mars. So this is going to be a very interesting future. We are going to see in another 20 years' time, our space program will be on the top. So when you have all these assets in space, we need to protect the assets. The enemy should not attack us from his satellite. So we have developed the anti-satellite system to protect us from any possible attack. Then we want to generate energy and also water from outer space. This is one new concept which is being worked out, how to generate water from air. And also you can desalinate using the solar energy pumped into a floating power station on the ocean, and purify the water and pump it to the people for drinking purpose. Then integrated global space station with the core competencies of spacefaring countries, because now one nation cannot do a big program. It's a very it's costly. We want to have cost-effective program. The nations have to join. Like-minded nations will definitely join. Then global human resource cadre has to be built, because there is a need for people of high caliber in the space research more than what we have in ISRO. So there is going to be a joint program with other countries to develop the human resource data in the whole world, so that we will be able to share technology, work together, and for a common mission. So we also got the aerospace area. We have got Agni program. We have 5,000 kilometers, and we are now working on the MIRV, which will give the multiple injection re-entry warheads. So we are going to be very powerful nation with a nuclear payload. We are a nuclear power state already. We have a nuclear weapon state already declared, and we have got the carriers for 5,000 plus kilometers. So it's going to be a big thing of protecting our nation. Strength, respect, strength. That's what Dr. Kalam used to say. So we have to show to the other nations we are not only technology people, we also can save our country. We are strong people. So the internationally we can collaborate. So in the aerospace program, one novel mission was the BrahMos. Is a joint venture between India and Russia. You know that when the 1971 war, we had to use Russian anti-ship missile to finish off the Pakistan ship, naval ship. Now we have got our own anti-ship missiles, very powerful, 3 times faster than air. So we have a very good system, and we went for a novel joint venture where India contributed 50.5% and the Russia contributed 49.5%. The idea of 50.5 is to make government funding a private company. The JV, which has been formed for joint design, development, manufacture, and marketing, that's called Mind to Market, distributing the resources already available, technology resources between India and Russia, finally worked as a joint venture company, a private company, and we were able to do the project within the cost, within that time. Multiple versions have come. Now all three services have got, recently we have flown from the air. So all platforms, everywhere you will see now the BrahMos getting into the ship, then land, air, everywhere it is there. So it is a very important and successful program, and there is no equivalent to that in the whole world. We are the only one to have in the army and in the air. Only Russia has got on ship. We also have got. So we are the people leading now in the supersonic cruise missile program, the whole world. Then now we have formed a team. Already a project is there with us to develop the hypersonic, because the hypersonic is a when we have the BrahMos, we cannot celebrate it for long. The interception will happen. So that is why we have to get into the higher speed, Mach 7. From 3 to 7 we are now venturing into, and this is a good program, and we have got, our gods have got weapons. You see that Lord Krishna is having a Sudarshan Chakra. So we are thinking that this missile, which is going in hypersonic speed, can be operated from the mind of the leader, and it can go do its job and come back to us. That's the type of concept we are working on, that so that a new Sudarshan Chakra will come. Because Brahmastra we have done, now we are working on the Sudarshan Chakra. So hypersonics, what it will do, terrific. You see hypersonic missiles, the way it can devastate the enemy's area, it will penetrate into the nuclear installations of the enemy. So that is the power it has got. So we are getting into that. And we have launched a big program in Indian Institute of Science. Dr. Kalam inaugurated this hypersonic laboratory, which is funded from the BrahMos. And it's a very important development which has happened. And we are also having another program funded by DRDO now, 130 crore funding for hypersonic program to be undertaken in IIT Madras. That's why I am there in IIT Madras, and then IIT Bombay and the IISc jointly. They will be developing all the technologies and DRDL will make a missile. You can see that these are the technologies which are going to be done. Main technology is the material, high temperature material. We are now working on that. This, if we succeed, all other technologies we have captured: scramjet engine and high temperature materials. This ISRO has done the scramjet technology already in a small rocket. They have made it and they have flown this scramjet. They achieved 6.5 Mach number for 26 seconds. They have flown. It is a marvelous development which has been happened in our country. See, this is the missile which is going to come up. It's going to be, this is the what I showed you, the terminal phase as a hypersonic going and finishing of the enemy for a long distance. It will be for a long range, and it is going to be one of the very important projects which will be undertaken by us. So all over the world, though they could not overtake in supersonic, they are trying to overtake in hypersonic. So there's a big program going on. I have seen what Russians have done. China has launched the hypersonic missile, the wave radar. USA has launched the wave radar. So it is not only the wave radar, the major technology is the scramjet technology, which needs to be developed. No one has done it. They are all in the beginning stage for smaller time, but we want 2,000, 5,000 seconds burning of the scramjet technology that no one has done. So we are now trying to work on that. Mainly it comes to the materials. So if we can look at the overall in the aerospace area, we see all these people, they have gone for heavy launch vehicle to put a small payload. Space shuttle, which is 2,000 tons in the shuttle weight, it can put only 1.5% of the payload, and it can put only 30 tons. So it's not a good system. So we thought, we formed a team to work payload fraction of 15. From 1.5 we want to jump to 15%. It's a very huge tall order, but we have found the method of doing it with 100-ton takeoff. Our vehicle, which has been designed, can go to the go and orbit around the Earth, spending the fuel, reduce the weight to 91 tons, and while it is flying around while it is going around the Earth in a scramjet mode, it doesn't leave the air. The hot air is cooled. There's a heat exchanger. You'll cool the air and separate the liquid oxygen and store liquid oxygen. The weight suddenly from 91 ton increased to 166 ton, and then we use cryogenic propulsion because we have got hydrogen stored, and we use the liquid oxygen generated in flight, and finally we are able to put 16 ton in the orbit to that. This is a shock to the world. When we presented in the IAF Congress, it was a very shock. So they said that this is not possible. Finally, we proved now many people are working on this technology, which if it comes, we can get high payload fraction. Why we need high payload fraction? Because we want to see the cost of launch should be reduced. The very, very important thing is the cost. If we are spending now $20,000 per kg of satellites, we want to make it $2,000 initially and finally getting into $200 per kg. This needs technology. So that is what is shown here in this slide. What are the different technologies which can help us to reduce the cost per kg? So we will be successful if we can reduce the cost, so that because it's a competitive world. Also, the solar power satellite is a very important, which just now I mentioned. It is going to be a very important requirement for the future. The power comes from the satellite, which can be used to desalinate water, and you get drinking water also. This is the debris removal. Debris removal, there are methods, many methods are being worked out, and people have to join together, countries have to join together to do that. Industries with the debris capture, that is collect, a big collector will go and take out all these debris around the Earth, because the Earth is already crowded with these debris, and deorbit, all these technologies being worked out. So if you look at the future is very interesting. One is the mining of the scarce resources from Moon, Mars, asteroids, factory on the Moon for mining helium-3 for electricity generation, dry ice deposits in the Moon, which was found out by the Chandrayaan-1 as source of fuel for rocket engine, Moon to be used as a hub of transportation to liberation points, Mars and other planets, solar power satellites and floating power stations and desalination plants for water, then safety against possible asteroid collision on the Earth. This is a very important thing because there is a prediction that 2080, March 16th, an asteroid is going to hit on the Earth. So we have to protect the Earth. Solar sails for interplanetary travel, removal of space debris, operating satellite service should be extended. We have to operate service stations in the geo orbit. The satellite will do only service, like our fuel pumps are there. We go and fill the cars, fill fuel in the cars. We should do it for the satellites in the orbits. So this is what is going to. This is the method of the servicing the satellites. So there's going to be a lot of things happening in the in-orbit servicing capabilities to be built. The asteroid, we can get resources from the asteroid. A lot of new materials are available on the asteroid. So this is the research on that, and the protecting from the asteroid. And so if you see next 100 years of space research, your aeronautics, astronautics, all put together, you will see there's going to be a big program on planets, hypersonics, unmanned combat air vehicles. Planes will not have their pilots. Unmanned combat vehicles, then morphing airframe. So the control is done automatically like a bird. Aircraft can fly. A huge aircraft which can carry 10,000 people at a time. Then reusable systems, then solar power satellite, mining in planets, space colonies, and very importantly in the 100th year, we will be settling in another planet. That is also possible. So the 2 years have been already located, which are very similar to the Earth, double the size, and people are doing research on that, whether we can go and settle down there. The settling is very important because the Earth is in the solar system. Solar system has got a life. The sun, which has completed 4.7 billion years, can live another 5 billion years. But the human race is a special given by the God. The human race is totally special. So that human race should be protected. Coronavirus is trying its work to reduce our strength, but we have to fight and drive the coronavirus away from us. We should fight. People are afraid of that. Instead of that, we should fight with that and get rid of it. That's what we should do because human race, even one life should not go. So for that, now the IEI and the VASAGAM has just joined. I'm seeing his face. Sir, good morning,
Yes,
sir. And then Dr. Sundaramurthy, all of you, you've got a lot of things to do. I'm showing here, you should have a vision. ISRO, DRDO, NAL and institutions, they are doing research on the aeronautics, astronautics and the aviation. So you have to bring together with the mission. See, what will drive the people is the mission. So you people should join together, probably at the end of this conference, to define a mission 1 for aeronautics, mission 1 for astronautics, mission 1 for civil aviation. Then like that, what is mission 2 for each area? If you define, then the people will start working. What we need is we have to create synergy between the research organizations, academy, and industry. Industry is capable today, but we need to tell them this is what we need. So we have to bring them and give them our technology. Then only the development will happen. So synergy is a very important thing. Space technology has got a great future, and we will achieve advanced aerospace systems and industry complex. So thank you very much for giving me this opportunity and I enjoyed sharing with you some of my thoughts, which will definitely kindle the minds of the young people. Thank you very much. Thank you, Gokul.
Yes, sir. So thank you so much, sir, for your enlightening session. I think this has given a lot of vision for our aerospace industry, and it's a wonderful inaugural address. I think during this lockdown period, we have not got so much of information how our country is looking into that, and your experience, your knowledge, and your happiness are shared to all our people of our nation as well as internationally. There are few participants who are also watching this session. So thank you so much for your presence as well as the wonderful thoughts on the challenges and opportunity after post-COVID-19. So thank you once again, sir. Thank you so much. So it's an immense pleasure to also invite our Vasagam sir, who's a Padma Shri on this session. So Vasagam sir, are you audible? Can you check up?
Sir, we would like to hear your voice, Mr. Vasagam.
Hello.
Hello, sir. How are you?
Sir, yes, sir.
How are you?
Yeah. Hello.
Hello. Hello.
Hello.
Yes, sir. We can hear you, sir.
Vasagam, sir.
Yeah, you are able to hear?
Yes, yes. I am able to hear.
Yes, sir. We can able to hear, sir. So no issue, sir. So thank you for Vasagam, sir. Sir, to be in this. So before we start this session, we just have a small brief introduction about our Vasagam, sir.
This slide.
So Vasagam, sir.
Slide is being shown as thank you. So we remove that?
Yes, sir.
Yes, sir. Yes, sir.
So that Vasagam slides can come, or he can come and speak.
Yeah. So a small brief introduction about our Padma Shri A Vasagam, sir, who is a mentor for our IEA. Always like we can say he is a leader and a visionary. So he is currently a chancellor of Dr. MGR Education and Research Institute, and also chancellor for Karpagam University, Coimbatore. And he was a vice president in the Dr. MGR University, and he was a vice chancellor of MGR University from 2003 to 2006. And he was a director for Karna Institute of Technology, also a chairman of Tamil Nadu Institute of Information Technology. So previously, he was a vice chancellor for Anna University in 1996 to 1999, and he was an outstanding scientist in ISRO. And to be proud, the first satellite Apple, which we have launched from our hands of India, its project director is our Padma Shri R.M. Vasagam sir. So he was a Directorate of Advanced Technology and Planning, ISRO headquarters, Bangalore. So he has completed his BE honors from University of Madras in 1963 and MTech from IIT Madras, and worked in Indian space program from the inception in early 60s. So he is the one of the key person in for Apple. That is India's first experimental geostationary communication satellite project between 1977 to 83 time frame. So he has received so many awards, which includes Padma Shri and Vikram Sarabhai Award and Brian Roy Award for Space and Distinguished Alumnus Award from IIT. So he is also visiting scientist at the Indian Institute of Space and Astronautical Science and a fellow of National Academy of Science, and so many. I think to say about profile, I think it's very detailed. Without wasting much more time, we would ask our Vasagam sir to take up this session. Sir, please. Sir, can you hear us, Vasagam sir? Yeah. Sir, you can proceed. Sir. You can give your guest of honor address.
Hello.
Yes, sir. We can hear you, sir. Please go ahead, sir. So can you hear us? Vasagam sir, can you hear?
kindly give you a best of honor. Sir.
So, Vasagam sir, you can proceed your guest of honor
Address. Sir, please proceed with your address, sir.
We are audible. Arnav, can you just talk to or can you just call him and check out? He's not audio from our side, so please check his audio.
Yeah, hello.
Yes, sir.
Sir, we can hear you, sir. We can hear you.
Yeah, okay. Okay. Okay, I will just begin. Hello.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. We are waiting.
Hello, you are able to hear?
Yes, yes. We are able to hear you. Please speak.
Yeah. Hello.
Yes.
So, good morning to all of you. This is a historic occasion. On one side, we are having, very difficult circumstances. At the same time, we are talking of the future of many things. So, first and foremost, let me say that the institution, because I represent the institutional engineers also, as the chairman of Aerospace Engineering Division Board, and as part of the centenary celebrations of the institutional engineers, we are conducting the international events, and this is one such event for the Aerospace Engineering Division. In addition, we also have the birth centenary of Dr. Vikram Sarabhai being celebrated, who is the father figure for the Indian space program, and Professor Satish Dhawan, his birth centenary starts from September 25th of this year. So the stalwarts who made something in this field, we salute them first before starting the program. And second, the foundations of the aeronautics in this country has come from Walchand Hirachand, who started the Hindustan Aeronautics, and also the J.R.D. Tata, who had the first commercial flight for the airmail. That was the first one, and then the civil aviation was born. So many things have happened, and the Royal Air Force also had operations in the Second World War time. More than 400 airfields were created at that time for fighting the war. So many people have done such accomplishments, and the infrastructure which came in those days is now supporting the major program. And the important thing that you'll have to see is the troubled times. The human body is the host for more than 3 trillion organisms, all virus, bacteria, everything, 3 trillion. So even the stars are only 100 billion, as Carl Sagan, Sivathanu Pillai showed the slide. But we are surviving against all those odds. Our immunity is built over maybe thousands of years. So how we survive, we will survive all the time to come. And the second, the pandemic, COVID-19 is crippling the whole world. Aviation affected totally because all the airports are locked, and then the planes are parked on the runways. You will see all kinds of things. And the cargo movement is only for essential supply. It is going on. And the other part, aircraft production also stopped, and layoff of workers. Even Boeing has sent out 10,000 people just few days back, and all over the world it is happening. And layoff of workers, whether it is in Asia Pacific or in the Americas or in Europe, everywhere it is happening. Supply of parts from work center, because Boeing company had outsourced parts from almost 37 countries with only all digital route for the drawings and the materials, everything was through digital means. So on one side, the IT enabled them to spread the network for the suppliers, but at the same time, it is now getting affected totally. And the space system projects, all the modernizing, all other things which are happening in the areas. But what I would say, on one side, you have seen beautiful slides depicting the growth of space and the defense sector, and also the civil aviation sector in this country, especially the navigation system related things. But the future, going beyond the confines of the earth, go to moon or Mars, or even beyond that for the entire solar system, that is all, you can say, the curiosity component. And maybe sometimes you will be lucky to get some new knowledge, new way of doing things, and then it will also give maybe a much better return. That is one of the important things. But the part which is happening is the assembly testing of ISRO is now closed. Infrastructure building has been slowed down. Absolutely essential service only are maintained. And Chinese Long March, in spite of all this, they launched their heaviest payload carrying vehicle, 25 tons in low Earth orbit. So that has been also returned part of it. And the other part, the Virgin Galactic is trying to redo the Orbital Science Corporation experiments. The Pegasus was air-launched, the satellite launch vehicle. And very same thing is now being done by Virgin Galactic with Boeing 747. And the other slow return of commercial flight is happening, trickling passengers, and also so many barriers, including the health checks. Or also progress is who are chosen for, that is the Gagannauts, we call them. They are being trained in Russia, but now they are waiting, just about to resume the training now. And tomorrow morning, maybe the commercial crew will fly from the US for the NASA SpaceX joint experiment. And we hope they succeed, because that is the initiating so many new things of doing things at faster, cheaper, better. That route they are trying to demonstrate now. And Chandrayaan and beyond, we have also the other missions, even Mars and many other things will happen. But I would touch upon the education component. The entire AICTE, is focused on the experiential learning, and not only beyond curriculum. You have to do many things before you are getting ready for the industry jobs. And that is one thing which is the big lacuna in this country, maybe in many other countries also. So how you blend practice with learning is very, very important. Because our Institution of Engineering, AMIE, was one such program, well thought out in 1930s. And then that has stood the test of time. Many people have played very key roles in many organizations in India and abroad, but including the aviation sector and aeronautics and rocket sector also. But the pioneering effort by the California Polytechnic College, Cal Poly, it is along with NASA Ames Center and also with NASA, the other NASA centers and the Stanford University, they came up with the CubeSat, 10 centimeter cube. That was the module, and then you can put 1U, 3U, even 12U. Up to that, they have built satellites. So this is where I think the Burt Rutan, who had the around the globe non-stop flight, he built. Burt Rutan was a student of Cal Poly. And we also have the composites activity, that was entirely composite aircraft. And same thing with the CubeSat is now blossoming in many countries, many areas. Of course, even our PSLV, as Sivathanu Pillai told, it has launched many of those things. from other countries, student built satellites at a very lower cost and economic cost. So that is happening. And the orbital debris mitigation, what you have seen, these are all ideas and dreams. It is like, you open a bag of beans and then you try to collect it again. So it is as bad or as simple as that. So that is the, ultimately, whether it is a non-contact thing or a net will be capturing or it will be a laser energy, whatever way you have to remove this debris is a very big thing. Thousands, 22,000 plus objects and tracking them and then, getting their orbit, how they decay, all those things. And then controlled descent is now going to be made mandatory for many of those things, whether it is low Earth orbit or even geostationary. Geostationary, there is a common understanding that they will be removing it out of the useful orbit. So at least that is happening. But in other places, the last stage also is traveling and then it finally explodes or it goes into many, many fragments. So these are not yet understood how to handle this kind of things. And the other, the rocket lab, I need a different way of doing things, including, setting up a launch pad in New Zealand and also in US. And the University of Toronto, Institute of Aerospace Studies in Canada, they did the small satellite initiative long back. University of Utah did. NASA, James Fletcher, who left NASA after resurrecting the space shuttle, he became the president of that university. And there a lot of work was being done on the small satellites. And many, many other universities are now participating very, very actively in this, in Europe, in Japan, in China, many other, even France also we have people. And one of the things that we are doing, even Israel, they are doing with the high school students, they build satellites. And these are things which are happening. And one of the initiatives as part of the thing was the 75 years of India's independence. We wanted to have the Gaganyaan as the climax event and getting the Indians sent to space and then get them back. And at the same time, we also thought the student community of this country, 4,500 plus colleges in this country, they should be capable of building small satellites, and 75 of them, 75 institutions individually or consortia, and then they should get them launched by 2022, maybe with the Indian built launch vehicle like small satellite launch vehicle, which is just about to be experimented now, tested very soon in launching and other things to take place. So this is one thing where we want to move the workforce among the students, and it is a highly interdisciplinary activity. It's two subjects the AICT has mandatorily done, that two of them should be interdisciplinary, and also they have to have partly practice, partly theoretical, so interdisciplinary groups. So this small satellite will very nicely fill that role. And that is what I think we are trying to promote among the student community, academic institutions in the country, and also maybe some of the research labs, those who are going to do the internship. So this is happening now. And the other, of course, you have heard the Sivathanu Pillai's presentation on the defense, where, our Tejas is now going for production mode, which is the indigenous, combat aircraft. Unmanned version of that also will be built, and the aircraft, but the aircraft maintenance and life extension has not yet taken off properly in this country, even though we have Hindustan University had a Typhoid core program for doing this in our Chennai airport. So I hope that this is spreading much better, because where skill and knowledge both are combined, and guaranteed reliability has to be made. So this you will have to see. And the other, of course, now the new things which are happening, we have the foreign direct investment is now, permitted in the defense sector. And the co-development, of course, the BrahMos is the initial, example. You can say many more will follow. Then we have the other very similar activities for the co-development in civil air transport aircraft. India doesn't have a civil transport aircraft other than the original Aero, and that is also now not really made, productionized in Kanpur. So we are starving for that, and the C-17 and all what we are getting for troop transport, equipment and armaments transport, these are not yet there. Even forest fire fighting, we don't have a plane available in India. Oil well firefighting, we don't have the means. So variety of things which we have to think of. So when we are talking of, the ideal scientific and technological achievements, same time we have to find the real need of the country. The uncharted territories, I would just like to end like unmanned aerial and combat vehicle. So the UAV program was attempted in this country, even as part of the NDRF, which is part of the Institution of Engineers, along with academic institutions and research institutions. More than 130 projects were completed, and that all the outcome is available both for the researchers and also for the industry people to go for production and patenting and maybe marketing outside also. Because today the scenario is that the low-cost menace, other than the COVID pandemic, it is also in parallel, it is attacking India, and they say unmanned vehicles will be used, drones will be used for spraying. So this is something, when we have technology and understanding, but we have not anticipated this type of sudden demand and then get ready for meeting that, increasing demand at a very short time. Whether it is PPE or any other things, capacity is there, but you can't scale up in a short time. So this is where I think we'll have to see. And the other cargo operations will be bulk of the things where actually, separate cargo planes are there, but we also carry the cargo in the passenger aircraft in the belly, and that is now affected. So many of the supply chains are totally in disarray. So this has to be separate, cargo planes have to be also made in this country, and that should be supported by government. And also it could be, a useful life of an airframe, maybe around 30 years. Engines have to be replaced after 10 years, avionics every 3 years. So that cycle we have not understood nor made it country. And the other contract R&D for other countries, international programs, as we have seen, there is always area where it is possible to get a window of opportunity. So Boeing and EADS, out of necessity, when they are marketing some of their products to India, they also have to spend more than about 30% of that money in India. In the case of Israel, it is almost 50%. So where is the workforce? What kind of work they are expecting to deliver to those people out of the 30% share or 50% share? So this is an opportunity which I think the thousands of engineers who are coming out, not alone aeronautics or the aerospace or the electronic engineers, it is mechanical engineers, manufacturing engineers, quality assurance people, and chemical engineers, many people. We have to think of that kind of opportunity. And when are we going to export Indian aviation products in a massive way? Long back, I think when former Prime Minister Rajiv Gandhi once told, when are we going to make electronic chips, not merely the banana chips? So how long we are going to make banana chips? Because in those days, the word banana republic was a derisive remark. So it is partly dictatorial regimes and dominating the government policy. So that I think the electronics is the weakest link, Achilles heel of India's every segment. Out of that, aeronautics also is suffering. I think that we will have to understand. So this one thing, the foundry, what cost, whether it is astronomical cost, we don't think so. It may be $3 billion, $5 billion kind of investment, but worth for the returns that they'll have to think of. And the hope is 1,050 space missions with an outlay of $450 billion in over next 10 years. So this is the broad picture. Out of that, what India, whether we can get a share of 5% at least, that is what I think we'll have to aspire for. And the unfulfilled demand of the domestic demands for transponders, the world over there are 11,000 transponders already. We are also hiring from foreign satellites. But when are we going to have our own satellite transponders leased out to others? I think the industry has to come forward to take this as a big opportunity for make a good business and succeed. That is what I think. Communication is the bread and butter. Next only maybe the imagery and the remote sensing, all other things, they are more for elite users. This the communication touches each and every person in the world. So that I think we have to now immediately get on with that kind of thing. And the other part is the curriculum and whether we have opportunities for the young people who are completing the aeronautics program. In spite of the almost 17,000 people, nearly 9,000 and odd engineers and scientists in ISRO, we have less than 100 people with aeronautics degree. And even computer science, you don't have too many people. I think you must understand the balance of the workforce requirement, even in R&D, in manufacturing, in testing, everywhere. It is highly interdisciplinary product. Aerospace is highly interdisciplinary. So you have to now gear up for that kind of environment. And then the piloting unmanned air vehicles and also the pilot training is another critical segment which we have not yet been able to do. And the aviation medicine is another area. So a variety of things are happening. So you might see people who are going on the current flights, many places you will be seeing them. They are, what I would say, suddenly there is a demand for so many safety aspects, even for a passenger. So all those things have to be documented. It has to be codified and systematically followed. So that how we are going to do, we'll have to see. And the space and aviation law is another area domain where India is just making a beginning. Without a space law, many things are not possible. And then the compensation, also the accident cover, variety of things which you have not understood. The business end of the science and technology, I think that has to be also mastered. So I hope that this program, not alone it is reaching the students and academic people and industry people in India. I am very happy that it is reaching out many other countries around the globe. So I hope that this event will be a good success and you will be really able to get a new way of interacting with the entire world. Thank you so much.
Yes, thank you. Thank you so much, sir. I think for your wonderful the guest of honor, sir. I think you have given a perspective of all what required after post-COVID, as well as I think the earlier how India has gone aerospace industry, and the very important the youth of our country, how they are going forward the aerospace sector in different perspectives. Definitely, I think they would have got enough knowledge, and we are so happy. I think you have joined us with guest of honor. And it's so immense pleasure again from the organizing committee as well as Institute of Aeronautics, Astronautics and Aviation and the Institute of Engineers Technology Center. We are thankful so much for our Padma Shri A VASAGAM sir who have joined and as a mentor, as a leader and as always a teacher. Thank you so much, sir. I think it is a time. I think we are going to conclude this session. I think before we conclude, I think I should say some few of statistics what we have reached for this conference. I think Bala, I think you can share the our statistics for all the audience, speakers, and guests. Till I think today the total response through our Google form we have received is 1,710, and out of that the final response is 1,500. Almost 200 were duplicate. So if you try to see out of that, I think Hindustan College is almost ranks gold of more than 70 participants. We have got many participants from premier institutions like IIT Chennai, IIT Kanpur, IIT Gandhinagar, and also MIT Madras Institute of Technology, SRM, and much more institutions of nearly something around 966 students have joined in it, and 295 faculties and 144 industrialists and 87 people across the email. So also I think 126 company people have responded, especially HAL Bangalore, Astro, and much more. I think CPCL, many industries. So these are the responses. And college-wise, we try to see I think many private institutions as well as premier institutions. So the response from if at all we see from foreign, I think we got a good response from California, Sweden, Catalonia, Canada, Spain, and we got from Florida, Virginia, France, and South Korea. So, and few people from NASA, Boeing, and LDRA, and Safran, France, and Tunsan. So, very happy to share to all the statistics to all our delegates, as well as our panelists and the speakers and the eminent guests. So, we are the statistics of a 10 days conference on this aerospace. So we have reached much higher. I think the audience delegates are waiting for much more panelists to discuss. So thank you so much, sir. Can I ask our Karnakaran, who is a professor from Sivathanu University, as well as a very important person from IAA, to deliver the vote of thanks. Karnakaran, please.
Arise, awake, and stop not. As Vivekananda says, every time when the disaster strikes or difficult times, we prove ourselves, especially we Indians. And also across the globe, the human race fights for its survival and also evolution. This international conference, especially during this pandemic time, crisis management time, we are gathering ourselves to make our mankind and aerospace sector to move across and along with the young student community. First, I take pleasure in thanking and welcoming both of our chief guests and guest of honor, Padma A. Sivathanu Pillai sir and our Padma Shri A. sir. It's a great honor for us to have you once again in IEEE events. So, IEEE is a young professional body and a foundation which started in 2017 as our vice president said, and a lot of aero enthusiasts across India from DRDO, ISRO, and industry, especially academicians, came together and started in 2017 MIT. And then it started to act very efficiently, especially where there is a need and where there is a need to push our target getting activities. In 2018-19, IEEE has supported IIT Guwahati's techniques event and IIT Madras Shastra event and have launched various aero competitions in IIT Shastra every year. And in 2018, IEEE launched officially entered into a Guinness account with 14,000 school students to promote aero enthusiasm among the school students with paper plane, and which gathered around 14,000. And in Hyderabad MLRIT venue, we got around 7,000 school students participating in the competition. And in 2019 Jan, we have also brought 10 hot air balloons. And along with other partners, we have conducted hot air balloon festival, International Hot Air Balloon Festival at Chennai. And we are progress, like IEEE is contributing along with every professional body, premier institutions, and its main focus is to bring on the next generation leaders. We see in aerospace, there is a very big difference age group. The leaders will be from 35, or else they will be above 45 or 50. So there is a need that we need to bring on all young leaders to take charge and realize that they are the next leaders of aerospace. So that's what we are trying to do, and I thank IEI chairman, IEI Tamil Nadu chairman BrahMos sir, who have effectively coordinated this event. And I need to thank Mr. Gopal, Dr. Sushil, and people behind that IEI Tamil Nadu team, Bala, Ramesh, Sendil, Tilton, and if I have missed someone, please excuse me. And we are going to have a continuous series of events for these 2 days. Lot of panel members across the globe and also participants across the globe who are going to see these things. And this is really going to give us very in detail knowledge about how we are going to face the COVID, post-COVID condition especially. We are going to discuss about space technology. Yes, as Vasam sir and Sivathanu Pillai sir said, we are going to discuss about space law and also defense and related policies and aviation, aerospace industries in academies, how the academic is being affected and what kind of aerospace changes will happen in academics. And we have startups and tooling and training software training industries. So all together we are going to have a very detailed insight and also the need and the role of professional body organizations also going to be discussed. So with this, I thank everyone who have worked a lot to bring this conference within 18 days. Within 18 days, and also I thank the paper presenters who have done a very good work and the team who have selected it, Dr. Satyanarayana Gupta, Dr. Isham Pannikrige, and the chairmen of the paper presenters, Muthuraman from PMAST and also Dr. Muruganandam. And I thank everyone who have contributed a lot as a team. And with this, I thank the entire organizing team and move on. I'm giving the dais to the comparer. Thank you. Thank you all.
Thank you so much, Dr. Karnagaran, for your introduction. So once again, to all the delegates and chief guests, so we are on the in international online conference challenges of aeronautics, aeronautical, astronautics, and aviation. So much awaiting session. I think panel discussions we are going to right now. We have 4 eminent speakers with the moderator. I think with initiation, I think we have Dr. S. Pandian sir, who is the former director of Astro, who is my mentor and my guru, I can say. And we have Dr. Anita Sengupta, who is a research associate professor, University of South California, and she also was working in NASA on the Mars orbiter. And we have Dr. Bharat Gopal Swami, distinguished senior fellow over, and Dr. V. Balaji, who is a senior research engineer, NIA. The moderator for the session, I think we have our organizing committee member, as well as the dynamic Dr. Sushil Shekhar, who was a former NPP fellow, NASA AME. So before we start, I thank all of for IEA chairman, IAA, the vice president, as well as the committee members, and especially our Padma Bhushan, Dr. A. Sivathanu Pillai sir, and Padma Shri Dr. R.M. VASAGAM sir for their presence and initiating this conference in a very higher way. Thank you so much, sir, for your guidance and support. Definitely, I think with your support, I think we will organize much more conferences. Definitely, the knowledge what you have has to be spread throughout the globe, and the younger generation of our country is waiting for it. Thank you so much. Can I ask our Dr. Sushil Shekhar to take up this session, the first panel on the impact of COVID-19 pandemic situation? Sushil?
Can you hear me?
Yeah, Sushil.
Yes.
Yeah,
okay.
please.
Thanks very much. Just a curious question. There are 25 screens that 25 panel members on the screen. Is there any way where we can just have the panelists alone on the screen and not everyone else? It might be a little confusing for people who are watching it online.
No problem. I think our Balava will take care. They'll be separately. They'll be put up the first and second panel. So when they started convey their message, I think they'll be on the screen.
Okay. Anyway, let me just start. We're already about 30 minutes late. Thanks everyone for tuning in to watch these panel discussions, and I have to start thanking all the panelists for accepting our invites in really short time. As Professor Karunakaran said, this program was brainstormed over a period of 3 weeks, so it's nearly just 20 days that we put together this series of discussions. Also, we have been having panelists waiting on the call from the US, and it's pretty late there already. So I appreciate their enthusiasm to participate in this. I also apologize for the 30-minute delay. I also have to appreciate the impressive marketing and publicity campaign put up by IEI and IEEE. They managed to garner think about 1,500 interested students, faculty, professionals, and researchers to participate in this program. Okay, let me go ahead with a very brief introduction of what you're going to look at, and I'll essentially introduce the panelists at the end. So we're trying something very clear. What we're trying to do is basically address the elephant in the room and trying to make sense of the current situation amidst pandemic-driven lockdown. So not just in India, this is happening everywhere in the world to different extents. The situation that we're dealing with is the uncertainty with regards to the future of industry, of businesses, of academia, and of research, particularly in the fields of aeronautics and aerospace and aviation. And to make sense of it, we would like to ask experts in the field about their take on the impact of the pandemic and the lockdown, and getting their perspectives on what they see could be done to get us all out of this sticky mess. Rather than just get a one-sided perspective from either the industry or from the government or from the academia, we're trying to do something unique here where we're bringing in 3 separate groups of people from each of those organizations and areas of work, and then trying to brainstorm where I have more questions for each of the panelists. I guess with that, let me start off with, now one quick thing. Since some of the panelists are in the US and it's very late out there, what I will do is I'll shuffle the order in which I'm going through the panelists. And I'll start with Dr. Anita Sengupta, and she is dialed in from Los Angeles right now. I'm going to read out a brief bio of her background and ask her to give a 5 or 10 minute talk on this particular topic. Okay, so Dr. Sengupta is a research associate professor at the University of Southern California, and she teaches the only entry, descent, and landing class in all of the West Coast for graduate students in the aerospace departments. Before joining USC, she was, for over 20 years, had been developing technologies that had enabled exploration of Mars, of asteroids, and exploration of deep space as well. She had started out her career designing and devising launch vehicles and communication satellites at Boeing. And as a part of her doctoral research, she designed engines, developed ion engines that powered the Dawn spacecraft, which reached Vesta, so that giant asteroid, and Ceres, which is a dwarf planet in the main asteroid belt. This was way back in 2006. After that, she joined JPL and was responsible for the supersonic parachute system, which was integral to the landing of the Curiosity rover on Mars. This happened in 2012. If anyone's familiar with the YouTube video titled 7 Minutes of Terror from EPL, she was on that team and describes how the entire combination of events transpired. It's fascinating. And following that, from 2012 to 2017, she managed and led the development of the Cold Atom Laboratory. It's a laser cooling quantum physics facility for the International Space Station. In addition to her background in space, she's also taken up roles in the private sector as a senior executive, developing a vacuum setup with magnetic levitating systems for electrically propelled high-speed transportation, for the Hyperloop system with Virgin Hyperloop as a senior vice president of the engineering systems there. She's also currently leading the development of a hybrid electric vertical takeoff and landing eVTOL urban mobility system. She's a co-founder and the chief product officer at ASX, which is Airspace Experience Technology, and is trying to develop a VTOL system which is emission-free, which could revolutionize travel within urban environments, and also make sure that the carbon footprint of these transport systems significantly reduced. Just as a background, she graduated with master's and PhD in mechanical engineering from the University of Southern California. Dr. Sengupta, could you give us a couple of minutes or maybe 5 to 10 minutes of introduction, please?
Sure. So thank you for having me, and it's wonderful to connect with everybody in India. I actually did similar event related to the commercial crude launch a few days ago. So it's late here, but it's nice to see you all in the morning. Can't wait to come back. I would probably limit my remarks to something a little bit shorter on the 5-minute side and focus on how I think that the COVID pandemic is really changing the way we're all living our lives and the way that we're thinking about our environment. And so one of the things that the COVID pandemic has shown us in sort of a global level experiment is the impact of reducing our impact on climate change, right? So what we've seen with the reduction in road travel and air travel is that the air quality has improved, the skies have become clearer, and it's actually a nice thing. So it's ironic how this terrible disaster has also showed us that we actually can change our environment by reducing our carbon footprint. And so I think even though it's a terrible thing that we're dealing with as human society and the tragedy and the human death, I think we can come out of this with necessity being the mother of invention and come up with ways to reduce our carbon footprint going forward, because that's probably the right thing to do. And I think the transportation sector naturally combines with aerospace as well as with mechanical engineering disciplines, and I think that's kind of the way to go forward. When it comes to space exploration, I think space exploration and space exploration design methodologies teach you to be very efficient in the way you design systems in terms of power utilization, any kind of resource utilization. And so if we can implement some of those problem-solving skills into the private sector, into the transportation sector, we can actually help to solve some of the challenges that we have with climate change using that kind of aerospace discipline. Moving forward, one of the other issues I see more from the sort of academic side or from being an educator side is that now students are having to learn in a very different way. In the past, students were able to interact with other students, with the professors by sitting in class, and now everyone is having to learn online, and that's a very different experience. And so it'll be interesting to see how that changes the way young people enter the job market if they spend 1 or 2 years in their academic undergraduate education learning in this different way. But once again, there may be benefits that come from that, where people are more able to work in remote environments because they've learned to be a student working in those remote environments. So I can see that if we can look for ways that we can leverage some of the challenges that we've faced over the course of the past few months and use that to solve both challenges on the climate change side and make changes in the way that we operate our daily life, such as having remote work more commonly, can actually come out of this maybe stronger than we started.
Thanks very much. That was pretty good. If you have a little bit more time, could I just finish off the introductions of the other panelists and then come back to you with a few questions?
Sure.
Okay, great. I would like to introduce Dr. S. Pandian next, and he's a distinguished scientist at the Indian Space Research Organization. He's currently the Vikram Sarabhai Distinguished Professor at VSSC in Trivandrum. He was previously the director of the Satish Dhawan Space Center in Sriharikota between 2018 and 2019, and was also the associate director of projects at VSSC before that, and the director of Astro's propulsion complex IPRC. At VSSC, he was responsible for aerodynamic design and characterization of launch vehicles, and these included the ASLV, PSLV, GSLV Mark III, several sounding rockets, air-breathing vehicles, re-entry modules, and reusable launch vehicles. And he was also responsible for the mission design, aerodynamic, aerothermal design, and qualification of all launch vehicles at Astro. He's made significant contributions to the Chandrayaan program and the Mangalyaan thermal protection and trajectory design, as well as the GSLV Mark II and Mark III trajectory designs while at VSSC. At SDSC, while he was director, under his leadership, they were able to launch the PSLV C-42 to C-46 launches, and the GSLV Mark II F-11 and GSLV Mark III launch during his time. And he was the chairman of the Launch Authorization Board for all launch vehicles at SDSC. He's also responsible for setting up the gallery, the viewing gallery, which can host 10,000 people for launches at Sriharikota. So we can thank him for that. Dr. Pandian completed his bachelor's from the Madras Institute of Technology and his master's at IISc Bangalore. He has a PhD from IIT Guwahati. He's a recipient of several awards, including ISRO's Eminent Engineer Award, Lifetime Achievement Award, Eminent Alumni Award from the IISc. He's a fellow of the Indian National Academy of Engineers, the Aeronautical Society of India, and the Institution of Engineers in India. He's the coordinator of Aeronautical Research and Development Board, which is a panel under DRDO, and is a member on Shastra's academic board and Karunya University's academic council as well. With that brief introduction, Dr. Pandyan, if you were able to say a few words for 5 to 10 minutes on what you think about COVID-19 and how you perceive things right now.
Thank you, Dr. Sujit Sekhar. Mr. Sivathanu Pillai, Supersonic Missile Man, Encyclopedia of Space, Dr. VASAGAM, Ramdas, Chairman IEI, T.K. Sundaramurthy, Vice President, IAA, Professor Karnagaran, Mr. Gobul, all my co-panelists, delegates, very warm good morning to all of you. First of all, let me congratulate and compliment the organizers for this wonderful event, and it is very timely and apt since we are in the midst of COVID-19. So, I would like to touch upon what the impact on aerospace and the defense sector due to COVID. In my view, this world underestimated COVID-19 in terms of both its propensity to spread and cause harm and its ability to bring businesses and whole economics to whole halt. Many countries are in the midst of executing either mitigation or all-out suppression strategy that are taking a toll on both populace and industries. In fact, this COVID-19 is blessing in disguise for some of them, that is such as retail, fast-moving consumer goods, and medical commerce, mainly because unanticipated demand growth due to panic buying, while for some other sectors such as hospitality and civil aviation, the pandemic has resulted in a very great downturn. It is very important to note that while some type of businesses, the effects of pandemic will be very pronounced in short term, for others, the effect may take more time to manifest. The latter is specifically true for industries that are exposed to a large number of externalities, that is politics, economics, and social. The aerospace and defense fall into this category. The coronavirus pandemic is creating ripples across the globe. Global aerospace component industry, with the red lights flashing over two most important characteristics, that is global chain supply, which move material and component rapidly across borders, and the fabrication facility and the large number of employees working in close proximity. Broadly speaking, the effect of the aerospace and the defense industries because of the spread of COVID-19 and related actions to curtail the contingent can be considered into 5 major impact points. That is, one is the production, manufacturing facilities and supply chain could be affected. Business development effort could be affected. Some will lose, some may gain. Demand for defense equipment and related service may go down. Companies may have to make tough choices that could impact finances and competencies. Stock price, of course, may decline, will bring secondary effect. As far as the effect of each of the above major impact points will differ based on the size of aerospace and defense companies, nature of business, production portfolios, supply chain dependencies, and business plan, just to name a few. In ISRO had a plan for launching 9 PSLV, 3 GSLV, 2 GSLV Mark III, which includes unmanned flight for human space program, Gaganyaan, and 2 small satellite launch vehicles in the year 2020-2021. Because of COVID-19, flow of hardware, subsystems, raw material, funding, and human resources availability are seriously affected. Unlike other technologies, development of launch vehicle and satellite requires long lead time for realization. Hence, impact of COVID-19 may last in National Space Program for another 2 to 3 years. So, the COVID-19 posed a great challenge to ISRO for accomplishing the ongoing missions as well as the future missions, including the prestigious programs like Gaganyaan, Chandrayaan-3 and Aditya. Later stage, the aviation requirement may come down and hence those opportunities can be utilized to compensate the present conditions what is emerging in aerospace. Now coming to orders, approximately 200 billion of market, $200 billion market value has lost in the US aerospace industries alone. The Aerospace and Defense Select Industry Index includes industry leaders such as Boeing, Lockheed Martin, and Grumman is down over 40%. For the entire month of January, Boeing did not have a single order for the first time since 1962. Airbus too have the same issue. Coming to China, the Chinese aerospace manufacturing main suppliers of multiple components used in aircraft and was the first to feel the full effect of the virus. Airbus closed a factory in Tianjin, which is home to its completion center for the Airbus 320 and Airbus 350 models. The factory produces 6 A320 aircraft per month, which is about 10% of the current delivery. And has the potential to trigger a global economic crisis of significant dimensions affecting all industries. One of the industry sector in the eye of coronavirus storm is aerospace. Global air traffic has been brought to almost a complete standstill by COVID-19 outbreak. While air traffic has consistently shown a solid recovery from previous crises, the debate is wide open about how traffic will recover following the current crisis and what will this mean for civil aircraft manufacturing industry, the supply chain and unprecedented whether we might see L-shaped recovery with the consistently lower level of air traffic and permanently slower growth after crisis. So under these circumstances, one has to work for new normal production rates. Either it is industry or as a company, they have to work for the normalization of the whole process, considering the present scenario. So they have to come out with the new normal. This way, this conference also is for new normal. The right size and potential repositioning operation must start immediately. To this end, company strategy, its industrial footprint and operating model need to be reviewed and blueprint developed to fit with the new normal and provide right framework for short-term actions and strategic moves. At industry level, companies and governments will need to work closely together to ensure that key industrial capability do not fall through the crack, as this would put the whole industry at risk. Therefore, the industry will have to quickly reach a consensus on the new normal, define a joint plan for how to transform the industry from the status quo to the new normal, identify at-risk elements in the transition process and develop plans to support them. Once this picture is clear, government support may need to be called upon to safeguard short-term functioning of industries and help manage the transition to the new normal for this strategically important sector. Thank you.
Okay. Thanks very much, Dr. Pandya. Because we are running short of time for the panelists in the US, I'm going to go through some of the questions that I have for Dr. Anita Singh quickly, and then she has to leave early because it's already late for her. And then I'll move over to Dr. Balaji and Dr. Bharat. I hope that's okay with everyone. Okay, Dr. Sengupta. So the current geopolitical situation has essentially amplified nationalistic voices all over the world. And someone who's worked in deep space operations, how do you see the future of projects like the ISS or even the operation of the deep space network, where several other countries have used antennae in Canberra, in Hillstone, and in Britain? Do you see those as relics of the past, or do you still see an avenue towards that sort of a global interaction, or is everyone just going to hunker down and then become nationalist and then work with themselves?
Well, I hope not. I think what we're seeing on the nationalist front is a phase and cyclical, so I don't expect it to stay. I think this probably happened before, and it'll probably happen again as history tends to repeat itself. But I do believe in the context of space exploration, it really depends upon the nature of the mission. So if the nature of the mission is scientific exploration or making humanity a spacefaring society, then we have to be collaborative because we wouldn't be able to pull the resources to make something of that size, which has an infrastructure component to it, a reality. But if it's inherently a commercial venture, such as mining operations, telecommunications, space tourism, then of course you're going to have the commercial aspect, an element of competition, an element of revenue generation, and the efficiencies and the technologies that come from that. So it really does depend, but I don't see an end at all to a US-funded space program, Indian-funded space program, European-funded space program, and I see collaboration going forward for scientific exploration and sort of hopefully future human colonies on the moon and Mars.
But in the current situation with the economic downturn all over the world, it's going to be difficult to convince governments to fund not necessarily feel good, but space exploration, like say find out how Neptune, the atmosphere of Neptune is, or some of the surfaces of Saturn's moons look like. Do you see more lopsided commercial exploration, like you said, mining on Mars or on Moon, rather than these? Is that going to be more transactional between, say, US would come out and say, okay, we are going to do this, and we can give say, the Soviet with Russia or India this much amount of effort? Is it going to be more transactional, or do you see more effort in the feel-good sector of space exploration?
I do still see a distinction between scientific missions, such as, exploring the moons of Saturn and going further out into our solar system. And to be honest with you, robotic exploration missions, which I spent the majority of my career working on, are incredibly cost-effective, huge return on investment, wonderful job opportunities, and they cost very, very little relative to, sending people to the surface of the moon or the surface of Mars. And if you take a look at the mission that I worked on for years, Curiosity, a rover, maybe $2 billion US over a period of 10 years, it's actually pretty small when you look at the overall size of the US budget. So I think they're actually a drop in the bucket when it comes to government expenditures. And then when you take a look at ISRO's space missions, they're even more cost effective. So once again, I think they represent a really small portion of a government budget. That being said, the commercial sector has the ability to develop an entirely new ecosystem. When you have an entirely new ecosystem, you actually create jobs. So that element of the commercial space sector taking over for human space exploration actually has the potential to self-fund itself and create jobs as a result. So I do see an element of, I guess, transactional is one way to put it, but I actually think it's a great commercial venture and it actually stimulates the economy. So I think many people think that moving forward into the 2020 decade and beyond, that space actually is going to be the new boom in the economy.
Okay. I guess we have to tweak the narrative in such a way that we convince people to keep going towards the feel-good sector as well as the commercial cooperation. Right now, you are a research faculty at USC. How do you see the research focus at the university level changing, say, 6 months from now, a year from now, or even 5 years from now? Do you see more focus on government funding or more industry funding in these fields?
So it's a hard one to predict, and I will say in the near term, it's going to be very hard to conduct research in general because of the social distancing restrictions. So if you're not doing a computational project, or you're doing any kind of hardware-oriented experimental project, it's actually going to be very difficult to do any kind of meaningful research probably for the next 6 months or so. I also see that governments are going to have to refocus their funding, for our last question, in the next 6 to 12 months as to what is the highest priority, what is lower priority. But I think moving forward 12 months from now, necessity is the mother of invention. I think governments will look to work with the tech sector, with academia, and coming together with other government sectors to be able to find solutions to some of these challenges. And I have a great example of that, which is ironically rocket science, is that one of the things that people are trying to understand with the virus is basically how far do the viral particles spread as a result of a sneeze or a cough. And what do? They turn to rocket science and computational fluid dynamics to do simulations of how far this fluidized aerosol media would go. So I think there's these really fascinating ways that people can actually work together to solve these challenges. And so that's a government-funded project, of course. But I do think that there will be, very likely, a lot of commercially funded aerospace projects, which then result in master's and PhD theses moving forward probably within the next 2 to 3 years, with companies like SpaceX and Blue Origin doing a bulk of the work to set up that first human colony. For sure, there's going to be a lot of research which is privately funded as a result.
Yeah, that's something to look forward to. I'm going to segue from your point that necessity is the other following mentioned. So the current response to pandemic by different governments has been drastically different by those governments run by women and those that aren't run by women. I mean, this is blatantly obvious data that that's apparent to everyone. How do you shake the industry culture, the academic culture, the political culture to rethink systemic biases, getting more women and girls into studying engineering, sciences, getting them into more powerful positions in each of these? Some of these practices are counterproductive, and some of them are even morally wrong. How do you modify the narrative to get people to think along those lines?
Well, unfortunately, it's sort of like a self-fulfilling prophecy. If you don't have enough women, you never have enough women, sadly. And we definitely need more women in the STEM fields, and we need more women in leadership roles. And historically, women are actually more effective CEOs. So when you have women leading companies and organizations, you actually get better business outcomes. So it actually goes for governments as well. We can take a look at sort of the effect of some of the Northern European countries, and their responses to the COVID pandemic have been quite good. And obviously, New Zealand has had a wonderful response, and taking a look at Germany as well. So there's a lot of data that suggests having women in these leadership roles is actually a very positive thing. But I think it does start very early on. It does start in elementary, grade school education, so primary, secondary education, making sure that young girls know that they have that as an option, giving role models to young girls to see that they too can be scientists and engineers and doctors and mathematicians and technologists. So I think we have to start really young, and then make sure that their interest is fostered as they grow up through the primary education system. And then once you go into the field and then go into the actual professional environment, we have to make sure that we have environments which are healthy for women to feel safe and comfortable and to be able to grow and get promoted into positions of leadership. So even in my own career, I only started to feel issues when I started to go into leadership roles in terms of facing some of those systemic biases. So those are things that we all actively have to pay attention to make sure that our female colleagues feel comfortable and are able to advance in their careers.
That's part of the reason why we desperately seeked out more leaders, women leaders in the field, and try to get you on board for some of these discussions. One last question before I let you go. There's been a tendency by elected officials in several countries to disregard expert opinion and blatant data that's available to them for setting up important public policy, especially in the scientific arena. How do you incentivize politicians to act scientifically and demonstrate to students and youngsters the future is not quite gloomy and with regards to critical scientific work?
Well, maybe my simple answer would be perhaps there should be more scientists and engineers entering political service. They do a better job in those roles. But ultimately, I think it's the training of the engineer and the scientist to think critically, to be pragmatic, and to solve problems. And so I think those kinds of skills have to be instilled in all people moving forward, because we're going to a new era of living where everyone's going to have to solve problems in their daily lives. Like even now, people who own restaurants have to come up with ways to physically change their spaces to support physical distinguishing protocols, right? There's critical thinking and problem solving there. But I do think, once again, it goes back to education and make sure that we have enough science and math education all the way through till people graduate. So people are like, oh, I don't like math, I'm afraid of math. But I do think that it might require retraining of some of the current generation. But I actually would like to see more scientists and engineers going into these political positions. Yeah, I think it makes a lot of sense. And all of what we're seeing right now on all the press conferences is that most of the work that's being done is being done by public health professionals who are all PhDs with different science background degrees, right? So we can see how that kind of training is required for all the policies going forward in this new post-pandemic era.
Great. I mean, that's a pretty hopeful message that we're going to ask you to give you. We need more women scientists. We need more women leaders. If you can have more women scientist leaders like Angela Merkel, perfect. Anyway, thank you very much for participating in this one. If you have to go, you'll be happy.
Thank you so much. I appreciate you having me.
Yeah, thanks. I'm going to shift next to Dr. Balaji Venkatachari. Let me give a brief outline on his background. He's a senior research engineer at the National Institute of Aerospace, NIA, in Hampton, Virginia, and he's a research associate at NASA's Langley Research Center. He works at the Computational Aerosciences branch there. His work there is on investigating physics-based approaches to modeling turbulent transition and implementing them into several CFD tools. And his other interests include developing the space-time CESC numerical framework for CFD for computing applications, and which are applied to high-speed turbulent flows, hypersonic flows, and thermal protection system modeling. Dr. Balaji has a PhD in interdisciplinary engineering from the University of Alabama at Birmingham, and he's an alumnus of Pondicherry University. Dr. Venkatachari, if you can give a brief 5 or 10 minute outline on what you perceive as the current scenario and what you see in the future.
Thanks, Sushil. Hope you can hear me. And hello to all my fellow panelists and the organizers for inviting me here. I think among the panelists, I think I should be honest, I have the least amount of experience probably in terms of the broadness of having spent time in this area. I've been predominantly in academic and government lab settings. So strangely, in the kind of work I've been involved in, it's like, as Dr. Sengupta was pointing out, I do predominantly computational work. So for us, actually, COVID has not changed things much. It's just that I don't go to office every day, but like every day I turn on my computer and I am doing my work. Nothing has stopped. In fact, I'm working more than ever because there's nowhere else to go to and there's not too many distractions around. And I think because it's computational, as long as our employer has set up the supercomputing facilities open and we can access all the software tools and the journals, we are in business. Nothing has affected us. Some of my colleagues who do experimental work, of course, have not been able to go in to work. So that's been a setback. And luckily, usually with experiments, when the experiment is ongoing, you collect a lot of data and you don't have time to process it. And this pandemic actually has given time for a lot of them to actually consolidate their data, process them, and write papers, which they've been meaning to do for a couple of years. Maybe they didn't have time to do so. Another thing is also, like, I think within the community, bulk of the conferences have already switched online, just like this one. So one of the biggest conferences in our area is the AAA conference, which happens in summer and winter. And they are starting with a virtual conference starting from this year. And they hope that in the future also they'll continue this. So this is one good thing. So a lot of times at these conferences, people from participating from India, China, or other countries, even poorer countries, can't often make the trip to these conferences. But now they don't need to do that. They can be at their desks and participate in these conferences for a lower cost. So it opens up. So this crisis actually has given us some new benefits, if at all I can say that. Of course, one challenge in area of research due to this social distancing is you miss the interaction or the random conversations you have with your fellow office mates or neighbors across the room. At NASA, we always have these blackboard conversations over coffee. Random people come and talk about something and suddenly it leads to another idea and you write a paper or something like that. I think right now, online, it still doesn't work like having a random conversation on the blackboard. So that's pretty much from my end.
Okay. Oh, thanks very much for that brief introduction. That water filter discussion or discussion over coffee more often than not gives rise to germinates excellent ideas that we can use in the future. I'm going to introduce Dr. Bharat Gopalswamy. Next, he's a distinguished senior fellow at ORF, the Observer Research Foundation. For those unfamiliar with ORF, it's an independent think tank that provides input for policy and decision makers in the Indian government and to policy and business communities all over India. It initially started out in the 90s as a response to dealing with the economic reform, and today it essentially tackles problems regarding security, strategy, the environment, energy resources, economy, and aspects regarding space. Dr. Gopalswamy is also the Vice President of Strategic Ventures at OCR Services. It's a tech firm that specializes in global trade management, and sanctions compliance in e-governance. He was previously leading the election campaign of Manish Tiwari of the from ISU. Dr. Gopalswamy, you give us a brief 5 or 10 minute introduction. I think you're muted. Could you unmute your call? Yeah.
Sushil, what Sushil forgot to tell you is he and I began our journeys together with the Indian Space Research Organization almost 20 years ago. So, thank you for that introduction. I'm pleased to join you all, and I enjoyed all your comments, listening to all of you, and I just, keeping the clock in mind, I want to keep my comments fairly short, and I have, one thing about going last is everything, you have nothing more to add because all of you have added the wise sentiments and the wise comments and intellectual inputs. But also the good thing about going last is also there are things, I could pick up the crumbs around the table and then just add my pieces of thoughts that you might. I think everybody's been discussing about the COVID situation and all that, what I wanted to do is just take a step behind, one step behind the whole pandemic. And I think this pandemic has primarily been a catalyst to what was coming. What we are essentially witnessing today is a fundamental and a tectonic shift in geopolitics per se. And the National Intelligence Estimate has always pointed out to the return of great power competition. The world took a different turn in 1992 when the US and the Berlin Wall came down, the USSR became Russia. And today, the return of great power competition is between these two countries, which is essentially the United States and China. And that's a tectonic shift in geopolitics per se. The US and the Soviet Union had an ideological shift in geopolitics. They were fundamentally different. There was no codependence between these two countries. But the US and China, fundamentally, the nature of the relationship is so different. It's a symbiotic relationship. There is $800 billion worth of trade between these two countries. These are the number one, number two economies with a lot of co-dependence between these two countries. And if you looked at President Bush's speech, just as before he took office, it was all China, China, China until the 9/11 took place. So China was an important, and many analysts and scholars and international relations theorists had predicted that Bin Laden and his friends might not live forever, but China is to stay there forever. So what you're seeing today, and people like me who have worked on the Republican and the Democratic sides, we'd always supported about the United States taking a stronger position towards China, and this was possible in 2008. And I just want to revisit one primary thing that is congruence to India and relevance to India is, if you remember, during the India-US nuclear deal in 2006 to 2008, President Bush could pick up the phone, call his Chinese counterpart Hu Jintao, and allow the Indian nuclear deal to pass through the Nuclear Suppliers Group or the Board of Governors at the International Atomic Energy Agency. And if you noticed 3 years ago, where you were talking about the Nuclear Suppliers Group, the United States did not have the power to let the Chinese succumb to the United States' interest. So finally, speaking about that geopolitics, it's essentially the American power had weakened, the Chinese power had increased. The United States does not have that kind of same leverage and the power that it once had to arm, twist, or depend China. So today, the United States is in a much different position where it has to engage, socialize, integrate, as well as work with China to accommodate its interests. So that's where you're seeing that fundamental shift in geopolitics. And in this, I'd want to willingly, respectfully disagree with my colleague who is not there, Ms. Sengupta, who has moved on, and she said that scientific collaboration has to take place. But if you look at what's happening, amidst the height of the pandemic, where this is partly a scientific issue, the United States is not able to engage on a scientific basis with China to solve the pandemic problem, which is at the end of the day a scientific issue, but it's been deeply politicized in both these countries.
as well as in other countries, where even if you see the literature in India, it's characterized as a Wuhan virus or a Kung Fu virus or a virus that's originated in China to assuage each of their domestic vertical interests. So this is primarily a catalyst. And if you look at the symptoms around you, this was first manifested itself in how the Chinese handled Taiwan. Today it's Hong Kong, and then the subsequent reactions to what the United States is doing, as well as all the liberal order democracies such as the United Kingdom, where the passports before 1997, anybody born in Hong Kong is being recognized as a British citizen. So whatever it may be a scientific origin issue, but this was coming to a head-on competition between the US and China. One could only imagine and speculate what this battle is going to be between the US and China, as in terms of scientific projects or whatsoever. Now, if you juxtapose this with any project like an International Space Station or whatsoever, or a large scientific endeavor that brings all these powers together, at the height of the Cold War, the US and the Soviet Union were still able to collaborate on scientific endeavors. That's because the ideologies were different. There was less interdependence. But I'd like to argue that there is more interdependence between these countries, and you see a clear fracture between liberal democracies on one hand and the authoritarian governments on the other hand, where there will not be such kind of collaboration. And a very small example for you is the US deciding what to do with the visas, revoking visas of Chinese origin students who have had any exposure to the People Liberation Army in China and who are studying in the US. They might be sent back for those kinds of executive orders that you might be seeing. So in the short to medium term, you're going to see less of a cooperation, more of a suspicion, and more of apprehension vis-a-vis whatever Chinese origin scientific endeavors collaboration with the US is. So this also spells bad news for all the multilateral trading regimes at a very higher level. The US is pulling out of the WHO. There is a fracture in the United Nations Security Council. There is a fracture in the UN. The voting is in strictly partisan lines. So you're going to see, this is bad news for multilateral regimes, but you're going to see good news for bilateral regimes, vis-a-vis trade regimes, and vis-a-vis international security regimes. I think there are, the second agenda, the privatization agenda, which was posed to me, this is a domestic Indian agenda. Do you want me to go into that, or I can just...
No, I have a follow-up to what you had said right now, and this is something that I would ask both you and Dr. Pandian subsequently as well. I'll ask you first because you just finished off this this issue regarding, to some extent, politicization of science, how the narrative, objective scientific narrative gets completely skewed depending on what the politics of a particular country or a region is. So, the overall question is pretty much like this. So, elected officials tend to disregard expert opinion because it's easier for them to tweak something for political gain rather than have objective policies and initiatives. How do you think we should influence I don't know if you can explain to them, how do you influence political narrative so that they can have objective scientific policy in mind and explain to them or convince them that this is for the general good of everyone, not just people within a state, a country, but for the entire world?
I mean, I've had, fortunately or unfortunately, I've had the honor and the privilege and also the experience of working with so many elected officials. I think politics is all about jobs, votes, and returning to power. And if a scientific opinion, for that matter, can be, it's all about community complex. And in my, in the tech world, simplicity is the most exquisite form of complexity. If you could digest a message to the politician to say, this is what it actually means, and this is how you frame it to your constituent and narrative. All he needs for a politician, ultimately, he needs to be elected by the people. And if he could convey the message to the elected people, for the people who elect him, that this is what is good for them, that's how he needs to sell a policy. So the art of selling is a policy, but politics is the art of selling that policy. But if I were to start on a cynical note, it would be any politics is immune to intellectual knowledge, and it's insulated from intellectual knowledge. And the politicization of any intellectualism is what sometimes characterizes a certain policy. And politicians thrive on something because science is sometimes science is never absolute, and they thrive on the corridor of uncertainty. It's like I vividly remember briefing a German parliamentarian on a verification system that we went to the Middle East, and I said, your sensors could detect blah 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 X Y Z plus or minus 4 dB, 3 dB, 2 decibel, and all that stuff. And then after all the briefing ended, he asked me one simple question. He said, "Is your sensor as good as my dog is? My dog's characteristics are." And how do you answer such questions, right? So, and then, but the other end, coming to, if I were to look at the Indian system, if you look at some of these things, the politicians recognize some of these things. If you look at the ISRO primarily, it's bureaucratically characterized in the Prime Minister's office. It's not like the Department of Commerce, Department of Trade, Department of External Affairs or something. It directly reports to the Prime Minister. So all I'm saying is politicians are very smart enough to engage a scientific input as and when it benefits them, and disregard and politicize them as it when it's inconvenient to them. And finally, and also in the United States, if you come, there was a JASON committee which was formed to assess the fidelity of the nuclear weapons vis-a-vis the United States. That was deliberately created to insulate it from the politicization of the whole nuclear weapons arsenal. So the JASON committee regularly briefs the Congress to say, oh, this is what the United States needs, and this is how its arsenal has to be modernized, and this is where it needs to be. That's why the United States hasn't, while the Comprehensive Test Ban Treaty may have been politicized in its purest form, but the United States knows where its arsenal stands vis-a-vis all these testing regimes. So all I'm saying is politicians, and last but not the least, I've had a number of conversations with Dr. Kasturi Rangan, and Kasturi Rangan once, I recall a very vivid conversation with him, and he said, when he was a member of parliament in the Rajya Sabha, he said, I walked out from the Rajya Sabha, I ran into Lalu Prasad Yadav, and in quotes, Lalu Prasad Yadav asked Dr. Kasturi Rangan, told him, आप राजनीति में घुस जाइए मगर core competency ना छोड़िए. So Lalu Prasad Yadav knew what core competency means. This was Dr. Kasturi Rangan's point. So meaning politicians are smart. They know at many levels what they are doing. They're happy to engage on scientific input. And as scientists and engineers, we have the responsibility to convey that scientific input to them, that if you take these account of scientific input, the collective good is always better than an individual best. So you try to find a way to sell it to your constituency that this is the right thing for you to do in the broader interest of the country than for your narrow interest in selling this to your constituency and winning your votes.
In a way, would it help if more scientists get into politics?
It always helps, right? So it's the more scientists get into politics, the less for the the less for more informed opinion.
Fair. Dr. S. Pandian, we just got the perspective of a policy bomb. He had a more cynical take on how to influence and what he sees the political class as. You've interacted with them in different leadership levels from a scientist perspective. How do you see the situation right now compared to, say, at the start of your career at ISRO? When it comes to interacting with politicians and how to influence policy, there are a few things that ISRO would like to do. How do you convince the politicians to say this is in the better interest of the overall nation, even though the cost benefit might not be apparent immediately, but it is in the national interest? How do you communicate with politicians in that level? Sir, I think your call is muted. Sorry. Yeah, okay.
See, also all of you are aware that the political system is there. The various work of people are sitting at the different levels. So right from the Prime Minister office to different level. But what all the scientists need to do is, if you look at and recall what ISRO has been doing for last so many years, starting from the Vikram Sarabhai to present leadership, we take what way the scientific effort will benefit the nation. We must ensure that we must put it in a language which they can understand. See, as Mr. Bharat told, the Prime Minister offices, many bureaucrats are there. It is our responsibility to go to them and convince them what way each and every program of the, for example, space, how it is benefiting the common man, how it is benefiting the strategic aspects of the country, how it benefits the various walk of life. So that way, we see right from the beginning, as far as ISRO is concerned, we have been convincing the top politicians, whoever comes there, and we have been getting whatever ISRO need to do it for the nation, and we have been getting, and I am sure that in the future we will continue to get, even in the pandemic scenario. I am sure that the government will support because of the end use of our scientific effort is very, very visible to them. So it is our responsibility to convince them that what way it is reaching the common man. So that way I don't see any issue.
I think that's one of the success stories, I think, as far as ISRO is concerned. They've been able to communicate and influence the political arrangement in the country to get most of what they wanted from the government, with modifying the narrative such that the politicians are able to understand and support the projects. One additional question. Recently, the government had decided to privatize a significant part of the space sector. Do you have an opinion on what the government got right with respect to that? What do you think requires more deliberation in that particular field? Does it make sense to privatize missions like interplanetary missions right now, even though the government, ISRO itself, does not have a tried and tested technology for, say, sending probes to Mars or other planets? How do you balance that with? I think last year there was an initiative to set up a launch pad in Tuticorin for the small scale launch vehicles. What do you make sense of the privatization focus right now?
See, look, this space is growing and demand from common man is increasing. Strategy sector demands a lot of things, and ISRO alone cannot meet this whole need. So it is high time to privatize. In fact, whatever you have mentioned, that the interplanetary mission, the payload, what need to be carried, what need to be done, that kind of thing has to come from the scientific community and private partners also. So, and even in our own ISRO contest, we wanted to give the whole PSLV to be productionized and launched from Sriharikota by private pros. And in fact, there are consortium of people coming forward to do this, and we are hand in hand working with the industrial partners. Actually, it is high time to induct competent private parties who can shoulder these responsibilities, and ISRO is with them to to help them. I am sure that in the years to come, the privatization of certain aspects of the space activities definitely is required. As the interplanetary space mission is one such a thing where they can use PSLV or down the line GSLV or GSLV Mark III. They can make use of it, and we are with them to help them. And it is essential. You look at the kind of demand what is required now in the pandemic scenario. So all are going for e-classes. We need to support them. We need to have more communication satellites. It is essential to go with the ISRO alone cannot do all this, cannot meet the requirement. In my view, it's high time to enter into privatization and slowly get into that and make sure that private partners are getting benefit out of this, and because of that, we can be able to meet the common man need.
Absolutely. I mean, especially considering the demand for several agencies, several demands from universities, even private sector for several satellite launches. which is why it made a lot of sense to set up the SSLV launch pad in Thoothukudi and then have that as a completely private operation. But I was very curious to see things like interplanetary mission. That takes a lot more effort than just launching a satellite up into either the low Earth orbit or even above. Should we make that distinction between certain aspects should be privatized and certain aspects should just be left to the government right now and not let out to the private parties yet?
No, there are some strategic sector we have to retain hardcore competence, and there are certain aspects that's as I told this we are using PSLV to go to Mars. Right. If PSLV is getting productionized in the private sector, then they very well can take it to Mars and beyond. So that way, there are certain strategic sector which need to be retained by the government or ISRO and DRDO. Other aspects where the interplanetary thing is more of scientific aspect, the hardcore basic science we need to explore, and those aspects definitely we can privatize it, and the launch vehicle per se, for example, can be used now the PSLV or the down the line GSLV. In fact, now private parties are building satellite for us. Whole satellite is built by private parties. India is growing to that extent, and I think we must capitalize on it and make use of the scenario and make sure that by this process the whole nation is getting benefited.
While you were the director at SDSC, did you happen to see industry interest in the launch area from private parties? I mean, we've always seen, as you said, satellites being manufactured by universities and private sector. What about the launch sector? Like, were private parties willing to participate, or did they show interest in setting up rocket technology?
You are right. Actually, the though whole satellite is built by private parties. In the case of launch vehicle, this whole rocket is not built, but there are many systems. Right, major hardwares are built by private parties like L&T, Godrej, HIL, all those people, and definitely they need to have a little more hand-holding, because certain aspect is with ISRO. We are opening whole SHAR facility for the privatization to make private parties down the line other launch vehicles.
Thanks.
There are consortium, people are coming forward.
And I think at one particular point, nearly 80% of PSLV's launch facility, the rocket was, I think, the components were manufactured outside, but assembled and essentially set up at SHAR.
Yeah.
The other thing that I asked Dr. Sengupta and Dr. Gopalaswamy, and we're starting to see, particularly as a after effect of this pandemic, all the countries are changing their focus to go indigenous and not necessarily depend on other countries for their technology for a series of aspects. Do you think that we already have enough the technology base for privatizing a lot of these launches, for example? Do we already have that? Or what I'm trying to ask is, if we privatize today, would we be able to see launches, say, 2 years or 3 years from now? Or is there going to be a significant development period of, say, 10 years from now, after which we'll see a private launch? Oh, sorry, this is for you again, sir. Dr. Pandian.
Yeah, I think it is maybe in 2 to 3 years time frame, it is possible to do it. Because if you take the major hardware, it is all built by the L&T, Godrej, and HIL, and now they are forming consortium to do the same thing. So from that point of view, I don't see any bottlenecks. I don't think it is like a 10 years time. Maybe 2 to 3 years time frame is a reasonable time frame for completely taking over PSLV by private parties and launching it, and continue to have the same heritage as what PSLV is achieving now.
I see. Okay. All right. I have a question for Dr. Venkatachari right now. I mean, we've been talking about the policy aspect of it and the political side of it and the government research side of it. You work at an institution with government research, academic aspect of it, and private institute as well. Where do you see the research focus for places like NIA changing over the next 6 months, say a year or 5 years from now?
Since we are actually we are actually, NIA is a kind of strange organization. We are like a trifecta of universities catering to predominantly NASA language, but we also have customers as Airbus, FAA, and we also do outreach. But I would say 70 to 80% of it essentially caters to government research or government funded research, either coming through universities or coming directly through NASA to us. So in that regards, I think the funding scenario may not be too drastically different, because often these funding cycles are based on long-term goals. So they have a certain lead time in mind and they start funding towards that. Of course, if the Congress doesn't pass the budget and for some reason they'll have to remove some extra quota, then these fundings can be taken away, but usually it doesn't happen. So these are long funding cycles. Usually you're guaranteed for 3 to 4 years and more fundamental in nature, so that it doesn't vary too much with some new pandemic or anything like that. So in that regards, I don't see as much a change. But often, even though our funding levels may not change, often the milestones of the project can be tinkered around with it. For example, like I think some of the focus for aeronautical research might switch now, because with these big planes being retired, for example, Airbus has said that they're not going to no longer manufacture A380, things like that. So you might again go back to focus like single aisle kind of vehicles and stuff like that. So to make them more efficient and to meet the new environmental regulations and so on, now the focus suddenly might switch to smaller planes, which might need a completely different paradigm in terms of design and things like that. So the funding might change its position slightly, but these are all like minor changes compared to things like, I mean, these are always in the pipeline. It's just that one might get pushed higher on priority and one might get pushed lower on priority and things like that. But as in a big scale, it may not change much. Of course, the funding coming from private industries to us, that might take a hit. For example, Airbus might decide that they're better focused on like doing, taking care of the manufacturing side of aspects and things like that, and not so much on fundamental research. So that funding might come down. But even within the US, the funding from private industries is still a small part compared to government funded research, especially in an area like space and aeronautics. So there we may not see too much of a shift.
So right now, like if someone were a scientist in a private research lab, for example, how do you think they should like retool their skill sets to the changing dynamic of, say, funding situation, for example? Would you see more funding from biomedical firms and, say, epidemiology related research? So there'll be more, for example. How do you see people changing their skill sets to the changing dynamic of industry and the government as well?
I mean, as a researcher yourself, you're quite aware that like the only constant is change, right? And within research, I mean, we dwell on changing directions all the time. We like that. We like the curiosity aspect that often takes us in different directions.
And it's important to keep changing as well.
Keep changing, because it's not a change for change's sake, but often by slightly taking detours, you learn a lot more. Like you get a different perspective on your own research. So from that end, I think most research have always, at least coming from academic background, you see professors always writing proposal grants to different agencies. Always has to happen in an era like, for example, say aerospace right now, right? In the last 2 to 3 years, the number of papers that have been published on machine learning as applied to aerospace has gone up tremendously. Machine learning as an area has been in existence for like maybe 30 years, 40 years. Neural networks has been in existence. It's just that it needed the Go program to make that breakthrough and defeat that Go champion. And then from Go, it morphed into AlphaGo. And even though it is still only proven in very limited areas, people have already seen that, hey, this is something which I can benefit from. And maybe like we are right now in an era where this might take off. So suddenly now everybody has jumped onto it. I mean, as an engineer, I've never, I mean, like at least as a dwell too much on neural networks and how it may benefit me. But now I'm forced to look into it, forced to learn into what PyTorch or any of these TensorFlow algorithms can do for me, get to know the nitty-gritties and see how I can start tinkering with it. So we are constantly retooling ourselves to even survive.
Is there a message in that for faculty and educators in this line, rather than just focus on one particular line of teaching?
I mean, that's been, at least like when I was doing my undergraduate in India, that has been the major restriction, right? I mean, we are like, I went to mechanical engineering school, so I was pretty much, in the first year of college, I did take courses in physics and chemistry and everything. But after that, I was just hunkered down in my department and didn't even actually have so much of a cross-pollination between some of the other branches. Whereas now, like, you know that. I mean, that's why actually in India, you need more like a university setting rather than an engineering school setting, where you're only talking to engineers. You need to be talking with humanities, you need to be talking with doctors, you need to be talking to chemists. That way you kind of see flow of ideas across disciplines, and also probably I mean, the future is all about multidisciplinary collaborations. I mean, right now, any big grants coming from, say, the DOD or DOE within the US always needs at least 5 different PIs coming from different universities with different backgrounds, trying to put together a big package so that as an overall, you can deliver something. A simple example would be something like, say, the supersonic aircraft which people are trying to design now. I mean, Concorde has been retired for a while. The biggest hurdle in supersonic flights was not the design scientific aspect itself. It was more to do with humanities, convincing people that this is not too loud that you're going to be disturbed, or it's not going to kill fishes, or it's not going to kill the birds, and things like that. So a bulk of the scientific or the money for these grants actually went into doing humanity studies, psychology studies of people, how they'll react to these things, rather than the aspect of just flying at supersonic speeds. So for that, then you need to tap into other communities to get a more holistic view. So that also actually makes a case for having these collaborative or multidisciplinary research aspects. And I think that's one aspect where India, or even like Japan, for that matter, has been very rigid in its old ideas. They haven't embraced the challenge of collaborating across or spreading.
The way I see that happening here is when people come out of colleges and academic institutions, because of the lack of availability of employment in that particular sector, they start to diversify after getting out, rather than be trained within an academic environment where they can develop skill sets in biology, fluids, or whatever it is that they want to learn. But they're forced to do that training outside of that proper framework, which I don't know if it is a very productive environment at all. I don't know if the quality of someone who comes out and learns independently would be the same quality as an environment where they are able to learn and are exposed to multiple streams of study in a more curated setup.
I mean, the point you brought up actually makes, like, for example, the current scenario with COVID. I think people might have read in news about the NASA JPL lab coming up with a ventilator.
Right.
I mean, think of it, ventilators, it's like, it's like essentially artificial lung kind of thing, right? So we think it's easy for engineers, maybe NASA rocket scientists, it should be pretty easy, that this should be doable. But then what apparently they did, the chief engineer who designed it actually said it was like a kind of light bulb moment for him, because he realized all the things he knew in rocket science doesn't apply to these things, because these are such low speed flows, and which we are often not dealing with quite often. So they had to go talk to the doctors, and then the technicians who operate them, to kind of understand how to even do these things. So it was pretty much like back to school for them. But then they did, like, once they saw the angle and then putting all their experiences together, they could quickly come up with that. So having these kind of experience as part of your training in undergrad makes you more agile. I mean, agile is, IT world always talks about agile technologies and things like that, but for every engineer that's important.
I think humanities training will also instill a sense of humility as well. I have just a personal opinion. Okay, this is an interesting question for you, especially since you're an expat in the research area who's living elsewhere. Now, India has a huge talent pool with expert capabilities living abroad. And right now, a number of nationalistic policies by governments in the US, the UK, and several other countries are kind of going very focused on hiring people within their own countries and not foreign nationals. So we're going to see, I guess at some particular point, a reverse migration of people with a lot of talent coming back to places like India. China has already been doing that for the last 15 years. How do you see the government adjusting itself for this sort of a talent bonanza? You suddenly have people coming in with a lot of computer science and IT expertise, even engineering, medicine, whatever the expertise are. We don't essentially have the infrastructure or the policy narrative to get them and keep them employed, rather than then come back and then go elsewhere once again. What do you think should the government and the policymakers think about? Say, if you were to come back, say 5 years from now, what would you look at in the government? Policy-wise, that would attract you?
I think the first thing, essentially, is rather than me making a full-scale move back, if I had the opportunity to say come every summer, start working, collaborating with some universities or national labs, spend a few months here interacting with the students and all that, it'll make it easier for people who have gone away from the system to get refamiliarized with the system and get their feet wet in knowing the circles. I mean, in research community, it's always about knowing your program manager. It's about knowing who to collaborate with, and so on and so forth. The scientific aspect is easier of the collaboration, but then you need money to do scientific research. And when you move to any new country or new city or new university, then you need to know the big people who you have to know so that you can facilitate this. And having something like a summer fellowship, inviting these people to come for the next few years slowly, might actually whet their appetite to even moving full scale back. From the policy end, I think what we need to see is India has done actually a good job in opening up a lot of new fellowships for people willing to come back. They even often even come to, at least in the US, they come every 6 months to come and recruit in big cities and so on and so forth. But these recruitments are often to institutes, say even the IITs, which are predominantly undergraduate teaching institutes, not as per say a full-blown scientific research university or something like that. So the incentive then trickles down, or reduces. So we need to have world-class research facilities across. It's not enough you have elevate the few NITs, IITs or something like that. That still only serves the undergrads who are eventually going to not even stay within India, probably, for that matter, or go and work.
So places like GNCASR, Jawaharlal, if they come out and recruit people, that would be more attractive for some.
More attractive, and I think what now, even within a lot of these private universities have expanded. These should also push the governments to allow them to recruit people. It shouldn't be okay, somebody always wants to go to IISc. You should go to some tier 1 university too, because their research can happen too. I mean, in the US, that's one thing they've always done. Even in minority undergraduate institutions, they make sure that the faculty are involved in at least some small fraction of research and expose their students to research. It doesn't matter whether they're in a poor neighborhood or in a very small state, they always get tagged down to be part of bigger proposals, and you get benefits to be involved in such things. So, I mean, a lot of people would be happy to move to a smaller town and have the luxury of living in big houses and so on and so forth, not fight with the crowds within the cities. But to have that, we need to have a healthy ecosystem that will allow you to do this. We need to advertise more of these facilities, and also somehow break the misinformation campaign that says bureaucracy is still a dominant picture. So people are hesitant to deal with that aspect. So if you can kind of clearly show that, and these summer programs actually would help you do that, you'll get a feel for what is happening, and you'll know that, hey, this is not the India I left 5 years back, 10 years back, or this is not the academic setting I was used to, and things have changed. And eventually people will move back. I think that's what China had.
Once you set something like that, it'll have an avalanche effect and more people will start
exactly.
back.
I think China, that's what they did with their 5,000 scholars program or something. Like essentially, of course, they invited the top 5,000 scholars, what they considered, and gave them a good fellowship, come every summer and teach and do research in a university. We can essentially take a leaf out of that book and do that.
I think what you said would be very useful for both the policymakers here, as well as researchers and students who are, say, in the UK or in the US or elsewhere, who are looking forward to coming back at some particular point. Yeah, thanks.
I mean, I would like to add one more thing. It's usually the researchers are not there for the money, so it doesn't take too much to convince them to move. Yeah, so it's like all you need to show is like you have a healthy environment, feeding, doing research, then people move there.
Very true, very, very true. Okay, so I have one last question for all three panelists remaining over here, and this is something to do with ISRO predominantly, especially after all the privatization moves that have happened recently. Like, what do you see would be the role and the purpose of ISRO in the coming years and coming decades? Balaji, you are answering right now. Just finish off, and I can go to Bharat and then finish off the Dr. Pandya.
Well, ISRO is like a great vehicle for motivating, youngsters or the general public. Like as Dr. Pandyan was saying, it's easier to show that, or the politicians that, hey, this directly benefits the common people. It's a good vehicle. In fact, I would say it is more like a poster child for on which fundamental science can cling on to, or it's like a mothership, because fundamental science is less sexy. It's not easier to convince people that, hey, this is something good. This is going to take 60, 70, 80 years to mature, but trust me, this is going to benefit you. And people are not convinced with those kind of aspects. Whereas
more like an NSF kind of a role in the future?
I mean, those kind of researchers, essentially.
Yeah, National Science Foundation kind of.
National Science, something like that. Whereas, something like any space program has a bigger visibility on that front. I mean, you see, and it's more immediate. I mean, the payload they might carry may not convince you, as you were asking, how do they gain from looking at the moon of Mars?
Right.
It's not very evident to a common layperson who's trying to get food and things like that. But still, it's still a very good platform to instill inspire people, or even have a fantasy. It's always nice to see that, hey, I will someday be able to fly to moon or fly to Mars. I may not afford it, but the possibility is always engaging, and that gives you hope and to cling on. So from that aspect, ISRO is very important. And the other aspect is because it's been established now with, we were celebrating Satish Dhawan's 100th centenary birthday, right? So in the sense, it has a longer tenure in terms of how a research establishment should come into picture, or how to establish itself. And it can have valuable ideas for smaller research agencies to benefit from insights or some gyan they might have accumulated over the years on how to put a very successful research agency. From that angle also, I think it will be very useful. That's what I see it as.
Bharat, what do you think about the role of ISRO in the coming years, decades, maybe?
ISRO, of course, obviously has had a key role to play in the last 4 or 5 decades. I think there are three main lessons or roles that ISRO has played and will still continue to play. And I think my colleague, Dr. Pandyan, alluded to this in saying, he kept repeating, for us, it's to convince the politicians about what ISRO has actively contributed. And if I were to frame it and look back at one of the statements that was made by Dr. Satish Dhawan when ISRO was in its infancy, was essentially how technology could be applied to the development goals of India as it pertained in 1970s. And those goals still remain to the Indian public, because ISRO is predominantly funded by the Indian taxpayer. So time and again, the Indian taxpayer has to be reminded why ISRO is such an important organization. And there are 2 main areas where remote sensing and telecommunications, besides the scientific endeavors and scientific exploration that it has done, India has a huge population. It's connected the millions of people that it houses. And India has unique geography and is a country which is predominantly affected by natural disasters. It's a country that's prone to natural disaster. ISRO is one of the first countries to do tele-education and applications like telemedicine. So these goals predominantly will continue to say that. So which means what I'm telling you is essentially ISRO's role will be in the developmental goals of the nation. It is one of the premier scientific organizations that's largely devoted to devoting its scientific expertise and skills into the developing nations. The second most important goal that's been under-missed and under-reported and understudied is how ISRO is a beautiful business case. This is a high technology that a developing nation in the 1960s that was relatively poor, that successfully adopted. 40 years later, it is on par excellence, and it is counted as one of the success stories in space technology vis-a-vis as far as the developed world is concerned. So you talk of ISRO today in parity with much of the most developed spacefaring nations in the world. So how did ISRO come about from somebody who had no money to build a self-sustaining space environment? And this is a beautiful business case that could be studied about 3 phases of ISRO, from where it learned to, the first phase was learning by, the next phase is learning those systems and building those systems themselves. And the third phase is achieving that self-reliance. And now I would even portray the 4th phase as from a technology importer to a technology exporter. So much of, for not only for India, but for the India's surrounding neighborhood and much of the other countries in the OECD.
Global South. Yeah, the Global South.
Global South. I don't want to put that in very political terms, but I wanted to put it in very parity terms, is how you become from a technology importer to a technology exporter. That is the second case. The third case is ISRO's, from a foreign policy perspective, India's foreign policy has always been very, what I would call it as a very collaborative, engaging, by far, for lack of a better word, it's a non-alignment movement whatsoever. ISRO is one of the few cases where you've had a scientific collaboration healthy with the Russians as well as with NASA on a scientific level. So it's a non-alignment case, and today you have a SARC satellite. Despite all your neighborhood disagreements, you have used scientific technology for building bridges across the most difficult and sensitive neighborhoods. So I think these are 3 main areas that I think ISRO can teach the world in terms of how do you promote soft power. Just as Bollywood is so famous all across the world, I think ISRO is a famous story that is undertold and underreported in the rest of the world as well. So I think these are 3 main areas where I think ISRO will continue to be a mainstay of the Indian story. I think it's an Indian success story that's been largely underreported and undertold.
Thanks. And Dr. Pandey, what do you see as the role and purpose from someone who's been an administrator there for a long time? Where do you see, say, ISRO 5 years from now, 10 years from now, maybe 50 years from now? Oh, sorry, sir. I think you're muted again. Okay.
Yeah, I think first let me thank Dr. Bharat Gobalsamy and Subalaji. I think they very nicely summarized the role of ISRO for next couple of decades. What I would feel is, even if it is privatized, ISRO will continue to play a very key role in the cutting edge technology. If you look at this common man needs, keep on increasing in using the high-end technologies. And if this kind of pandemic situation, as you know, in Kerala, now all schools and colleges, they are starting e-classes. Already they started, but now right from LKG to onwards, they are going to do the e-classes and other thing. How do you provide this kind of infrastructure through space? So definitely is a huge demand is emerging, and I am sure that the tele-education and telemedicine in this kind of pandemic scenario is very, very effectively priced, and I am sure the common man need is going to increase in using the high-end technology. We in ISRO, we are ready to serve the nation by providing all the high-end technologies to common man. Even if you take the railway crossing or fisherman where he has to fish it, all those things we are able to link our technology to common man need. So it is continue to be there, continue to serve the country in all the aspects of the using the technology. I am sure that ISRO has got a very bright future in the coming years.
And also with privatization and a lot of interest in both launch vehicles as well as satellites, can also be a guiding hand for private parties so that they can progress faster rather than start to reinvent the wheel per se for many of these situations.
Yeah. That's once it is the transition will always take time. Once the transition to privatization of the certain things happening, and once it is smooth and the transition phase is over, definitely things can go fast. So the government or the common man side, the utility point of view, you have to define a bit long-term goals to the privatizers so that they can fund it for their infrastructure. Right now, that part of it need to be strengthened and reinforced so that private parties can come forward and take it and do the things in a fast-track way. Definitely, the transition is one thing, but later on, I am sure that it will benefit in the country.
Final random a sentence or two on what your message would.
Philosophy is never look at short-term things and make decisions. Have a long-term vision and march towards that. Along the way, you might stutter and stumble into different detours, but trust. I shouldn't say trust me because I've been only like 40 years old, so I don't have too much of an experience. But those detours will give you the most important lessons in your life. And when you look back later, those would be the most important changes in your life. And the other thing to have is have confidence in yourself. The area we've chosen, for example, aerospace. You have heard from all the panelists that this is definitely the future. This is an area that's going to be of very utmost importance for the next hundreds of years. We need to be able to go to colonize other planets and so on and so forth. So we are there for the long haul. And this is a very challenging field. And the skills you learn in this field is going to serve you no matter what, whether you decide to go into IT, whether you go into banking, or you're going to go into policy making. The skills that you developed in learning these courses and learning through this, working through this area will serve you very well. And I think you are of the same generation as me. Like when we were graduating, it was the same kind of crisis. It was September 9/11 happened. A lot of plans went disarray. I know I had a job and I couldn't get a job. And they rescinded the offer, so I couldn't go. And that kicked me into advancing my post-graduation efforts. So, like looking back 20 years from now, 20 years from then, like I got to go work with NASA, be at NASA Langley Research Center, which is the first NASA center, and so on. I never even imagined that crisis would have spawned this response. So don't look at too pessimistically. Have a very optimistic long-term vision and stick to it. I think just sticking to plans sometimes has great benefits. That's all I would say.
Great, thanks. Bharat, do you have a message for youngsters who are watching this?
Well, I think
even policy wonks who want, even youngsters who want to get into public policy and politics as well.
Yeah, of all places, I just want to revisit China again, as the whole Chinese saying goes, every crisis is an opportunity. You are in the midst of a pandemic. We do not know. I think I want to revisit some of those points. It's essentially you're in the midst of a pandemic, so you do not. It's very hard to predict because we still do not have the accurate picture, not the entire data, what this pandemic means, how it is. The financial world is still evolving. You look at the stock markets; they've bounced back. The stock market is always looking at the future. So nobody has a clear indication. There are hiring freezes across big companies in the world, but just because there are hiring freezes, there are also careers, like my colleague just mentioned, 15 years ago, 9/11 happened, and, but there was also no social media and the advent of Facebook, no Twitter, no kind of messaging, democratization of information. and the carry forward of information in such a way. So the youngsters today have much more career opportunities than just sticking to the traditional opportunities, so to speak. They could. It's all about how the information that you have, and in the intelligence world, we say something. Having intelligence is one thing, and realizing that you have intelligence is a completely different thing. So knowing what skills you have, realizing what you could do with those skills is a totally set of different issues. And with the markets that are prevalent today, I think the world could be their oyster, and they could make best use of what they have. So if I were them, I'd be just looking at, why am I not born 20 years later, and why was I born 20 years ago? This was a much better world for me to be in. They can shape the world, and that's what leadership is all about seizing the opportunity, making best of that opportunity, and seizing, can I be the leader in the world? And I think they have a phenomenal road ahead, and that's what I want them to see through this. But just don't stick to, sticking to plan, but also improvising on the plan and making the best use of it. If a road is blocked, then use the detour, and you can get to your destination wherever you want to be. And that you will have a rich life. And richness doesn't mean only in one sense. It's a variety of experiences that come for that richness.
I think all three of us are from the same generation, so having some level of dynamism and not compatibility, but some way where you can adjust with adaptability. That's the right word. Yeah, adaptability and adjusting to.
That's what politicians do. Even if Donald Trump, he just goes, he doesn't play to the script. He just adapts to the situation and he wins votes.
Absolutely. Dr. Pandian, do you have a message for students and young professionals who are watching this right now?
Yeah, I think they need not get disheartened. I am seeing that a very challenging picture is there. I think most of them, they should become a job provider rather than job seekers. Now, if you look at in India, there are many startups are coming up, and they are all doing very fast things. Even they are designing the launch vehicle, they are taking satellite, the startups are coming up, and all corners they are getting support, and I think they should make sure that they are, in fact, the environment is very conducive for this startup, and they should go for that kind of thing and quickly align themselves and adopt themselves, as Mr. Kovarsamy told, adopt themselves to the changing scenario. Future is very bright, and let me wish them all the best.
Oh, thank you very much, sir. I think you're 10 minutes over the scheduled end of the panel discussion. I'm quickly checking if there's any questions.
Sushil, I think you can go with our chat. There is few questions posted by our participants inside Zoom, and a few we have taken from YouTube and we have given. I think now audience can also, I think they can give their question in the Zoom.
While I look at that, I would like to thank all the panelists, Dr. Pandian, Dr. Sengupta, who had to leave early, Dr. Venkarachari and Dr. Gopalaswamy, particularly those who dialed in from the US. Because of the time zone difference. I think it was 3:40 or almost 3 o'clock in the morning for them. They've been very patient and very enthusiastic in giving a lot of answers to all the questions that were put up. Just looking at some of the questions, what are the opportunities? I think these are fine. Not sure if these will be useful for. Query to how to execute the project to start an aerospace startup. Okay, so I think we've addressed most of these questions in the panel discussions already. Since we're already 10 minutes beyond the end time, I think I'll decide to end this panel discussion. Again, I thank all the panelists for participating in this one, and please hold on. There are 2 more panel discussions that are lined up. One which involves people from industry. They'll give perspective on the situation that they are seeing, as well as some opinion on the economic side of it. And later on in the evening, we also have another discussion with panelists from academia. So, thanks very much. Thanks, everyone.
Thank you, Sushil, for the excellent job of all those questions and things like that.
Good.
Very nicely moderated.
Thanks.
Thank you, sir. Thank you so much for Sushil and all the panelists. I think all the Indians are rebacked in this panelists, I can say Balaji, Bharat, and Anita, as well as our audience. So it was well. I think they have given lots of ideas and suggestions, and on the post COVID-19, also like the overall the glimpse about space and defense program. Definitely, I think we can even minute and we can able to through IEA and IEEE, we can even send it to the respective policy makers. So from the narrated points. So thank you so much for all the panelists of our first session. So I think it is an international online conference on the challenges and opportunity on especially on aeronautics, astronautics, and aviation. It is organized by Institute of Engineers, Tamil Nadu State Center, and IEEE of India. So it's almost, I think we are on time. May not be like, I think another 15 minutes we are much faster. So we have almost 120. I think the second panel and the third panel will be starting up. So I request all the participants and audience delegates who are in Zoom as well as in social medias of YouTube channel and Facebook. Everybody can be back around 1:50. So we have an interesting session from the panelists of industry. So they are going to talk about the aerospace industry, especially we have Sri Praveen P.A. Damodharan and Mundiratnam and the other panelist of Java, I think one more panelist, yeah, sorry. So they are going to be joining around 1:20. So hope so. I think that's the industry panelist. So from here, research and academic, how the industry going to take up the ideas from both of them, and we have versed profiles are there. So we will be back. I think now anyhow the Zoom and YouTube will be lined up with a few videos, so people can watch their home having their lunch, and we will be back by 1:30 sharp. Thank you so much for all of them to join.
Okay, let me once again compliment and congratulate the organizers for the excellent task being carried out. Thank you.
Thank you so much, sir. Thank you. So Bala, can you? I think we can post the video. I think this Zoom will be live. Not to view this, so they need not to leave.
In the early days of space exploration, food was mostly squeezed out of tubes and brought up in dehydrated packets. But today, we can have quite a variety of food. There's all sorts of things that we normally consume on Earth that we have here in space. We just need some minor adaptations.
And increase the volume.
In the case of sandwiches, we had to substitute for bread. So we decided to use tortillas. But why? Mostly it's because bread, of course, makes crumbs. When you eat them on Earth, the crumbs fall down to the ground. But here, crumbs are just going to float away. On the other hand, the tortillas that we use are heat treated and specially packaged in an oxygen-free environment to prevent mold from growing. They're packed in packages like this. And thanks to that process, a tortilla like this can be good for 18 months. So what we're going to do is we're going to open up our tortilla. We're going to get our peanut butter, squirt it onto the tortilla, get our honey, squirt that on there, and we will have peanut butter honey sandwich in space. Open up the tortilla, and voila, a weightless tortilla. Okay, I got one tortilla. Whoa, got away. Take my peanut butter, open it up. Can't rip it. Fortunately, we have space scissors. They're attached by each other so they don't go floating up. Take the scissors, cut open the peanut butter pouch. Peanut butter is open, squeeze it onto the tortilla, carefully. And now a little honey. Hey, I noticed something cool about the honey. Instead of the bubble sitting up at the top, because there's no gravity to make it float up, the bubble is floating in the middle. Okay, all closed up, and the envelope peanut butter and honey is ready to eat. Not too bad. Last piece of my sandwich. It's been pretty delicious. My hands are all sticky. Gotta clean up. We don't have a sink. We don't have running water. Gotta wash yourself up some other way. Disinfection wipes. All cleaned up. Nice and hygienic on the space station. This goes in the trash. Lunch is over. Delicious.
Things in space look a whole lot cooler than here on Earth. Welcome back, guys. Today's video is on the top 5 amazing space experiments.
How do you wash your hands with soap and water in space?
Number 5. Canadian astronaut Chris Hadfield experiments with a new pack of hand washing solution and demonstrates how to properly wash your hands in space.
It is no rinse body bath. No rinse body bath. And it's a bag with a straw. So now let's demonstrate. Okay, it's time to get clean. I'm going to squirt some water out. So we have a big ball of water, and you put it on your hand. And now I've got water floating around on my hand. And so I wash my hands up with that. And then grab a towel. And dry them off. So that's how we do it. We use no rinse. It's a special type of slightly soapy water, so you don't need to have a bunch of fresh water afterwards. You squirt it, you float a ball of water in front of yourself, and then you just dry your towel. And when you're done, we just tuck our towel somewhere to let it air dry so that the evaporated water gets back into the space station and we can use that water again. So it works pretty well. Sort of like, maybe sort of like if you were on a sailboat and you needed to get clean, you do it sort of the same way.
Number 4. An astronaut experiments with water physics in a weightless environment. It's really trippy to see how the water reacts.
Wow. Cool. Wow, I just love those oscillations. Here we go. Okay. Let's switch it to a black background. Yeah, so that's about 800 mils. So this should put it around 1100 milliliters. Let's see what happens here. Oh, just look at that. Look at that. Amazing. Just one of these jaw-dropping moments. Okay, here we go. To do it again, looking into the camera. Big pop. Here we go. Oh, right at the lens. I saved the lens. What I'm planning to do is, after this whole series of experiments, I'll suck all this water up with the syringe, I'll put it back in bags, and I'll use it to make tea with, so I'll end up drinking my experiment. You gotta conserve your resources when you're in the frontier. You don't get to see this as common, intuitive observables on Earth. And so when we go into a frontier, our normal Earth-home intuition no longer applies. So this rule works nice. And instead of putting a puff of air on it, I'm going to put a puff of water. This is going to have a lot more momentum in it than the air. Whoa, whoa. Oh, look at that. Cool. I squirted water through. Oh, isn't that cool? The water in the sphere went around the air cavity and formed a huge bubble. Wow. Oh, that is so cool.
Number 3. European astronaut Tim Peake tests how the body responds to being dizzy in space.
And does it make me feel unwell? So I'm going to get Tim to spin me around doing something that would probably make me feel quite sick down on Earth. So let's see how that goes. This could be the worst idea I've ever had. Okay, so yeah, I'll just go into a ball and start spinning. And then if you know, just keep go around. Yeah, on axis, that's cool. Actually, it's more provocative when you go off axis. Yeah, no, don't worry. Provocative's fine. Just keep it going. Yeah. Let's go for it. That's good. Okay, I'll see if I can I'm feeling dizzy. I'll see how quickly it stops. So it definitely felt dizzy initially, and now it's gone.
No,
yeah, yeah, completely normal.
Amazing.
Yeah, and again, I wouldn't be able to kind of just get off the fairground ride spinning that quickly for so long. So I feel normal. Yeah.
Crazy.
It is amazing.
Number 2. Students from Nova Scotia asked Chris Hadfield to wring out water from a cloth. The results are unexpectedly interesting.
We may have the coolest washcloths ever here on the space station. I'm going to show you. Here's one of our washcloths. Impacted. It's put down into this little tank so that it saves space. But when you open up a hockey puck, your hockey puck and turn it into a washcloth, it was compressed in a great big vise. Okay, so here's my washcloth, like a magic trick. Now I'm going to get this soaking wet, and then we're going to see what'll happen when we wring it out. Meredith and Kendra suggested that I do this in a bag. Bags don't hold water in space, so instead I filled a water bag because there's drinking water. And I'm going to squirt a bunch of water into this washcloth. Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. It's really wet. It's becoming a tube of water. The water is all over my hands. In fact, it brings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of has it stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had jello on your hands or gel on your hand, and it'll just stay there. Wonderful moisturizer in my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet. Great experiment, worked perfectly. Meredith and Kendra, congratulations.
To be number 1, U.S. astronaut Scott Kelly tests how various dyes interact with a floating ball of water. It's almost like he's creating a miniature planet.
Scott Kelly aboard the International Space Station. I wanted to do a little demonstration of these paddles. They're called hydrophobic paddles, and they repel water, kind of like a raincoat. But up here on the space station, they allow you to play ping pong with a ball of water.
Be sure to subscribe for more top 5 videos. And if you enjoyed this video, you might enjoy my previous upload on the top 5 amazing spacewalks.
Let's talk about space food. In the early days of space exploration, food was mostly squeezed out of tubes and brought up in dehydrated packets. But today, we can have quite a variety of food. There's all sorts of things that we normally consume on Earth that we have here in space. We just need some minor adaptations. In the case of sandwiches, we had to substitute for bread, so we decided to use tortillas. But why? Mostly it's because bread, of course, makes crumbs. When you eat them on Earth, the crumbs fall down to the ground. But here, crumbs are just going to float away. On the other hand, the tortillas that we use are heat-treated and specially packaged in an oxygen-free environment to prevent mold from growing. They're packed in packages like this. And thanks to that process, a tortilla like this can be good for 18 months. So what we're going to do is we're going to open up our tortilla. We're going to get our peanut butter, squirt it onto the tortilla, get our honey, squirt that on there, and we will have peanut butter honey sandwich in space. Open up the tortilla, and voila, a weightless tortilla. Okay, I got one tortilla. Whoa, got away. Take my peanut butter, open it up. Can't rip it. Fortunately, we have space scissors. They're attached by a tether so they don't go floating up. Take the scissors, cut open the peanut butter pouch. Peanut butter is open, squeeze it onto the tortilla, carefully. And now a little honey. Hey, I noticed something cool about the honey. Instead of the bubble sitting up at the top, because there's no gravity to make it float up, the bubble is floating in the middle. Okay, all closed up, and the envelope of peanut butter and honey is ready to eat. Not too bad. Last piece of my sandwich. It's been pretty delicious. Well, my hands are all sticky. Got to clean up. We don't have a sink. We don't have running water. You've got to wash yourself out some other way. Disinfectant wipes. Nice space station. This goes in the trash. It's over. Oops.
Good afternoon, sir. We are medical students from PS here, sir. We are very eager, sir. Here. Good afternoon, sir. We are very happy to see you, sir. What is the question, sir? What is the role of a medical student in building a strong nation? What is your opinion?
Well, healthy people build a healthy nation. Okay.
Some more.
Okay. So, but doctors, I want to ask you, how many hearts you have?
Single.
Huh?
One heart, sir.
You have got only one heart.
Yes, sir.
That is biological heart.
Biological.
But you must have another heart. What is that heart? Kind heart.
Kind heart.
All doctors should have kind heart and biological heart. Okay?
Thank you very much.
Things in space look a whole lot cooler than here on Earth. Welcome back, guys.
To become the first citizen of the country and to be the supreme commander of the armed forces. I think इससे अच्छा success story I don't think India में और कोई है.
At that time, I used to see in my class, 5th class teacher, in science teacher, his name is Sivathanu Pillai. He entered in the classroom and we used to see the radiation of knowledge from him. And the way he taught, my dream was got shaped.
In Indian history, at no time, have you seen, I will ask all of you, 2,500 years, any time in Indian history have we invaded any country, but reverse has gone. Reverse is, so many countries have invaded us the last 2,500 years. So our work, whatever we are doing for self, that is our national security.
I, Achit Jayadabudin Abdul Kalam, do swear in the name of God that I will faithfully execute the office of the President of India.
Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. Knowledge makes you great.
Our biggest driver is to create benefits to society, the scientific community, and the country at large. We do not rest on past laurels. We constantly look at the future and seek new challenges in everything we do. A lot of hard work goes into conceiving, planning, and executing the program in collaboration with various industries. Industry partnership has been a hallmark of ISRO since its inception, and we hope to continue building strong, mutually beneficial relationship with every step we take forward.
ஒரு மீட்டிங் ஆன்ல இருக்கும்போது இது ஆன் ஆகுமாப்பா? இங்க மியூட்ல தான் இருக்கு, எல்லாத்தையும் மியூட்ல போட்டான்.
Lander descent was as planned and the normal performance was observed up to an altitude of 2.1 kilometer. Subsequently, the communication from lander to ground station was lost. The data is being analyzed.
I want the young people to understand how to manage the failure. If you want to be innovators, I am going to give you what type of characteristic you must have. See, I have a feeling whenever I do something, I feel happy. You want to be you, not everybody else. By breaking the limits of their imagination, they change the world. Creativity leads to things. When he enters the classroom, my teacher, I see radiation of purity of life. Leaders should work with integrity and succeed with it.
So how did you become so great?
How did I become so great? That's the question. Yes, get up.
Who gave you bravery, sir?
Who gave?
Bravery. Braveness.
Courage. Well, you see, courage you have. You know, courage comes from knowledge. Hello, you fellow, ask a question. Look at me. You repeat with me, knowledge. Repeat with me, knowledge. Repeat, knowledge is equal to creativity plus righteousness plus courage. So knowledge comes from courage. Okay? The question, last question here. Last question.
The best brain of the nation may be found from the last benches of the classroom. Sir, could you please tell us what made you to believe in the last bench students?
Where are you? Repeat your question.
The best brains of the nation may be found from the last benches of the classroom. Could you please tell us what made you to believe in the last bench students?
Because I was the last bench.
Even I do, sir.
Sometime on the last bench. Most of the time the first bench. But I felt the last bench and everybody has got some knowledge. Every human being has got some knowledge. A great teacher, a good teacher, his way of teaching, his way of interacting with the student, he doesn't care whether you are the first row or the last row. For him, everybody a student. For her, everybody a student. Okay? So friends, with this I will say, all of you repeat with me that where there is righteousness in the heart, there is beauty in the character. When there is beauty in the character, there is harmony in the home. Who will give this righteous in the heart? Before 17 years, afterwards very difficult. When you reach 17, another plus 30, 3 years, 20, you can get righteous in the heart. Righteous in the heart only give 3 people. Who are these 3 people? Can you guess? Yes. You got only 50 marks under the answer of 100. Correct answer is father, mother, in a spiritual environment. In a spiritual environment. Why you are silent? Father, mother, in a spiritual environment. And the third person, the great primary school teacher. So friends, wish you all the best. God bless you.
One question.
Sir, how did you become so great?
How did I become so great? That's the question. Well, which class you are in?
4th.
What's your dream in life?
I want to become a singer.
Singer. Hindustani or Carnatic? Hindustani or Carnatic? Any music. Any music. Well, I don't know how big. You know, these are relative terms. So I personally believe you must have a dream. Say, I must have a dream. I must continuously acquire knowledge. Continuously acquire knowledge.
I must continuously acquire knowledge.
Hard work. Hard work.
Hard work.
And perseverance.
And perseverance.
One should not be not afraid of problems.
Not afraid of problems.
That will be successful. Okay?
Okay, one question.
So, wish you all the
Sir,
best.
one question, please.
And any question you put on me, because of time, what I suggest, a lot of people waiting, I suggest to you any question. You send a mail, apj@abdulkalam.com. apj@abdulkalam.com. If you want autograph also, send you want autograph. You will get the autograph with photograph and also answer to your questions. Okay? Wish you all the best.
Sir, I have one question.
Kalam's vision of developed India. Dr. APJ Abdul Kalam Vision 2020.
You must have a dream, continuously acquire knowledge, hard work.
Hey, good afternoon, Damo.
Hi.
Afternoon.
He wanted young children to dream high and have very high aspirations, as he always believed that one can achieve bigger only if one can dream bigger.
Hi, Damo. Hi. Good afternoon.
His very famous
I'm
quote
fine. How are you?
goes as follows: dream is not what you see in sleep. Rather, it is something that doesn't let you sleep.
Well, it's very fresh.
Dr. APJ Abdul Kalam's vision for India was to transform India into a developed nation by 2020.
Yeah, I'm trying to the
we are
video
still developing.
from my laptop.
In addition, we have been following the advice of the great scientists and have achieved a lot of excellence and advancement in area of technology. He has also mentioned that every civilization should have a vision, and it will be a failure without a vision. It was his idea of making Vision 2020, but he was such simple human that he did not want to take the credit for it, and he wanted it to be named as Vision of the nation India and not Kalam's vision. Every underdeveloping nations like to get the mode of developing nation, and every developing nation likes to grow the title of developed nation. Dr. Kalam always dreamed of taking this great nation, India, into a league of developed nations. With his great expertise and knowledge in varied areas, he formulated a roadmap to attain that vision.
So, welcome all our panelists. I think, sir,
With his
by
great
start for
expertise and
1:30
knowledge
we can start. I think
in
another
paradise
Okay.
area, he formulated a roadmap to attain that vision. He always ensured and wanted to empower and enrich youth, expertise, and government organizations toward realizing the goals of developed India by working on the distinctive profile of developed India by 2020. Every individual of this nation should work towards making India great. We should follow the below objectives, which will help us in achieving the visions laid by Dr. Kalam. Vision 2020, a nation where there is rural-urban divide has been reduced to a thin line. All parts of India will become developed. Vision 2020, a nation where there is an equitable distribution of and adequate access, energy and quality water. Vision 2020, a nation where there is agriculture, industry and the service sector work together with sympathy. Vision 2020, a nation where education
Yes,
and
Muni.
the value system are not
Do you have any presentation?
Canada
Yes, I have a
because of
small
societal
presentation.
or economic discrimination.
I also have a small presentation.
Vision 2020, a nation which is the best destination for the most talented scholars, scientists, and investors.
Yes, we need to
around
tell
the
him
world.
upfront so that we can share the screen.
Vision 2020, a nation where the best of healthcare is available to all citizens of India.
I'll send my presentation and download presentation.
Vision 2020, a nation where governance
We can share Muni directly.
I know we can share, but in case if there is some features, it's better to have a click from this side as well.
Yeah, definitely.
a nation totally literally remove the crime against women and children from acts, and no one in society feels alienated.
No, that Google has
Vision
shared
2020 that is prosperous, healthy, secure, devoid of
That is my
terrorism,
official mail ID, sir.
peaceful and happy, and continue on the sustainable growth path.
IGEN 2020.
Vision 2020, a nation that is one of the best places to live in and is proud of its leadership.
So anyway, we will keep this as a backup, sir.
Yes.
Yeah.
Vision 2020, a nation should develop places so that is a lot of visitors come to see it.
Gokul.
In
Yes,
conclusion,
I think all the
Dr.
four
Kalam's
speakers
key objectives for Vision 2020 have
take it
been
as a course.
highlighted above.
Kindly check it.
Yeah. It would be very beneficial if the students are nurtured at the school level on these objectives, as it will help them contribute to the nation law.
They can share their screen and all those things.
Yeah, sure. I think Bala is there. Dr.
Bala is
Bala
there?
Yeah, I think Bala can check once. I think. Is it okay?
Yes, so they can make it actually like so
Your name, IA name,
So I am in IEIT in SC only, sir. So I can join in my name itself. So one moment.
Can you confirm I'm able to?
Yes, sir. It's completely
yes,
viewable
yes, sir.
and it's perfect, sir. It's perfect.
Thank you.
Thank you, sir.
So what is the next program?
We are going to start with this. Who's speaking?
I am Pushkin, sir.
I'll join one minute.
Yeah, there is a session is going to start. Maybe another 2-3 minutes.
Okay, sir.
Gokul, I just sent you an updated version of things that Mr. Praveen had sent me.
Can I share it directly from here?
That'll be even better.
Yes, sir.
Yeah.
Yes, sir. Praveen, sir. Yes, sir.
That'll probably be the best.
Yeah, so this is visible, right?
Visible.
So is this you sharing it right now?
It is
Yeah,
me.
Praveen,
Okay,
sir is.
perfect. Sounds good. Okay, perfect. I was just curious if somebody else was sharing.
Right. I'll just share. I'll take it off share.
Only co-host can share their screen, sir.
Okay, sir.
Some might behave differently. That's why I sent you a copy in case.
Yeah, definitely. Sure, I'll just check it out.
Yes.
Sir, can you send it again? I think that is ice. A small country. Okay. Can you send it again, sir?
1 minute.
Gokul, what is your ID?
Yeah, it's IC.
Yes.
Triple A CON. Con.
IC AAA?
Con. CON. Con.
Con.
2020 at gmail.com. I think a small mistake. It's a conference CON, so it's a short one.
Right.
If everything is okay, I think we can start.
We will start.
Is all the people screen?
131.
No, their presentations able to screen it. There's no issue.
Yeah.
Okay.
All the speaker can share their screen.
Okay, fine. So,
Gokul, you please confirm.
We can go live.
Yes, sir. I just check it up once.
YouTube live should be on. Yes.
Yeah, we have received from our Praveen.
Now it's live on YouTube.
Okay. If I think our Muniratham sir mail has come, we can start. I think.
The meeting will start.
Okay. I think maybe Bala. I think you can take up, right? If the mail has come, you can just download and keep it if there's anything required.
In which mail ID, Gokul? So
this IC AAA Con
Okay,
2020.
okay, fine. I'll just look at it. One moment.
Okay. Okay. So, well, good afternoon to all friends. I think we have been getting inside the panel 2 session. So, it's an international online conference on the challenges and opportunities in aeronautics, astronautics, aviation, the new normal. So, it's all institutions of astronautics, aviation in association with institutions of engineers India Technology Center. Participants we can mute it. So, there are no disturbances occurring. Okay. Yeah, it's good. So I think very good speaker this morning. We have of Padma Bhushan, Sivathanu and Padma Shri VASAGAM. So they are like a well experienced knowledge aerospace sector and how it is going to turn up in the new normal. So definitely, I think there are like various functional movement as well as like how our India, the country, is going to lead into that. So we also had a eminent analyst from new normal in aerospace and defense sector. So I think they have given a valuable suggestions in all aspects what we were needed. Especially, I think we should thank our Pandian sir and Dr. Anita, Dr. Balaji, and Dr. Bharat, also our the moderator. So we are so happy, and it's a time we are getting inside the second panelist of the new normal in aerospace and aviation industry. So I think after this we have an academic, before we had an aerospace and defense. So they both are going to be like synergized by this panelist, because they need lots of ideas and innovations from the institution, as well as they also wanted to invest, or they wanted to do for the aerospace. This was a much more oriented program. This industry also can support it. So almost like an eminent panel. So we welcome all the panelists, also the delegate, and also the participants, organizers. So we are so happy because the 30th May 2020 in the COVID time we are organizing such a mega event. So I welcome the 4 panelists, Mr. P.A. Praveen, who is a Director of Aerospace, Government of Telangana, and Mr. S. Damodaran, Managing Director from Saffron Engineering Service, Mr. D. Umameshwar, Executive Chief Engineer from GV Aviation, and lastly, Mr. J. Muniratnam, who is the CEO of JM Consulting. So I'm so delighted to have this panelist, especially all are like from a top management. They had a wide experience. Definitely, I think the session is going to give a lots of enlightening. Their experience are going to be shared, and we are going to enlighten for the young generation. So before I think we go, I think the 4 panelists has already be there. So let me like welcome again once again, and we can get inside the panel. So it's with Mr. P.A. Praveen. I think he's a government policy maker. So before I start with our Mr. P.A. Praveen, so let me give a small brief introduction about our Praveen. So he is the Director of Aerospace and Defense Sector Initiative for the Government of Telangana. He leads policy development, infrastructure planning, skill development, industry partnership, and investment promotion initiative for an integrated ecosystem within the state. He is also Director of Banking, Financial Service, and Insurance, that is BFSI. He is credited with attracting global EOM giants, including Boeing, GE Aviation, Lockheed Martin, UTC, Safran, ELBIT, etc., who have established and expanded their manufacturing facility and technology center and skill development center in Hyderabad. He has also initiated strategic partnership with leading aeronautical university from the UK, France, US to offer world-class courses in Hyderabad. He works closely with the Minister of Defense, Minister of Corporate Affairs, Departments of Space, and Department for Promotion of Industry and Internal Trade hierarchy in the central government on key projects. He is also like a key person in the space cluster and various Center of Excellence within Telangana. He received Best State Award in 2018 from the Minister of Civil Aviation for the state with the most progressive outlook on the aviation and aerospace sector. is the perfect person to have on our panel today. And previously, he served in the private sector such as country head, the chief operating officer, and business head with HSBC, EFL, NCDX, MCMSL. He is also alumnus of IIM Ahmedabad and was the 7th Kurkul Fellow at the Department of Politics and International Relations at Oxford University. So such a versatile profile. So I think Mr. Praveen has agreed to be here. So thank you so much for Mr. Praveen. I think the government is already moving with lots of work with the government employees. So we are so happy, delighted to welcome you, sir. So I think Mr. Praveen can start about this brief, the introduction or what's going to happen in the new normal of this COVID-19, especially in aerospace and aviation industry.
Thank you, Kutul, for the long introduction. In fact, I'm sorry for that if it.
No problem. Yeah.
Beyond the time.
Yes.
So I would just like to give a brief introduction in terms of how the sector has been affected with aviation and aerospace. And while we can't negate the impact, the kind of disruption which is caused, and there is a long road to recovery, but there are a lot of positives which we can see, especially for the engineering students and startup ecosystem in the country. So, right. So, aviation is amongst the most COVID hit sector. As you all know that COVID has globally affected the. It's one of those pandemics which has affected all across the world synchronously, and this is probably once in a lifetime sort of situation, wherein the global GDP has fallen to 5% and is expected to recover in 2021. That is in 2 years of pain there. The impact is quite larger than the global financial crisis, 4 times larger than the financial crisis of 2019. But in case of the airline and aviation industry, it's like it is expected that the recovery would further take at least 2 more years, and expected to recover around 2023. Huge amount of loss which is taken, the sector has taken a hit in terms to the tune of 314 billion as estimated by IATA, and as you all know that for a couple of months flights have been grounded and just assumed operations. The Indian aviation is right now on a road to recovery. After 2 months of grounding, the country has started domestic airline operations with 1/3 of the flights starting last week. It started with stricter norms, price caps, new SOPs, etc. So, which also means that the road to recovery is fairly slow in terms of the profitability and how the sector will grow. Currently, it's operating around 20% pre-COVID capacity and it's expected to kind of progressively increase. But the plus point that we have is the domestic captive market is quite strong. So unlike other countries, say particularly the Middle Eastern airlines, more dependent on the overseas customers, here the market is expected to come back faster. And being a core sector, the government is expected to ease more policies and enable faster recovery of the sector. So that is with respect to aviation, but aerospace is nothing but manufacturing of aircraft and their components. So there is a ripple effect which is directly proportional to whatever loss we see in the aviation sector. Aerospace companies in India are part of the integrated supply chain, as you all know, so we share the same amount of impact of such global shocks. Many airlines have cancelled aircraft purchase orders and delayed both the deliveries. So the downstream supply chain also is affected in terms of many of them are expecting that even for their existing orders, they'll be delayed offtake and probably, they're still not sure about the future orders coming in. Industry-wide growth and expansion, because we've got a very long rally in the aviation space, and we have been driven by the numbers which both Boeing and Airbus have been quoting for the last 5-6 years in terms of huge number of aircraft to fly. Suddenly, there is it has come as a big dampener, and the expansion plans of most of these companies have come on board. Short-term global aerospace outlook is certainly weak. But then the impact on the domestic aerospace industry is expected to be relatively buffered as compared to other countries, because we also have a strong push for the defense sector manufacturing and space sector manufacturing, which is primarily indigenous and primarily internal to us. So that is expected to kind of grow the industry, the local industry, manufacturing industry for the next 2 years. These opportunities, I mean, there are opportunities in this crisis, as it was pointed out earlier, that during these crisis situations that, you can expect new innovations, new unicorns to come up. There's a faster pace of technology adoption, which is seen all across industry sectors. We've seen in the effort in the education sector. It was unimaginable that almost all the students would be in a position, we see a day where even the kindergarten kids are kind of looking at laptops and starting to learn. Entry barriers are going to fall. In fact, say for example, aerospace or space industry, it is perceived that the entry barriers are quite high for a small startup to kind of play. But today the situation is like the status quo has changed, and there is a wider acceptance for the innovative startups to kind of really provide solutions for the larger corporations. A large number of innovative startups are expected to emerge. See, as a side effect, probably a lot of layoff might happen in the industry, which can't be kind of avoided. But then many of these experienced technocrats, experts is likely to kind of start their own startups, and India is a hotbed of startups, and that means there's a great number of opportunities which might emerge as a result of post-COVID. Current scenario can also catalyze multidisciplinary research collaborations, JVs and institutional partnership for more local IP creations, and all these are expected to create new job opportunities for the country. It's a great time for startups. India still stands by its aim to be a 5 trillion economy. The government, both central and state, are encouraging entrepreneurship and innovation in all sectors. If you see the main theme, which has been driven hard, the Startup India, Make in India, the lately Atmanirbhar Bharat, and the various state innovation policies and initiatives are all directing you to a new future which awaits them. Large number of incubators, accelerators, corporate innovation programs, center of excellences, rural innovation programs, etc. are actively promoted by government and industry. Post-COVID, the world will throw up a lot of problem statements for innovative local firms and startups to kind of work on. So there's a large scope for more unicorns to emerge in India as a result of this crisis. Plenty of collaboration possibilities are also emerging to work with government. In fact, in this crisis period, both the center and the state has engaged a lot of startups to kind of really come forward to solve. In fact, a lot of ventilator manufacturing units have started in Hyderabad in a very short notice, and that's something that's quite encouraging. Even drones, there are certain startups which we have in T-Hub, our state promoter incubator, who manufacture drones, and they have been engaged for surveillance measures. They've already also been piloted for mosquito eradication and multiple other applications. We're also using AI solutions to check traffic violations and violation of the COVID restrictions as well. So this is a nice opportunity for a lot of startups to come forward with their solution to government and find more work there. So what are we doing to measures being taken in Telangana to redefine the new normal? We are kind of strengthening our skilling ecosystem. This has been an ongoing process, but then the COVID situation or the crisis has kind of given us a chance to prioritize our activities, and these are areas where we feel that our focus will kind of go more on. Short-term job-oriented skilling programs. There's an institution called TAS, Telangana Academy of Skill and Knowledge, which is tied up with all the engineering colleges in the state, and they've been providing job-oriented courses. Now this is going to be accelerated further. There's a lot of emphasis on internship for engineering graduates for the local industry. I think not just Telangana, I think all the state governments are kind of promoting these kind of initiatives. We have over the past 2-3 years have several global academic partnerships. Now these are primarily investment-oriented partnerships, wherein we felt that foreign OEMs, when they come into our country, they prefer the skill levels of their highest to be at a level which is at par with the European or probably the US level staff or the technicians are higher. So we had collaborations with Embryo, Aeronautics University, US, Aero campus in France and Stanford University, UK, to provide their curriculum, their short-term programs, certification programs, job courses in Hyderabad at low cost on demand by the industry. Similarly, a lot of center of excellences were promoted in the recent past. Pratt & Whitney Aero Engine Center, CFM Aero Engine Center, FST Simulator Center, which got recently inaugurated. Castle has got for aerostructures and all their JVs, they've got a training center which is kind of trained on 6,000 plus student candidates there. GE on aero engines. Adani's has set up a center of excellence in composites here. Kalyani's a center of excellence in microwave and RF technology. And there's a proposal from the Aeronautics Society of India to kind of again set up a center of excellence in aerospace and defense. So all these initiatives, both led by the government as well as from the industry, is kind of tuning towards a future wherein the students as well as the local firms will find more work to be done on the innovative technologies and opportunities which comes across. So to summarize my brief discussion, the COVID scenario is unprecedented. The short-term industry outlook is indeed challenging. There is but an accelerated push towards technology adoption. So digitization used to be a fancy term earlier, but now that is mandated. It is an imperative today for all the industry to take up. That means all the nimble small firms, even the tech cohort, which is originating from an engineering college, not even the graduates themselves, probably can find a place in the entire ecosystem to provide solutions. Disruptions are broad across sectors and a large number of problem statements are innovative start to solve. So this will trigger a lot of new content. It's also it is also understood that because there's been rampant firing in some of these sectors of the large corporations, the fresh hires probably might take some time. It is a very difficult time. So there's a good time for upskilling and sharpening experience, particularly taking up courses which are more in lines with the emerging technologies, be it IoT, robotics, drones, so students can help themselves with the skills and differentiate themselves in the job market to come. Government will continue enabling policies, skilling programs, infrastructure creation, and other ecosystem development initiatives. And we will emerge from the current situation stronger and more confident. Thank you.
Yeah. Thank you so much, Mr. Praveen, for your versatile presentations, especially how the government, the level of policy level change, how the industries as well as the academic can be correlated. So thank you. I think, as you said, I think it is a time that we are going to come out with very high spirit of competitive level. Definitely, as we can see the history behind, after the Second World War, I think Japan, now we can say they are in the topmost race. Same way after Spanish flu, similarly happens with Europe. So it's going to happen in the globally, and morely India is going to have a very big role, especially in the aerospace industry. I think lots of initiatives, especially Make in India. The Make in India, it's not only like industry can play a role, the government has to give lots of policy level change, and that you have explained it very well. So anyhow, we have lots of question answers with you. So before that, I think we can get inside our second speaker in our panelist. I think that is Mr. S. Damodaran, who is a managing director of Saffron Engineering Services. It's one of the, we know, like globally, the Saffron does lots of contribution in aerospace sector. So we welcome Mr. S. Damodaran on the panelist and a new normal in aerospace and aviation industry. So before I think Mr. Damodaran initiate this session, so let us see is a small brief introduction about him. So Mr. S. Damodaran is an accomplished executive management professional with comprehensive leadership experience. Local organization. He is the managing director of Saffron Engineering Services and has been with him for more than 15 years. He is with ESSI for 8 years, joining before Saffron, and with Ashok Leyland for 11 years before that. Having good understanding of profitable business models blending with cutting-edge technology, a continuous learner, keeping up to date with the business skill and technology, relevant to aerospace, defense, and other growing market, especially skilled in business development, strategic planning, budget control, and running business model of profit cost centers efficiently in multidisciplinary service organization. He is a Green Belt certified, Lean Six Sigma executive certified by Saffron University. He has been extensive management experiences of large projects and has been successful in building highly efficient leadership skill, conveying complex concept in understandable terms. Extensive international experience, more than a decade and a half years of business relationship with global opportunity, not only limited to Saffron, but also to the blue chip companies like Renault, Toyota, Volvo, and good track records of acquiring large business and winning confidence of customers and executive leaders and strategic thinkers, peers, and customers. Handled several end-to-end high-tech large turnkey projects, passionate in developing complex business models and covering transnational diverse team. He has a bachelor's and master's degrees from BITS Planning and management degree and certificates from IIM Ahmedabad, Bangalore, and Anna University and UT Dallas. I'm so happy he's also my alumnus. So I'm a master's from BITS Planning. So we welcome our S. Mahamodran, who's dealing about the engineering analysis on the Saffron, which is very important global companies in aerospace industry. So can I ask our Mr. Damodharan to take up a lead and give about his own session on new normal in aerospace and aviation industries in post-COVID, what's going to happen?
Thank you, Gokul. Hope I am audible.
Yes, sir. You are very clear.
Okay. We start talk with the support of a presentation. Let me know if it is visible properly.
Yeah, it is very visible, sir. It is very visible.
Thank you. I think we are all talking today in front of our computers in the respective homes. Little bit of details of the devil corona. You know, like it affects. You know, like the crust of the matter. You know, like mobility is the essence of any human life. This tiny virus. You know, like it started in a place, maybe China. Now it is transported through mobility. That means what happens is it does not have a boundary. It moves in a bus, in an aircraft, in a train. All it requires is a few seconds or few minutes with a short distance. So that puts us, all of us, to think very differently. Despite we have a lot of technology, this morning we heard a couple of speakers, panelists talking about from the space technology, defense technology. You know, still we are not able to find one or a robust solution. And since we are all coming from the aviation and aerospace industry, mobility is key for us. So it's a threat. But we need to manage this in a technology and strategic way. I think Praveen, my previous speaker, has given a good idea about, you know, like what is the industry going on. With the help of a famous consultant, Roland and Berger, they published a very nice article. I just borrow some of the slides from them. What happens to the industry? I just want to talk with some numbers and scenarios. This small virus literally shaken 115 years old industry. There is a sudden plunge in terms of air traffic. If you look at this graph on the right side, we were, you know, like steadily and progressively having our projects, commitments, growth in the air travel. It was very much fine until end of last year, even in January. So that means we were at in a trajectory of good growth. We saw some visibility up till 2030. So what happened to this because of this virus? Slowly and steadily, people stopped traveling. The aircrafts are grounded. The experts and statisticians are modeling what could happen to the industry. There are several theories. One is, some people said in the beginning that it's a small hitch. It can rebound anytime. The other theory is like there is going to be a little bit of a delay, maybe another 1 year. Some of the other experts are saying little bit very conservatively or with the risk, there is going to be a travel restriction and recession. Okay, so anything, like today we are in the third month of our lockdown. Like what we envisaged in the beginning of the lockdown, and now we are realizing we are sitting in a big risk, or it is true and real. So let me go to the little bit of a number. What we are seeing here is the 22,250 is the fleet strength by end of 2019, and we had a very ambitious order book or forecast which can go up to 35,300 exactly 10 years from now. This is going to be a story on the wall now. And the breakup is here. There is a opportunity for retiring aircraft. This will get replaced. Also an additional capacity. This is giving a fantastic market and opportunity globally. A majority of the portion in new development. Of course, there are some production challenges. There is a business for life extension. Last but not the least, it gives an opportunity for the entry into service aircrafts, which will go into maintenance, repair, and overhaul. So before this pandemic, we had a very nice industry growth, but the small virus has a little bit of a cornerstone and disrupt a little bit. Further to this, so I shown you in the beginning, there are different scenarios. This scenario was very, very light impact, which can only, limit close to 800 aircrafts. But that is not true. This could be a mid scenario. Scenario 2, that we are going to lose close to 6,000 aircrafts. But this is the worst case scenario. We are going to lose almost 10,000 aircraft in overall. That pretty much puts very close to where we are today in 2030. So I think I'm not a specialist, I'm not a statistician, but the industry experts are predicting the market could be, anywhere between here or more close towards the right. The companies like Boeing, Airbus, including Safran, GE, everyone, we are every day adding up the numbers and looking at. Of course, this is a scenario which is happening since the inception of the aerospace industry more than 100 years. So now how we need to recover from this? What are the impact analysis? Since most of the participants here are students, I want to focus more on what they have to do and what are the precautions for them. If you look at, we are almost in the middle of 2020. Irrespective of what is happening in the industry is slowly recovering in the semester 2. But as I explained, the lost opportunity is huge. So we need to really wait for the airlines to come up. Then they need to earn money. Then they need to renew their orders, because many of the orders are suspended or postponed. So we need to continue with our existing activities. The second one, this is also going to create some impact in the number of jobs, layoffs, which is pretty much started or going to start, and it will have its impact until mid of next year or towards the end of the next year. So what are we going to do? While the industries are having this kind of a scenario, what the young engineers who are aspiring after 4 years of engineering in several disciplines, who are aspiring to come into the aerospace market or business, what are they going to do? First thing is, they need to keep up their motivation very high. We are all humankind, we solved several technology geographical, human evolution problems. There are several ways to manage this time. You can take up whatever the job you have, or continue your studies, or move to startup, or teach. But like it's very important. Sometimes this kind of tough scenarios also going to bring some innovation or some change in opportunities. What is in the midterm for towards revival? There is a huge opportunities for MRO, because what happens is the grounded aircrafts uplifting, all of them has to be done. If not now you see slowly the aircrafts are coming into service, but that's a very meager percentage. We don't have enough staff on this. So this is a realization after the COVID. What happens is in real life, not all the aircraft systems or aircrafts go to MRO. Like it goes in queue, because the aircrafts are designed for 50 years. Most of the time it will be in the air. The second opportunity is, because of this virus, it is going to make a lot of legislation or changes in the standards of safety, both inside the aircraft and airports, which is very evident. What we are seeing today is a temporary measure, but it will go into aircraft or aerospace regulations very soon. And because of the sustenance of aircraft life, there is going to be a life extension possibilities, or whatever aircraft, if it is in the midlife, there is no chance, we should not leave any chance for the performance failure of the aircraft. So there is going to be a lot of focus to maintain the assets what we have till the end of the life. So we already saw that civil aviation will have several challenges. First of all, you need to run the airlines, you need to earn money. They will seriously think about the future orders. That will obviously put some reduction in demand or order cancellation delays. That will directly impact all the aerospace companies in the form of slowdown of manufacturing. It will also affect engineering projects. Of course, there will be an offset to this situation. People will have to spend some amount of money in R&D and innovation. This will be in demand. Of course, this is not going to completely offset the gap or the dent which is created in the current scenario. The chances for multidisciplinary research is very much in the cards. This morning I saw a couple of panelists have been stressing upon this. There's going to be a additional domain or science, like medical and health safety will fuse very much with the aerospace technologies. So here are some of the activities which are going currently in a very quick manner. So all your aircrafts, your HVAC will be completely revamped with the provision for different technology to disinfect the aircraft before the trips, during the trips, and several safety devices which is going to be live in the aircraft or at the entry of the airport and in the aircraft gates. So thermal scanners, how to integrate all of them, not only in the aircraft, which are also going to get connected with the passenger at his hometown or its home place. So all these things are definitely a one-time or a midterm solution. So coming back to this, how we need to reposition ourselves. For sure, the opportunity what we had in the beginning of the period was quite high. That's going to be a surplus at some point of time. But there is an opportunity in the life extension, maintenance, but it is limited. It's important that we should not get these skills get rotten. So we need to really see how we can uplift this capacity to work on other domains. This morning I was listening from the stalwarts and experts from the space technologies. They were saying there are a lot of programs are waiting for some resources. How quickly, with the help of academia, governments, and not-for-profit organizations, how we can help them to bridge these gaps. A little bit of a brainstorming what I want to present here. We are going to have a tough time, which is already started. At least it will last for next 12 months or 24 months. There will not be much of intake into the industry how it was last year. So that should not discourage the young engineers. They need to really use this opportunity in a different manner. Of course, there's a lot of help required. Let me try to explain this mind map. Because of COVID, the movement of jobs from academia when they complete the course to the engineer will be limited. There will be a hiring, but it will not be like in the past. So the industries will spend a lot of time in how to recover. Probably R&D activities also will be stalled. So maybe with the help of academia, with the government, we may have to create some kind of an extended schooling with the focus. There are two problems. One is the current scenario. Even with in the past, there is a question about the quality of engineers in order to meet the ever increased demands of the industry in terms of technology, because many of the time we have engineers, not scientists, but sometimes industry needs a combination of a fundamental science-based students as well. Especially aerospace industry is a niche industry, either in terms of materials, etc. So we need to really see how we take advantage of this gap, joining hands with the academia, industry and government, create some kind of an extended schooling, incubation, hands-on, and try to give some kind of a cost leverage and advantage to the industry to run the projects which are stalled for want of time, want of resources. Thereby, we can also create multiple routes for the students. They can join in skill development or participate in research laboratories to do some R&D projects, or some of the people, which is very much evident today. There are many startups, like they directly go from school to start some companies. So these are all some of the topics we need to really work. I don't have a like a crystal ball in front of me, but these are all some of the ideas I have. We need to take it to the right experts, both in the industry, academia, and government. We can solve this problem. As we were discussing this morning also, we should not worry about what is happening in the aviation sector. There are other domains still active. There are several developments or like in need of capacity. Space is one thing which definitely we need to look at, and we also combine this with like other disruptive technologies which can be definitely the engineers need to learn about these skills, because today it's in a very infant stage. So with the basic engineering, they should go and learn some of the additional skills, not going for a certificate program, but they need to master them and come back when the market is ready to absorb. This is one suggestion. I remember during early 2 decades before, there was such kind of a problem in the automotive industry and the aerospace industry. People used to move from the, like a coast to coast, from Detroit to Seattle, Seattle to Detroit. Some amount of, like a cross-skilling has happened, and such things definitely should happen in India also. This is the only way we can sustain and maintain our resources. So with this small introduction, I transfer the control back to the Gokul.
Yes, sir. Yeah. Thank you so much, Mr. Damodaran. So yeah, rightly you said there are so lots of out-box thinking should be happening right now in our aerospace industry. as well as I think multi-shaped, maybe like academicians, scientists, including engineering knowledge. So everybody has to step out to come against this new normal pandemic situation. Definitely, always we see that whenever there is always a fallen, it is a step for us to go up. So now the industry is looking forward the same. And you closed up with the automobile industry, I think some years for maybe like they are not now. And this pandemic will try to give us a new thoughts, new facilities, as well as like we talk about more on industry 4.0, many things. Definitely, I think all are is going to influence in our sector, aerospace sector, and this is going to give a lots of potential outgrowth. So we have, I think, another two more panelists. So before we start with our query session, so let me introduce our third panelist to our audience and everyone. That is, we have Mr. D. Umameshwar, who is Executive Chief Engineer from GE Aviation. So people always like they have a mind that is GE when they always think about it because that's a globally recognized on aerospace especially, and all the design and everything is a robustness. So we welcome our Umameshwar for this panelist. We are so much thankful for your presence as well as with other panelists. So before we start this session, let me introduce a small introduction about our Mr. D. Umameshwar. So Mr. D. Umameshwar is the Executive Chief Consulting Engineer at GE Aviation and manages over 700 members in the engineering team at Bangalore. His team is involved in design and development of next generation propulsion system, support of aircraft engine fleet, and development of customized digital and engineering software. He has around 28 years of experiences in setting up and leading large organizations in research and technology, advanced design, engineering, manufacturing, and CAD/CAM and CAE PLM domains. I think can we mute all of them except me? There is some disturbances there. Yeah, he joined GE Aviation in 2001, and since then he has led many leadership positions in aviation engineering. He is instrumental in setting up and leading 200 plus members world-class advanced technology team at Bangalore for GE Aviation. He played key role in the design and development of 7 new aircraft engine programs, covering full life cycle, particularly in architectural evaluation, and then cycle mechanical, rotor dynamics, thermal system, combustion aero, turbine aero, acoustic discipline, etc. Prior to GE, Uma held position with L&T for 8 years. During this association with L&T, Umameshwar led engineering of 25 mega plants for oil and gas, fertilizer, power, petrochemical, defense, nuclear sector, involving design, manufacturing, and commissioning. Umameshwar has set up and lead advanced design and CAE team in L&T, that is the largest manufacturing plant at Azira. He was one of the management representative to set up engineering services company for L&T. He also holds Masters in Mechanical Engineering and Aerospace MBA from Toulouse Business School, France. He has presented papers and publication keynote session in 120 plus national and international conferences. Umameshwar was recognized with many awards, and he is a member of SAE Aerospace Board, NAFEMS Board, NACOM, and ER&D Council, and Academic and Industry Body. So I think again we had a wonderful, versatile profile. So I'm so happy. I think this aerospace session, each and everybody is like a giant, we can say. So let me welcome our Mr. D. Umameshwar on the session. Sir, the session is for you. So you can take up an introduction as well as how this new normal is going to happen, especially after COVID in aerospace and aviation industry. So please.
Good afternoon, Gokul. Thanks for a very nice introduction. Am I audible?
Yes, sir. Very clear, sir.
Okay. So I think there is a lot of anxiety and a lot of questions in everybody's mind related to aerospace, so I wanted to really change the narrative and the context to 3 things. One, how are we going to survive? This is nothing new to aviation industry. We have seen in just last 20 years in my career, I have seen This is my fourth such disruption, so to say. So, and aviation industry has seen many such disruptions in the past, and this is far severe. Now that being said, how do we survive? The second thing is, from survival, can we think of revival? So that needs certain aspects of technology and the whole stuff I would like to, and then a lot of times we actually miss the real essence of aviation, which is about reimagination. The aviation industry is going to come out very strongly, and much more, going to be, friendly from the point of safety and health aspects. And this would be a history a few years from now. So, and I think it is very important for us to think of reimagination, because aviation industry is all about reimagination. It's about dreaming something, imagining something, and really chasing those dreams. And I think there are a lot of things that we can talk about from the point of academia, from the industry, from the government aspects, as to where we can really reshape. And we as a country can actually be the leaders when the situation emerges out of this whole COVID situation. Okay, so in a way it is like a past, present, and the future kind of a scenario. Make no questions about it. It's the COVID pandemic epidemic is the most severe. We think the projection is that globally it's going to have an impact of as much as 3% of the entire world's GDP. And it's going to take, I've seen some of the charts, but now it's very clear that aviation industry would take around maybe 3 years. Even some pessimistic views is that it will take 5 years or even beyond that. It's a possibility. So the question is, how do we really mitigate this situation? It's very unfortunate to see that we are going to have job losses. We are going to see many airlines, many companies not being there after some time, or getting merged or acquired. So it's going to be a very brutal time. And so I will talk about what are some of the things that the industry is thinking about to really come out and survive in this scenario. So and then the second thing is about revival, right? So there are several things, several challenges in front of us. So let me talk about these two things first before I share my thoughts around where we can really think long term and really take this whole thing in our control and shape the way we want. So in terms of survival and revival and also reimagination, there are three things which are the broad themes which we see as emerging. One is about the overall efficiency. There are so many aircraft which are parked right now, and companies like GE or Safran or other engine makers, we make money because of services. When the aircraft fly, when the engines come to service shop, MRO shop, that's where we get money. And now there is excess capacity. So how do we become efficient, and how can we reduce the costs? That's going to be the primary aspect. So when you look at the scenario, it's going to be very challenging. But the good news is that the Industry 4.0, the digital technologies which are there, they are going to play a big role. So far, the digital technologies have just entered into aviation. We have not seen the digital technologies really driving the outcomes of the companies. Now, when you look at the manufacturing or the airport operations or the airline operations, the entire ecosystem is going to be enabled by the digital technologies. So it's going to be a big game changer. So I think that's going to bring a lot more efficiency. And the good news is when of the whole industry and the ecosystem, meaning the affordability of aviation, the economics of aviation as an industry is going to be a lot more attractive for industries and for students and for the whole world to look at. So it's definitely a brutal time, 3 to 5 years, maybe, if you are lucky, maybe 2 years.
But short term, very, very tough. The only way we can manage is to drive cost out, to improve the efficiency, to improve the productivity. And that's where you see many companies are really busy in driving some of these. The second aspect is about revival, right? And I think the most important thing is about health, right? Is it really safer, to travel? And that's a very fundamental question. And aviation industry has seen this. I'll bring a narrative here. Aviation was always associated with safety. And if you look at the track record around flight safety, say 50 years ago, used to have a lot of accidents. Kudos to the aviation industry. If you see today, the most safest travel is by flying. There's a good chance that you will be hit if you are walking on a road than actually flying. That's the level of safety that the industry has accomplished in last 40, 50 years. Now, post 9/11, along with the safety, there was a security which was added. Is it secure? Around terrorism and all these aspects. And you can see now in last 20 years, the industry has very addressed this without really causing big disruption to the passengers. And safety and security are already given. Now it's about health. I'm pretty sure aviation industry will come out with some ways, and that's where I see a lot of opportunities for academicians, industry and government. There's a huge need for all the governments, the whole aviation industry to come together and draft some of these ideas and policies so that we can address this challenge. And I'm pretty sure it can be addressed. Because let's face it, which industry in the world has the best of engineering, the best of technologies that you can ever imagine? It's aviation industry. So this is the industry which is going to pioneer some of these, which are going to be applicable to rest of the industries. We just need to bring the muscle power, the mind power together and really address this. So that, I think, once we figure out, I think the industry is going to be back to where it is, and it might take a few years, but I have no question in mind that it will happen. Now, having said that, let's for we as the country, how can we seize this opportunity, reimagine the aviation industry, and push ourselves as the leaders, going forward. So let me tell, not many people know that the future of the aviation industry is around emissions. If you see, already the aviation industry is really grappling with a huge challenge around the carbon trading, the emission norms which are going to be there. How do we really address this? Quite simply put it, whatever emissions we have in, let's say, in 2019 and 2020, aviation industry has to achieve the same level of carbon emissions 30 years from now. And the projection is that the market will go almost like 4 to 5. We have seen the number of aircraft which are going to be there. The flying is going to be democratized. We are going to have a lot more smaller aircraft as a number of countries are going to increase their purchasing power, the GDP. We are going to see a number of aircraft flying. So how do we maintain the same level of emissions? It's a huge challenge already, and that needs reimagination. I'll talk about a few technologies where every one of us can think about. It's a long term, but that's where we emerge as leaders. So sustainability is a key thing. Noise, aircraft noise, as the communities grow. Take an example of Bangalore Airport. 10 years ago, Devanhalli was like a remote village. Today, it's part of the the city, and people are already complaining about noise. So there's no way we can arrest the civilization or urbanization, and airports are going to be part of the community. And how are we going to address the noise? Already the fuel cost is around 20-30% of the entire operational cost. Now there's a huge challenge around reducing the overall cost, as we know, for the aviation industry to revive and survive, and also viable in the long term to compete with other modes of transport. it has to reduce the fuel efficiency. And those of you who are familiar with the overall propulsion systems and the aircraft systems, you know that these are not easy to accomplish. We are thinking of 20% reduction in next 20 years from where we are already today. And today, the aviation industry competes with other modes of transport in terms of efficiency. How are we going to achieve? And the technological innovations, the ideas are going to be very, very conflicting. The solution which improves fuel efficiency may not be good from the emission standpoint, and vice versa. So I will share with you 3 or 4 key technologies which are emerging. One, around this whole sustainability using alternate fuels. Again, just to tell you, many of you may think, what is so big deal? We can have some kind of alternate biofuels or other modes or other fuels, and we can easily address. But let's think about it. If you have to produce those biofuels, what's the level of emissions we are going to produce? The factories are going to produce emissions in the process of converting this into biofuels, the land that is needed. So net, are we really going to solve the problem of emissions, or are we going to transfer from one source to another source? So we need to think of some solutions. Electrofuels. So there is a buzzword, there is a technology around sustainable, aviation fuel. We don't know what is that fuel, going to be, but there will be enough interest and need to go to look at that. That's one aspect. The second thing is around, electrification. We already see in automobile sector electrification happening in some way, and aviation sector is already pioneering. And let me give some numbers. 3-4 years ago, there were a handful of companies in the world who were looking at electric vehicles, electric aircraft. Today, there are hundreds. And I think this is the startup ecosystem which is going to pioneer. It's no more Boeings or GEs or all these big companies. It's about Google or Amazon or other startups which are going to pioneer this. And the good news is that the drone technology, again coming out of some of these small players, has already proven the viability of startups getting into this and making it a viable solution, both for military and civil applications. So staying on the civil aviation, we are going to see, this is my prediction, in this decade itself, we are going to see some of the smaller aircraft flying with electric aircraft, fully electric, up to certain size, maybe 4 passengers or 8 passengers. Up to say 20-seater, we are going to see maybe a hybrid, a version of electric and gas turbine, a smaller gas turbine, which is not going to pollute much. And then in the long run, the bigger aircraft are going to have more and more electric technologies. We may not replace the gas turbines or jet propulsion, but a good amount of power will come out of it. Now the thing is, today, if you have to fly, through batteries, it's so inefficient, it's so heavy. Because if you are carrying fuel, you are going to burn, and you're not going to have net weight, but batteries are going to weigh, motors are going to weigh. So what's the solution? So we have a huge challenge ahead in terms of electrification, and and that technology is going to pioneer other modes of transport, be it rail, be it road. I think we as a country, as an industry, can actually pioneer and take this to the next level. So that's about the electrification. The third and the most important thing is about digital technologies. You name any digital technology, whether it is blockchain, artificial intelligence, machine learning, big data analytics, the level at which the aviation industry is going to apply is going to be far more than what we can imagine. There are going to be a lot more jobs, lot more industries which are going to come out. Think about MRO industry. We spend a lot of time and money in training people, the skilled people, because skill is a big deal in aviation industry. But if you can have artificial intelligence in a way where the employees are actually trained on how to repair an aircraft or overhaul an aircraft, it's going to be a game changer. We're going to replace a lot of these errors, reduce the errors. So it's going to improve the safety. So it's a big deal. So we are going to see a plethora of these digital technologies which are going to be changing the very nature of the aviation industry. Okay, now this is about the industry. Let me spend maybe a couple of minutes before I wrap up about what a special time that we are in as a country. Because I know a lot of students and academicians, industry folks who are part of this session. It's very natural for us to see what is there in the immediate term, which is absolutely very, very brutal, as I said. But let's not lose the long-term opportunities. India is the fastest aviation industry already from last several years. We are also one of the largest military aviation, as a country, and we have a lot of brain power, digital power. We have, and around us, the Asia as a region is going to be the growth engine for aviation. It's going to shift from Europe and US to Asia, and we are in the middle of this growth region. Not just India as a growth country, but also Asia as a growth region for the entire aviation for decades to come. Now, can we actually change the whole narrative? Can we think of our own products? Can we think of our own aircraft? Can we think of all the skills which would cater to the whole world? Not just today. We just don't have anything. There's no commercial aviation product. Which has come out of the country. So it's going to present a huge opportunity. So my message to all the folks who have joined is to look at this from a little long term. And let me also tell you, this is not, definitely we are devastated by the COVID, but let's also admit that this is not going to be the end of the disruption. We are going to see disruptions, maybe far bigger than what we have seen, right? So if you want to have a career in aviation, the message to you is you have to be, you have to have a broad chest, and have the agility and the ability to adopt, and why so many people still pursue aviation is just because, as I said, aviation is all about dreaming big and pursuing. It's not so much about money. It's not so much about other aspects, and it gives immense satisfaction. So my request to all of you is to reflect on the short-term challenges, but also think of the huge opportunities that we have in the future to come. Thank you so much.
Yes, sir. Yes, sir. Thank you so much. I think you are on the dot. So what you have said about challenges and opportunity, it's almost like you are in the need. You said dream big. Definitely, I think the youth of our country is going to dream big, and they are going to bring back as a brain power, because it's more needed that of entrepreneurship, even a startup or even a make in India. So we are so happy you have beautifully narrated the challenges, especially on the sustainability and then electric aircraft or electric oriented aircraft, and moreover the digital technology. So yeah, the challenge we see, a lot of opportunities may open up. So again, much more opportunities going to come, because I think the current government is also opening lots of small airport system. So that is all going to give a lots of mileage to the aerospace industry. So we are so happy, I think, from your side, and you have given a lot of reach, imagination, survival, and overall efficiency. Yes, it's a keyword which we need always for the aerospace industry. Thank you so much. Before we get inside our QA, I think we have a last panelist who's waiting here, J. Munniratnam, who's the CEO of JM Consulting. So we are very happy to invite our Munniratnam on this panelist. He's our fourth panelist who is going to in aerospace as well as aviation industry. So before his session, a small introduction about him. So Mr. J. Munniratnam is the founder of CEO of Javanti M Consulting for the past 7 years. It is a multidisciplinary strategy consulting company for engineering, service, and manufacturing firms based out in Bangalore, India. He works with companies from diverse sectors of engineering that includes aerospace, automotive, and general engineering. They specialized in increasing profitability by integrating technology, culture across multi to suit the dynamic Indian market, with an objective to deliver practical and implementable solutions to clients, both domestic and international, covering both the manufacturing and the service sector. So he has more than 3 decades, which is equal to 30 years of experience in driving several patient management solutions in leading global organizations. He was previously a managing director of Assystem India for 6 years, the business unit at Geometric Software for 3 years, the vice president at Scandant Group for 2 years, and the country head of DSQ Software Germany in 9 years. Additionally, he is the chairman of SAE India Aerospace Board, a core group members of NASCOM Aero and Defense SIG, and was previously a management committee member of Indo-American Chamber of Commerce in Karnataka. So he is an alumnus of Hindustan Institute of Technology, Chennai. So again, I think all the panelists is like a much experienced and much who are can able to say what's going to happen in aviation industry or aerospace in the post-COVID. So may I welcome our J. Muniratnam to take up the session here.
Thank you, Gokul. In the meantime, thanks to the one of your colleagues to share the PPT, because I have some challenges in sharing the PPT. I just sent it to Karnakan.
Follow sir. Yeah. Follow sir will be sharing.
Okay.
Yeah, he is. Yeah, it is shared.
Maybe go to the next slide. Being the last panelist, it's very interesting and probably it is easy as well, because all my earliers with their rich experience have shared the current scenario, the global scenario, what is that we need to do, both from the government perspective, technology perspective, innovation perspective. So since we are all talking about so-called the pandemic and also the aerospace, some of the slides could be common. Probably those slides I'll skip it. Having said that, I just wanted to go back to the previous slide. This is what everybody thought, at least a couple of weeks back, COVID pandemic. Like Mahindra said yesterday, that he wants to get rid of the word webinar from the dictionary. All of us will strive towards eliminating the pandemic months and years. Yeah, next slide, please. Next slide. Yes, this is what our BrahMos also shared. There is nothing much I can add, but just wanted to let you know that plan is one thing, but finally the practicality is different. So the plan was to have 21K aircrafts by both the leading OEMs like Airbus, Boeing, and a couple of others. But obviously things are going to be different. Having said that, the fleet replacement may not be as it is projected here. It may also change. It was already discussed by. I'll go to the next slide. Again, I think it has been presented. See, if you look at worldwide passenger air traffic from 1945 to 1920, this is a report from ICAO. So far, as the industry has been quite often, at least once in 8 years, once in 12 years, we have been facing some kind of hiccups. For example, we faced oil crisis, then Iran-Iraq war, then Gulf crisis, then Asian crisis, and 9/11. 9/11, if you look at it, there was a big dip, and predominantly that dip has happened only in North America. Then came the SARS. But if you look at the SARS, the impact was more Asian side. But again, I think fortunately the global economy was going pretty well, and overall the economy was good, and obviously the Asian countries were doing a couple of years, so it was going quite well. And the financial crisis, again, it was around 2008-9. There was a dip. Having said that, these were all small hiccups, and the industry has kind of managed it. But now, if you look at it, there is a huge drop. As everybody says, we never expected or anticipated this. I'll just go to the next slide. The best part is there is a silver line. See, all of us in the month of January, we never thought things would happen, but from beginning of March till end of April or mid of May, we all thought, okay, everything is going to go for a toss. But if you look at it, mid of May onwards, there has been a slight recovery. Even this recovery, of course, we are only talking about the passenger recovery, but what has happened during this month of mid of March, mid of April, a lot of cargo flights were flying. I'm using the data here, but a lot of cargo flights have been had hundreds of cargo flights flown, which means it is not that the entire thing has collapsed. There has been some business, but we only look at the passenger cap. So let's go to the next slide. Next slide, please.
Yeah, one more.
Yeah, this is what has been shared by Ramo. I just wanted to touch upon briefly. So there are three different scenarios. One is that what they call V curve. We anticipate that recovery happens within 2 to 3 months. I think India is kind of starting that stage of the V curve. If you look at the last 2 weeks, there have been so many flights and the bookings have started. Somebody actually private family booking A320. Unprecedented, we all talk about unprecedented pandemic, but see that some aircraft just move a family. It could be one of the case, but I'm sure things would come back. I'm quite optimistic. So coming back to the other curve, which could be delayed, maybe 8 months, 12 months, 15 months. Some countries may take 15 months, some countries may take 3 years. But eventually we are going to go. Okay, next slide, please. So what is going to happen in the aerospace ecosystem? Because of this pandemic, all along, if you look at, I know one specific OEM which has evolved this specific process the last 25 years, was to bring in their suppliers as part of the programs. That's why they were calling the risk sharing partners. That was the journey all along from 1920 to now, or sorry, 1992 now. They've been integrating their suppliers as part of their programs. But what is going to happen once we are recovering or in the process of recovery? Two things are likely to happen. One is the OEMs, that is Airbus or Boeing or Bombardier, everybody, would actually start taking over mid-sized companies, smallest companies, for better project management, cost management, and quality management. That would happen if some of the small players are unable to survive financially. So that is one possibility. The second possibility is just below that, the consolidation by suppliers. It could happen that if some of the suppliers are strong enough to manage this pandemic situation, they will start taking bigger pie from the OEMs. They will also acquire a lot of smaller companies. I think this is likely to happen partly, but we have to see it could vary from country to country. For example, in Europe, some other countries are being supported by government. They would approach it, they would go by this approach. For example, North America is going to be different. So we have to see from region to region it could change. Eventually, industry is going to change the way we are going to produce aircrafts, whatever the little aircrafts for next 10 years. But again, it gets evolved, like our Uma said, technology will play a big role. Can we go to the next slide? This is what is a projection by ICAO in terms of the impact. What they're saying is that Aero is the least optimistic or least pessimistic and higher pessimistic, the right side. I just would like to look at the right side, Asia and Pacific, APAC region. The worst is about 38% of flights will be down. The The worst will be about minus 70%. If you look at it, it clearly demonstrates that Asia Pac will be in a better status than the rest of the country. For example, if you look at Europe, it is anywhere between minus 40% to 74%. What is going to happen in Europe, being the nature of the geography and the kind of transportation system they have, most of them would travel by personal cars, personal passenger cars, which means their dependency on airline industry would be far less and less. That's where the impact will be much more. What would actually help them is the actually tourism traffic. But the personal traffic will go down dramatically in Europe, given their infrastructure, rail infrastructure and road infrastructure. But America, again, a geographical challenge, they have to depend on aviation and the airline industry. So that will have its impact. Okay, we'll go to the next slide. This is with regard to, that is the traffic scenario. This is the domestic travel scenario. Again, if you look at the Asia and North America, 8% will be the down in terms of air traffic. About 430 million will be down in terms of passenger traffic in Asia Pac. And in terms of revenue, 32 billion in Asia Pac, billion in North America. The worst case is different. But what I'm saying is Asia Pac will recover much faster than Europe, and so is the case with North America. Let's go to the next slide. Okay, this has been already shared by my previous speakers. What will be the impact on the traffic? I would say it's about 50%, and we have to see in the coming months. Dramatically, it is going to be different because this is the report which was generated about 3 days back. And the airport will have about 50% traffic, then airline will be about 48%. Tourism is one of the biggest hit industry. Now, what is going to happen is people would travel only when they have to travel. It is not that they wanted to travel. It would happen across the industry. When I say across the industry, it is air industry or public transportation. You would travel unless it is extremely essential. This transport, otherwise you will take only private car. Trade, as one of our colleagues said, it is going to be reduced between 30 to 35%. And global economy, actually about minus 3% they're predicting. Let us see, but we will just go to a couple of other slides and discuss what is that we need I foresee as the impact in India. Here, so one is this, in the short recovery, what we have seen is one advantage in India and globally, fuel price, which consists majority of operational cost, has come down dramatically. For example, between last 5 months to now, it's about 40% cheaper. That means operationally they're becoming better, though the traffic is less. So that is going to play a big role. That is in the short term. In the long term, like the new technologies will evolve, and that will play a big role for our young engineers to work on new technologies. I also see impact of two things within India. One is the government of India has decided to encourage or change the policies towards MRO, which has been biggest bottleneck all these years. I'm quite optimistic about the new regulations, which will encourage more number of MROs, which means there is a quite tremendous possibilities for our young engineers to get into these MRO activities. That's one. Number two, government is also changing the FDI regulations for the aerospace and defense. Now recently they have increased from 49 to 74%, which means a lot of mid-sized players would start looking at India more for the manufacturing capability, the resource capability, and most importantly, to be away from China if possible. I'm not saying completely, but if possible. So all these things put together, I think will open up the market for the young engineers in the next 2 to 3 years to 2 to 5 years. It is not that scary, but for sure in the couple of months, it is not encouraging, but in the coming years, things will be dramatically different, and most of our young engineers will get employed. That's in the new technology areas. With this, I would conclude and go back to the panel discussion. Thank you, Murugan. Thank you, Gokul.
So thank you, sir. Thank you for your wonderful session. So I think you have touched upon all the even tourism and airports and aeroplane. So much avoided. I think the sectors, as you have already said, this maybe this cargo transportation is already on more. But how does the normal the passengers is going to take up? So thank you for all of you, all the panelists, for your wonderful introduction as well as your deep experiences which you have shared to us. So let me start with our Mr. P.A. Praveen. I think Praveen is a government employee as well as he is a policy maker. So it's if this as a Telangana, we have a huge human resources. It's also a talent pool living abroad. So and not all of them in the aero area, but this will be useful for policymakers in every state. How do you tap in that talent pool and encourage them to come back, maybe as a national state policies to several countries to hire their own citizen and make them to come back, and how we are going to be able to prepare this state as an aero state as a talent for us.
Thanks, Gokul. Yeah, I mean, I'm not sure whether any state government will be actively trying to pull back all their citizens from various countries, but these are situations where we expect a lot of inflow of people who kind of lost their jobs, so probably they want to come and resettle and start off from their home country. So we have, say for example, the IT cluster or the IT industry in Hyderabad is predominantly led by, or rather, the revolution started when a lot of people started coming from US after their stints there and setting up their firms here and then trying to kind of business from there. The aerospace side, we have thankfully a lot of anchor investors already settled, and that's something which is remarkable about the state. Boeing, GE, Lockheed Martin, Safran, Israeli companies, Rafael, Elbit, all of them have already started the manufacturing units, and that also means that we are already a way up in terms of trying to attract similar talents who have been working overseas in the same facilities or similar or their vendor group to come here and then probably restart their activity. So that certainly is there. On the other hand, with respect to the skilling side of things, say for example, the people coming from Middle East are mainly from the construction backgrounds. They may not be a good fit to the industry. There's a lot of skilling which will be required if you get a job in any of the core industries. We've identified 14 sectors which include precision engineering, aerospace, and defense sector. The other sectors being IT, healthcare, pharma, etc. So, depending upon the orientation and the background, we hope that over a period we'll be able to rehabilitate anyone who is coming back to the state to re-establish themselves. But it's again early days. Policies are yet getting evolved, depending upon the seriousness as well as the ability of the respective industry to absorb more workforce. We'll be kind of strategizing accordingly. Thanks.
Okay, Praveen. But if you see the government policies, especially the Make in India, can you say that what might be the existing and future effort to create this fertile ecosystem on incubators for industries or startup cultures or even an entrepreneurship?
See, Telangana, the current government, in fact, right at the inception itself, has given a great focus on the innovation ecosystem. We had kind of set up the largest incubator. T-Hub, which started off with 70,000 square feet facility, is now coming to T-Hub phase 2, 3.5 million lakh square feet facilities coming up.
where we actually are expecting a lot of startups to kind of come in. These we have again had multiple corporate innovation programs with the aviation majors. Boeing, we had hosted Boeing Horizon X and Boeing Build program in Hyderabad. Last year, we hosted Pratt & Whitney's accelerator program. Collins Aerospace is kind of working with us. During the Wings, recently we signed an MOU with Airbus Labs to kind of have particularly kind of encouraging startups associated with them to kind of work with the government as well as the industry. The specific MOU was for, again, as Uma was telling, the key need of how to minimize emissions. So we had a MOU with the airport for linking up startups who are in that space. Those are the initiatives which are done. Secondly, we are now coming up with the largest hardware incubator in the country called T-Works, which is 50,000 square feet facility, the largest makerspace. And recently, again, during Wings, we had demonstrated that a 3D printed drone entirely manufactured by youngsters in the makerspace in T-Works has flown there. And it shows that there's a lot of opportunity now coming up for young engineers to tinker with ideas and come up with solutions. There's also another incubator called B-Hub, which is exclusively for women entrepreneurs. Another institution called RICH, which is Research and Innovation Council of Hyderabad, which tries an institution which tries to link up the research institutions, the academia, as well as industry, to bring up essentially to see whether we can have a focused IP-oriented research, which the students can do, as well as the research institutions. Whatever is their ideal R&D which is there, whether it can be commercialized. Those kind of efforts have been taken up. So I believe in all these initiatives, a lot of these, both the engineers as well as the kind of firms can participate. We got a large number of experienced experts have joined as mentors in all these engagements, and many of them are also investors. Later turn out to be angel investors in this firm, and this we hope that will nurture much more locally generated firms and job creators.
Yeah, thank you, Praveen. I think Telangana is going to become one of the biggest aerospace park. We can see that the initiatives the government is taking up, and including you, the government policy makers. So it's good that there is lots of initiatives and movement is going to channelize for our younger youth. So I think we can go with our Damodaran, who is from Saffron. Sir, I think you said about the perspective on the aerospace industry is also on the students. So if you see, we are the one of the largest graduating class of engineers in the world. So that is almost approximately 1.5 million. So if you see there, even before this pandemic, there was a widespread disappointment in the quality of engineers and scientists graduating here. So how could you reset this education a change or a paradigm and introduce the quality info standards and develop fundamentally strong and confident talent? Yeah, is Damodaran sir is there?
Hello, can you hear me?
Yes, sir. Yes, sir. Please proceed.
Okay. So I touched upon briefly about this point. Since the demand was overflowing, to some extent we never bothered about the quality, because in India we are a billion plus population, and we need to, like a human factory, we need to do years of engineering, and they go into engineering and manufacturing because that is the need of the hour. But recessions like this completely will reset the whole scenario. We need to take this as an opportunity to go and enrich our fundamental sciences. Okay, so look at the Astro, how they started their organization. They started with almost nothing, ground up approach. But today they have a time-tested, hands-on approach, and they are able to challenge a multinational agencies which were existing several decades before. So it is very much possible Second thing is like we may have to revisit our engineering curriculum. This is what I'm trying to touch upon in my presentation. Why not we bring an extended practice wherein after 4 years of engineering, they need to work with an incubator or R&D labs. We should make it as mandatory. See, otherwise the situation like COVID will make us to do. So what we are going to see in reality today is next 12 months, there is going to be a log jam. Okay, the industry is not able to progress. They need to go back to their strategy drawing board. That itself will take 12 months. And even you cannot survive as a startup when this crisis situation. So we may have to go back to the new norm or a reset mode. This is not possible by individual organization. You know, like we need to join hands, government, academia, and the industry. Now, definitely they have time to listen to this kind of ideas. And second opportunity is we need to look at the quick wins. I discovered this morning that there are many programs in space or lined up for want of resources and the highly skilled people. Maybe as my previous speaker Uma was mentioning, aerospace got a very rich experience, proven experience, more than 100 years. And in the last 10 to 15 years, this kind of skills are very much visible in India. We are only using the skills not to the fullest level to support the global programs. It's time to rethink with the help of government and policies, how we can take some best practices from organizations like in the engineering, in the aerospace engineering. I think the need has come now, and we all tasted our air travel experience. There is going to be a need which is going to, what Muni mentioned, it's the right statistical information. We are less affected, the need is still there. This gap of the international aviation companies, while they are stepping back to restructure their way of working, here is an opportunity for countries like India to relook into our education system also.
Yes, sir. Yeah, thank you. Yeah, definitely. I think the standard of the education system should be improved. But I have one more, like on the based on the engineering analysis of the aerospace. So how can we like unlearn this prevailing industry culture, especially when this is a time when the conventional hierarchy systems might not be best suited to solve complex problems. So how do you see such a kind of systems from your eye?
Yeah, this problem to certain extent, we are not going to continue to work run-on-the-mill engineering jobs, okay? Because of the demand has reduced. This will also force the companies and the resources to go into, like an innovative mode. They need to learn how to create some kind of ideas, conceptualize them, apply for IP, go for funding, go from engineering to product, experimental basis. I think I saw the announcement from the government very recently, even during this tough times, they relaxed a lot of boosters for investment and make in India, also design in India, not only manufacturing, because we have mastered manufacturing, but we need to focus the similar approach for the fundamental IP creation in the country. It's an ecosystem, like it requires the big help of academia, because today, when I compare to 20 years during our days to today, the infrastructure is much better in colleges than in companies. So we need to rightly utilize them. They need to be challenged with the real life problems. COVID is the best situation today. How will you sanitize your aircraft? There are many companies quickly came up with several options, like a sanitizer from the pedal to clean up the aircraft and buses and trains. So that's a good start, but that's not going to solve the other complex problems. Electronics and communication is another area. I see there is a lot of activities happening in the India. We need to channelize these skills towards the aviation sector. So the third thing is it's time for us to relook into our syllabus and curriculum, because we are operating with the last 20 years.
Yeah, sure. Yes.
So these are all some of the corrections and changes to take away from the legacy.
Definitely, sir. Yeah, thank you, sir. I think I can just maybe like invite over Roma Maheshwar. Actually, you have given about lots of ideas on challenges and opportunity in your introduction session. But exactly like where do you see this aeronautical industries? Can we see this 6 months, 1.5 years, or 4 years from now?
Yeah,
maybe you can.
Yeah, so it's a great question. See, I talked about the reimagination and some of the technologies. So as I see, there are a bunch of technologies. For example, manufacturing. Right, if you see the footprint of India in manufacturing in aviation, it's very, very decimal. I mean, insignificant. We are net importer of lots of components and products. So let's take additive, for example. Additive would be a disruptor. 10 years from now, there are going to be industries and companies which may not exist because of additive technology. So we can, I mean, and it's not about just printing. Anybody can have a printer and print. That is not about additive manufacturing. Additive manufacturing is about design thinking. It's about reimagination. How can you combine, multiple systems? So that's a key aspect of digital, the additive manufacturing. It's going to disrupt manufacturing industry. I talked about different technologies like electrification, emission, fuel. There's a lot more around robotics, sensors, materials, which is a game changer in every industry, particularly in aviation. Right? So there's a lot more research and opportunities that we have. I just want to make one point which I missed. It's a well-proven fact. There's no rocket science, quote unquote rocket science, to recreate, another United States or Europe type of an ecosystem in India. It's well-proven. Anywhere you take a country like Turkey. In our wildest dream, we can't think that Turkey is one of the, most dynamic aviation ecosystem in the world. The reason is that the way it happens is government invests in creating the ecosystem. No company and no academic institute can actually bring in the kind of resources. It's the government which the money. It's like, you're creating a forest. We don't need it. We want fruits today, but I'm talking about, putting the plants, the seeds, so that one day it will grow to become a forest. And that's the approach we need. So I talked about a bunch of technologies, whether it's robotics, sensors, materials, electric vehicles, emission related, simply designing a jet engine in our country or our own commercial aircraft. We just don't have any of such product. I think once the government creates a mission to design, develop our own indigenous products, I think the rest of the things will fall in place. And there are a lot of things which we need to learn as a country.
Yes, sir. Yeah. Rightly you said. As you said, like government is has to play a major role. So, from your perspective, how you see this significant role in reviving this industry, or can this private-public partnership can initiate to bring back this aerospace sector?
Absolutely, yes. I know that's the mantra. Government creates the ecosystem. It has to have academia. It has to have the industry, and that it has to function like one organization. This is, if you look at these clusters, it's a well-researched aspect. The aviation, aerospace clusters all around the world, if you go, whether it is in Seattle, where Boeing is there, or Toulouse, where Airbus is there, or other developing countries, particularly in China, for example, they became they are going to have their own narrow-body aircraft, which is going to give a challenge to Boeing and Airbus. 20 years ago, they had nothing. They were in the same situation where we are in. But somebody conceived a small regional jet, and then they developed that, and then they developed. They are developing now narrow-body aircraft. Their game plan is to
design a wide body aircraft. So that's the kind of reimagination we need as a country, and then put all the players, all the stakeholders together, and government has to really invest, and they should not really look at 2 years, 3 years, 5 years. It will take 20 years. Let's understand. There's no country in the world which has designed an aircraft or an engine or anything like this in 20 years. 20 years is a miracle, right? They have taken 30, 40 years. So can we think of the 5th generation or the 6th generation fighter engine coming out of India? Can we think of the next big, innovation or a product for commercial aviation or business aviation? I think there are plenty of opportunities. I think we lack the imagination. We lack the long-term view. We always look at, the short-term needs. So, and those of you who are in aerospace, you all know the kind of challenges, the kind of intellectual challenges that it can provide. There's enough work that can be done in all these domains.
Okay, so yeah, which means I think you are trying to say that there should be a good initiative in R&D rather than focus on production alone.
Can you repeat your question, Gokul?
Which means like the initiatives in R&D should be more focused rather than the focus on production.
No, I think we need everything. We need the whole ecosystem to be created. We cannot be just a manufacturing country or a engineering services country. This is very unfortunate. The IT job, IT sector is an accidental innovation. If you really ask me,
yeah,
we had lots of trained people, and there no other way. They picked up whatever jobs came in the way, and they got into Y2K or whatever IT. But I'm pretty sure if we create this ecosystem and create the vision, and the products, we would be able to develop large number of highly skilled technologies and researchers and manufacturing, everything in our country. We just need to create that vision and mission, and then fund those, and then forget about this return on investment for the next 10, 15 years, and we are going to see a forest coming out of it.
Okay.
And I just want to make one last point, Gokul, just because you talked about innovation. Not many people know that, in aviation, GE has set up one of the largest, it's the largest investment in terms of high-end technology center anywhere in the world. It's one of the largest, it's the largest of GE. Every year we have 400 patents for so many years.
Okay.
And we design the future of flight. What's going to fly from 30 years, 20 years from now? We are actually doing that work now. If a company can do it, why a country cannot do it?
Definitely, yeah. So I think we have lots of pool talents are there. It's only like we have to convert it. So thank you so much, our Umameshwar, for your enlightening your answer. So we have a last panel. I think Mr. our J. Muniratnam. Sir, how do you see this commercial aviation operations is going to bounce back from this new normal or COVID-19?
I think if I see, how do you see this in terms of time frame? I think it will take about anywhere between 8 months to 24 months to 30 months. Because as I said earlier, people will travel only if they have to, not that they wish to. For example, tourism industry is all wish list. Okay? Attending a marriage can probably become desirable. Attending an important meeting is the most needed one. So that way I think all the wish list travel on, and it will take a long time to come back to normalcy. That's about 15 months to 28 months, again depending upon the economy of each region.
Okay, yeah. Okay, you might be seeing this enormous challenges in the industry. From the point of view of retaining this talent and running talent operations, do you see how this is going to be there in a new normal time?
Yeah, it's a very interesting question, Gokul. First of all, if you look at the companies, now they are actually looking at it, what is the resource requirement they need to focus? Because of the innovation and all that, they would focus on retaining the right talent, but they would also focus on reskilling. That's what like all my other speakers have mentioned. Reskilling will be an important factor for the aerospace sector. And for example, let us say MRO. In MRO, the people are going to maintain the areas in which passengers are getting in touch. The whole focus will change. For example, SAE has got a standard for aircraft interior cleaning. Now those standards will get modified, and all the MRO engineers will have to undergo through that new processes. The SOP will change, which means retraining will happen. I think it will evolve in terms of the way we do it. Secondly, if the MRO, as mentioned earlier, if the MRO industry is grow in India, we will consume a lot more engineers in India. Similarly, the FDI, the new government has initiated FDI in the aerospace and defense sector. That will also consume a lot of engineers. Now what would happen is the people, let's say now any service industry have retained to 30% of their technical resources. They would be the first people to get a job with the reskilling. It is not that immediately they'll fit into the right job, but they'll have to undergo some kind of customized training so that they're rightly fit into the job. For a couple of months, I'm sure it'll have an impact, but I think it'll come back to normalcy.
Okay. But this aviation sector, how you are seeing this impact on this cargo transportation? So is it like anything going to have a very big, or like nominally we can able to change?
See, now the cargo, it's a very important question. The cargo today, the entire cargo is focusing on the medical equipment and pharma equipment. That will be the topmost priority for all the countries, and that will be the biggest cargo factor. The next comes, for example, now, food will be the least industry. You know, for example, countries like Italy, France, they export a lot of wine. So those things will not be part of the cargo system now, because high-end restaurants are available, are open for next couple of months. So that will not be that will be the last priority in terms of perishable goods. Pharma will be there, and next will be the auto components and aero components and industrial components. I think that will play a big role. It won't come back to normalcy in the next 18 months. See, for example, as of 2016, we had something called the CTK, that is cargo ton kilometers. 19 billion CTK per month was transported. By 2020, it was touching 22 billion CTK per month. It has drastically reduced. To come back to 20 billion per month, it will take 15 months.
Okay, great, sir, great. I think all the panelists has given a lots of wonderful answers. We can able to see that we are almost nearing to our time. So from this new normal, I think we have got so many new words also from the panelists, like reimagination or rethinking, made in India, many things. To sum up, I think we can start seeing from all these challenges and the opportunities. I think the academic and industry should join together. That is going to be a new digitalization, or like a new solution is going to give. Say a public-private partnership. The government has to bring a lot of policy level change in order to bring more privatization inside the public, so that a lot of investment and manufacturing can grow. The third very important, the digitalization. So now everybody is talking about, even I think now airports started operating. Yes, Bangalore airport, I think completely they made digital. So whenever we want to travel, I think without even touching our hand or anything, that's a revolution has started. So wonderful. I think there are lots of points that's come up, and as starts with our Praveen, he was saying about the aerospace sectors in Telangana is going to replenish, and lots of investment, big giant companies are going to come. So that's one of the wonderful opportunity. And the next level, we see our Damodar. He was trying to say about the new syllabus has to frame up, and the talented, young, dynamic people are there, and the youths are there.
definitely I think they are going to have a relook on the syllabus, especially in the aerospace sector, to maintain the quality as well as the reliability of the sector. The very important what we try to see from our Umameshwar sir, I think three things like the sustainable and then the new electrifying and digitalization, which is again going to bring up lots of changeover in the current the servicing sector, how it is going to grow up, as well as the new manufacturing of the fifth generation. So everything we have, but hopefully I think government level as well as the key research, we can say the academically the IITs and ISU as well as labs, they have to come forward and creating a lots of change. And with our Umame sir has clearly pointed out, I think the impact is going to be there for only for a few more months or a year, and that is always like a paradigm change, we can say. So now we are seeing always a down. It's going to take up lead to the climbing up and make this sector something so different. I think we can open up a few question answers from the audience participants. I think a few people already pouring up a few questions from the Zoom chat. Let me check up. We have any queries for speakers now. So we have one thing from Mr. Avinash Kumar. I think he asked that more practical work will help to understand and enrich the education system rather than just only focusing on theory, or both should go parallel. I think it's open to all panelists. I think any of them can give their views.
Can I first answer Gokul?
Yes, sir.
Absolutely, Avinash Kumar Yadav, what he said is a well-known fact. You need the practical experience. I think of late we see a lot of education institutions are setting up a fairly good amount of labs with the help of industries. I mean, far better than what it is today, but certainly is there. In addition to that, just from SAE perspective, I just wanted to highlight that the SAE is organizing few practical events where students can participate. For example, Domo, myself, ran a program called Manovegam, where engineers were given an excellent opportunity to design aircraft and fly it, and they were mentored by practicing engineers from top-notch companies. Okay, I think students should take proactive approach in finding out such opportunities, and they should get involved, because we cannot consume the entire, a lot of students. The people who are very proactive, who are interested, they can always find an opportunity like this and exploit it.
Yeah. To add to Muni, I framed this a little bit differently. Practical to be treated as experimental, because we need to make product to fly. It's not going to happen. You're on mute, Damo. Sorry, I was saying more than practical, we need to go in an experimental approach. I'm a big fan of ISRO, because the time when we started engineering today, though we are in automotive and aerospace industry, they are able to cover the full cycle. That means the requirements are, of course, we need to have a theoretical knowledge to simulate, then go into experiments from concept to technology levels. This is missing for us in India. There is no one organization covered the full cycle, because aerospace industry, you all know that it's not happened overnight, hundreds of years. So we need to focus on take one topic, one system to the full life cycle, understand the dependencies. Many times the design cycle will be successfully completed, but when you go to manufacturing and when you go to testing, you have to come back to the drawing board. So it should be a hand-in-hand approach we need to take. I think there is a lot of improvements happening in the ecosystem today. You have a lot of colleges, they themselves have some test laboratories. If they create the directory of test facilities, even one college can share with the other rather than everyone is trying to compete.
Okay, yeah, rightly you said, sir. I think there is another queries from Goyal. So why mechanical engineers are preferred over aerospace engineers? Maybe aerospace industries, I think.
I don't have such distinctions because aerospace require all sorts of engineers. We need a lot of computer science engineers today to run programs. I just want to share my thoughts. I think this is absolutely not true. I'll tell, I think Damo and other folks from the industry can very well relate to this. Today we take all engineers, in fact, mostly mechanical engineers in our country because we don't have, to the previous question, the good aerospace engineers with the practical knowledge. Really, it's not about theory. Aerospace is all about making your hands dirty. People put their passion and everything behind it, making things. That's what we lack. Making things, designing things, and then testing. That's what we really lack, and that's a big apprehension from other countries. If they have to really give us the next level of opportunities and jobs and roles. So I think it's a big problem. But coming back to this bias, there is absolutely no bias. The fact is that today we take all engineers, mostly mechanical engineers, and give them 2 years of training. We have a program called Edison, named after our founder, GE's founder Edison. And those 2 years, we train the mechanical engineers and everyone the aerospace related trainings. They will go through a lot of classroom trainings and also practical trainings and then the assignments. We don't have to do if we have good aerospace engineers. So don't think it's the industry is biased. It's all about aerospace.
No, I would like to add something here. Say, for example, particularly in Hyderabad, I have come across several industries preferring mechanical engineers because the kind of work which they're getting here is aerostructure. And that too on a build-to-print format where the designing is done by someone else. But the actual work which gets across in the aerospace companies are actually mechanical works. So for that job content, they will specifically hire mechanical engineers. But yeah, I mean, from an engineering perspective, the job content needs to be in fact software and engineering as well as GE engineering. I'm sure that you will kind of hire a lot of candidates here. But in Hyderabad, I've actually seen that, and that's something which we probably need to get over a period. The preference to mechanical engineers.
Yeah. Okay. I think one from Balaji. I think our previous panelist is asking, what is the scope for urban mobility in India? Are there policies being framed? Maybe I think Praveen also can answer for it as a policy maker.
We have a different group which is handling it, sir. There's a transport group which kind of, and we are in the process of having setting up a mobility cluster here and encouraging industries to come set forth. But I'm afraid I can't kind of share too much because I'm not aware of the developments happening there.
I can share. So it's a great question, by the way. This is, very recently, I think somewhere in January, we just had a policy for drones. It may look very trivial, but when the drone technology was invented almost like 10 years ago, it's a disruption. But then, what if every drone is flying and how do we track and is it really safe? There are lots of questions which were raised from the point of safety, from the national safety standpoint. And then, many countries have actually prohibited, including United States. And very recently we had, in India, we had a policy for drones. So the answer is yes. As we see urbanization, urban air vehicles, eVTOLs, we are going to see government coming out with policies to enable. And I call this as air taxi. This is what probably is the future, right? You like a car, you actually fly with 4 or 5 people. There's no problem of, safety, security, checks, etc. But then it needs, tremendous cooperation from all the countries to put policies in place and then address the challenges around how do we track and then make it safer. So I'm pretty sure it will come. I know
there are lots of evaluations going on, even including in our company, around what if certain things fail, etc. So just wait for some time, but it will come. As we figure out the urban air mobility, it will come.
Yeah, okay. Thank you. Thank you. So I think maybe I think we will end up with this is the last question we can answer. What should do final year students of aeronautical engineers in the 6 to 8 months they do? Because no job scope should be there in this time. So they need an advice from the panelists.
See, one thing, what we are facing is not a erosion of a domain. It's a temporary setback. As you know that many of the veterans are going to retire soon. All of us are not going to be in this position forever. Especially, you look at the technologies. No new programs has been announced by Airbus or Boeing. We are all only doing a refresh now. Of course, on the engine side, there's a lot of focus happening. Like Uma said, the carbon footprint reduction is working like automotive, in aerospace also. All your computer systems are becoming more and more intelligent. There is a lot of need for the next generation engineers. The only caution is, in the past, they are all very segmented. The aerostructure engineer will talk about only the strength of materials. Today, they need to be an electronic engineer because there will be a lot of intelligence and sensing is happen in the structure also. Health of the structure, and avionics is undergoing a big change. You know, like the aircrafts went missing. Some of the aircrafts, nobody knows today where it is. So that has imposed a lot of regulations change. So when these regulations, I mean, there's going to be a surge of engineering, manufacturing activity. So we should not connect with the present situation. Aeronautical engineering is definitely specialized. You know, like I'm a mechanical engineer, to learn software, but aeronautics is a very structured program that has really helped to uplift the country's technology foundation, either in space or aeronautical engineers. As Muni said, the opportunities, you know, like we are more focused on engineering outsourcing and contracted manufacturing. This should change. We should be autonomous. Even if we make a small system, it should be completely to be done here. So the recommendation for the aeronautical engineers, don't give up. It's a temporary setback. You make use of this to learn some of the new disruptive technologies. How to make 3D printing, how to design for 3D printing, understand the operational part of it, MRO, etc.
Gokul, I want to definitely answer this question because this is a very pertinent question even to employees. So I talk about 3 key skills which are essential. It's going to be the life survival type of skills for the foreseeable future, not only for aviation engineers but other engineers. The 3 key skills are, one is the system thinking. We always specialize by nature of the need in aviation industry, particularly to be a specialist. But the future is going to be more system thinkers. You need to be very good in one domain, but be able to understand other disciplines. Right. So, for example, if it is electric vehicle, you need to understand a little bit of electrical engineering. So, I would encourage the students to go a little deeper and also broader. That's particularly from a system or a product standpoint, number one. Second thing is about digital. Whether we like it or not, the future jobs in every discipline is going to be a lot more digital. Whether it is, and very strongly suggest to understand, learn the analytics, big data analytics, because it's going to be used in every aspect of engineering, including aerospace. And the third and most important thing is our ability to unlearn and learn. Don't think that once you are done your masters or bachelors in aviation, you are done with all the skills. No, every 4 or 5 years you are going to see new skills needed. So you have to be open for learning for a lifelong time, and then this is a very essential understanding that every engineer and every student need to have.
I would also like to add something that, as earlier, upskilling and finding every opportunity to learn is something which is there. I'll share from my personal example. I've actually changed several sectors. I never missed an opportunity to kind of really take up a volunteering opportunity or probably a job. And it always helped to kind of build up transferable skills in terms of, say, for example, today you're not getting a job in aeronautical testing. You shouldn't kind of really think too much in picking up a job elsewhere until the sector revives, because as and when the sector opens up, same opportunity will be awaiting you, but you will be prepared with much more additional skills, be it business skills, sales skills, or probably any of these complementary skills which will add up to your future job.
This time is up. Gokul? No, Gokul.
Hear you.
Yeah, I think okay, sir. Can you hear me?
Yeah.
Yeah, thank you. Thank you so much for all the panelists who could able to spend their valuable time. I'm so delighted that the panelists are wonderful. I think this 2 hours, how it has gone, we could not able to imagine. So we started with 1:30, it came to 3:30. So wonderful. Definitely, I think each and every panelist has given their experiences, views, and especially for the youth of our country. And even I am a chemical engineer, but working in ISRO. So even whatever the discipline we are there, so it's not so like our profile always makes us more ignition. Definitely, we will be going up, and this new normal is only for a time being. So definitely, a big breakthrough is going to happen in our country, especially almost 80% of the youth of our country is in the mid-age. So they are going to play a very big role. This 2020, always everybody, it's going to be a dream. So everybody was there in the house for 3 months or 4 months. After this, a big change is going to happen. That's what the entire globe has done. The environment is doing it. So definitely, it has given us some kind of a few rest. So we will be back. So I am thank all the panelists, especially Mr. P.A. Praveen, Mr. S. Damodharan, Mr. D. Umameshwar, and Mr. J. Muniratnam. Very happy to be with you all. So thank you so much. Anything to be shared, we can have 20 minutes.
Thank you, Gokul.
Thank you so much.
Be safe.
Thank you, sir. Thank you so much.
Thanks for all the students.
So we will be.
Thanks and all the very best to everyone.
Yes, sir. Thank you. Thank you. We will be in touch, sir. So with IEA and IAA. Thank you.
Thank you.
So, yes. So I think panelists can be there. I request our next panel, new normal in academic. So which is more interesting. I think we have eminent people from IISc Bangalore, IIT Chennai, and we have from MIT, as well as from a university from abroad. So definitely this is a third panelist. May I request our Karunagaran, who is a professor from Hindustan Institute of Technology. Also, I thank all our organizing committee members for to happen. So thank you so much. So let me hand over to Mr. C.S. Karunagaran. Karunagaran, please take up.
Yeah, it's a very good session so far, and we have just covered 2 panel discussions. And now we are into the academic panel, and I welcome all to this academic panel. So today now we have 4 eminent personalities across the globe with us, starting from Dr. Satya Chakravarti sir, from Professor IIT Madras, and also he's heading NCCRD lab at IIT Madras, and then Professor Santosh Chakravarti, Dr. Santosh Chakravarti from IISc Bangalore, and Professor Tyagarajan Thanigarasu, Dr. S. Thanigarasu, who is the head of Aero department from Madras Institute of Technology, Anna University, and we have our next professor, Dr. Kyriakos, who is the director of airworthiness of UG and PG, who is with us from Ireland, from University of Limerick. So I welcome you all.
There were a few slides which missed, and thank you for that.
Welcome you all, panelists. Dr. Satya sir, are you there?
Yes, I am there.
Yeah. So it gives me a very big pleasure to invite Dr. Satya sir, and it is always a delight to be with sir during events like this, especially knowledge sharing. And with this, I am introducing sir. Dr. Satya Chakravarti sir is a professor of School of Aerospace Engineering at the IIT Madras. He works in propulsion and combustion and researches different aspects of combustion in gas turbine and rocket engines. He heads the National Center for Combustion Research and Development (NCCRD) at IIT Madras. It is the largest of its kind in the world, with a 5-story building that houses state-of-the-art facilities on combustion research, including a 33-meter tail microgravity drop tower. He also heads the Center of Propulsion Technology hosted at IIT Bombay. He has been awarded the HAL Prize for the Best Undergraduate in Aerospace Engineering in 1991, the Young Engineer Award by the Indian National Academy of Engineering in 2003, the Young Faculty Recognition Award by IIT Madras in 2009, the Dalmi MC Arkham Award by the High Energy Material Society of India in 2009, and DRDO Academic Excellence Award by the Defense Research and Development Organization of India twice in 2009 and in 2016. He received his BTech in Aerospace Engineering from IIT Madras and went to obtain his MS and Doctor of Philosophy both from Georgia Tech. After a brief postdoctoral stint at Georgia Tech, he joined the Department of Aerospace Engineering in IIT Madras in 1997. Dr. Satya Chakravarti is the director of the E-Plane Company, a startup company aiming to make a new breed of aircraft called hybrid aerial vehicles for vertical takeoff and landing, as well as long-distance flight to carry goods and passengers, ultimately leading to air taxi operations. And he's also director of Astro, a startup company aiming to produce micro gas turbines for decentralized power generations. Shareholding advisor and to Agnicool Cosmos, a startup company aiming to make mini launch vehicles to launch micro and nano satellites into space orbits. He's also a director of X2 Fuels and Energy, a startup company aiming to convert any kind of waste into municipal solid waste and agri waste into crude fuel. So it's a company which makes a waste into a crude oil, and also he also involves in efforts to set up the Center for Precision Agricultural Technology at IIT Madras and to form consortium of industries and R&D institutions for making aircraft engines through 3D printing in India with governmental support. So with this introduction, I take privilege in inviting Dr. S.R. Chakravarti sir. Sir, you please share your introduction to this panel.
Thank you very much. Hello?
Go ahead, Satya,
Yes,
we can hear you.
Yes. Oh yeah, okay. Good. So glad to be on this panel. This is a very interesting conference that has been put together pretty much at a very short time. So in fact, what I wanted to say was what essentially we have been doing during this COVID pandemic, lockdown and so on, how we are actually pivoting with our aerospace knowledge. So there are very interesting things that are happening. So we can essentially look at it in our academics. It's possible for us to actually do a lot of research level and technology level pivoting that could be of relevance to the pandemic itself in the first place. And secondly, we have to actually ask ourselves, what is it that we could be doing within the realm of aerospace that could be COVID relevant, or how to work around the pandemic and so on, and still keep ourselves sane, being aerospace engineers. On the first part, one thing that came up very quickly was we have been doing a lot of, for example, 3D printing, right? So 3D printing is like a very new thing that allows us to do a lot of things. So that just allowed us to do a lot of these face shields and new kinds of ventilator parts, those kinds of things. But that is sort of like, if you just make a design, you just print, and then you start, replicating it. So fundamentally, not much of an engineering research that goes into it. But what I also found was there is a significant amount of R&D that we can do as aerospace engineers. And we started doing things like, for example, what the medical community calls a turbine blower. So in the aerospace community, that's kind of like a contradiction in terms, because a turbine works differently than a blower. But that's what the medical community calls it. And this is useful in many ways for bringing ventilators out of ICUs into quarantine areas and so on. But fundamentally, it's a very small handheld blower, which is a miniature version of what you would see in things like liquid rocket. It's a centrifugal blower. So we could actually make that and proceed to make a lot of medical devices. For example, PPEs where medical staff that are in ICUs will not get to breathe the aerosolized virus in the air from the patients, or make something called a CPAP helmet. CPAP again stands for something that sounds very aerospacey, which is continuous positive airway pressure. So you can clearly see that there is a lot of airflow that is involved in it, right? So there are many of these medical devices that have a lot of airflow involved in it, right? The way the breathing itself happens, the pulmonary diseases that fundamentally the COVID disease is essentially a somewhat like an aerospace process. It's a fluid mechanical process. So the other thing that also came up, other than making these kind of medical devices that have aerospace relevance, and the point essentially is, just to give you an idea, right? The handheld blower apparently is something that's being done only by about 3 companies in the world, and there is really no reason why an aerospace professor cannot go ahead and make, particularly a propulsion professor, cannot actually go ahead and make this or design this and develop a product, right? So that kind of capability exists within the country, and we should be able to pivot to do this during this pandemic. Now, the second thing that occurred to me was, if we are actually trying to see what are the different symptoms that happen for COVID that we can understand. So many times they are basically saying that you start with a fever, you can start with then it gets into a sore throat, then you get into a lung infection, and it could show up in X-ray or CT scan a little later. So there are lots of these different things that we keep hearing about. Now, one of the things that could have been easily done, I shouldn't say easily, I take that back, maybe it's relatively easy for aerospace engineers to do this, particularly simulation kind of people that Santosh Kemchandra is, right? Model the whole thing, right? Starting from the nostrils, right? How the whole thing goes when a virus goes there, goes in, actually clogs that lungs, all those trachea and all of that stuff. Just do a 3-dimensional CFD modeling of the whole thing, so that you will be able to tell which symptom will be coming up and at what stage a patient will start getting what. It is important because I can actually now start running a lot of artificial intelligence models based on these symptoms, right? Using the model rather than having to go for actual patients, right? And this is something that will help us develop AI-based screening tests that can be done beforehand, before we want to decide who needs to be tested, and based on the symptoms that they report, and we can quickly tell how far the infection has proceeded, and so on, right? So these are all things that are actually sitting for us to do as aerospace engineers. Breathing is a sort of like an aerospace engineering activity, right? And that's what this thing basically touches upon. So why are we not doing that is something that I still don't understand, right? So we need to just come forward and do all these kinds of things. So we just have to think completely differently than what we are using. So these are all examples of what I would say academics can do to contribute to the COVID research, right? Not necessarily being doctors, that is fine, right? So we still should be able to do this. The other thing that I was actually saying, what about doing things because of COVID in aerospace. And the thought that I would actually leave you with is it possible for us to actually work on new aerospace products? Like, for example, there is a lot of work that's been done with drones during this time. Right? So if you now notice, many of those drones were either very small drones or even drones that were imported from somewhere and so on. So this is a very good opportunity for a country like India to have homegrown drone companies that can develop a lot of these kinds of drones. And these drones could be just the quadcopter variety, or it could be the hybrid variety where you have the quadcopter and fixed wing aircraft together and so on. And that leads to a lot of issues that are of research interest in both aerodynamics, because this will be like low Reynolds number aerodynamics, as well as rotary wing aerodynamics, interfacing with the fixed wing aerodynamics and so on, and as well as a lot of dynamics, like dynamics and control issues, because we have multiple ways by which you can control this, and these are very small, control surfaces, as well as rotary wing. Multiples of those, particularly to be able to control this. It's not so easy if you want to now do a very, very perfect machine. And many times people don't do that. At the level of startups and so on, they are just fresh out of college. They just put something together. They will have like about 500 crashes, and they will not have money to bootstrap that. So, is it possible for academics to actually get out from their pedestal and then start working with these guys and then do a better job, or get them to do a better job? Right? And lastly, if you now try to grow the same idea, I think the previous panel was talking about this. If you're now talking about social distancing, metros are not possible, buses are not possible, right? So the whole idea of mass transit has to actually go through a complete change, which means that we have to go in ones and twos in vehicles, and that will clog the roads completely. So when roads are clogged completely, what do? You have to actually take off from the road and then fly in the air. That's what aerospace engineers should be doing, right? So is it possible for us to actually have two-seater air taxis? And what does it take for us to do those kinds of things? And that will essentially mean that people don't have to travel together, but they will still be able to travel pretty fast across the city, right? So, and then start looking at urban air mobility rules and regulations and so on. So the entire pandemic is allowing us to accelerate a lot of things that we would have thought should be well into the future. And so you need to look at this as an opportunity for us to be able to do these things, rather than sit and say, hey, this is like the worst thing that has happened to us in our lives, which it is, which indeed it is, right? But just turn around and look at the brighter side and start thinking about what are the opportunities that this is bringing. That's all I have to say.
Thank you, Professor. You really gave a very great indeed insight of how AI can be useful with 3D simulation of flow visualization too, and all the PPEs and the like drone. How we can go with the
program that can help us fund an idea. We will apply for it. There is no question about it.
Yeah.
So if something hasn't happened, there is something in there that is putting people off, and that has to be taken out. Maybe it is red tape, maybe it is bureaucracy, maybe researchers have certain professional aspirations. If you say something like, I'm going to tell you which journals you can publish in, or I'm going to tell you which flight you can take out to go to a conference. It may be something really silly like that. That may turn off people, or you may be saying, okay, you cannot bring in someone from you can use this pot of money only with companies in India. Okay, at that point you have to see if you can make. If let us say there isn't a company in India that fits the goals of the project, then the proposal dies. It's just dead in the water. So the funding pot doesn't get used, and that's a shame, because that's, as you say, a waste of resources. So a little bit of whichever funding agency is wondering why its proposals are not fully subscribed to, they have to do a postmortem and sort of speak to people and find out why wouldn't you apply for this. But that has to happen. Only then you can improve utilization. And for tier 1 colleges, I mean, it requires a bit of should we say, animal spirits, enthusiasm to attract the funding. And trust me, when the first few projects succeed, and a reputation of trust and ability is built up, then things flow. And that's how it happened at IISc. That's how it happened at IIT Madras. That's how it happened at all the institutes today in India and in the world that get funded. So at the end of the day, what does a funding agency want? I hand out X dollars. I want to get something out of it. Not necessarily X plus 10X dollars, but if I say I will know a little more about this piece of science, yes, that should happen. That's the key. If any institution can convince a funding agency that they can deliver, I don't see why there will be a problem with funding coming.
So, Professor Santosh, he adds a valid point. Rather than thinking about the individual's capability and individual's consistency, if its institutions' deliverance and consistency about research interest, it matters a lot, and it also plays a vital role. That's what Professor Santosh concludes. So, we are here, and we are also nearing our time. We are overrunning our time. So. I'd like to ask one last question from my sets to Professor Tanigair. So before going to participants' questions, since it is we ran out of time, Professor Tanigair, sir, this is for you. What do you like to see happen in next 6 months, 1 year or 5 years as initiatives? Efforts might be more effective, or even establishing startup entrepreneurship or incubator culture in small towns to address local problems. How do you collaborate and satellite campuses of Aero colleges and even city colleges? Would that increase exposure of new technologies to the rural parts of the country?
Yeah, actually, this having a startup and making the students to be an entrepreneur, one should have a kind of a knowledge, or they should gain in while they are doing their masters or while they are doing their graduate. So then only after completing their this degree, they would be able to have a startup, and they would be easily having some idea to become entrepreneur and all. But Anna University actually has as one center called the Center for Technology Development and Transfer, which is supporting the students who are actually which is supporting the students who are doing their final year postgraduate students and the final year BE students. It funds for its 4 campuses. It funds to the students, maximum of 25,000, and the students who are bright students actually, they are actually having some knowledge, some innovative ideas, and so they wanted to put their ideas and execute it in the form of a project and make it as a model. So this funding, certainly we can call it as helps a lot. To the students who can take up their projects, of course, under the guidance of their mentors, the faculty members, and it gives some kind of an idea how to go with the execution of projects, how to be an entrepreneur, because they are doing all activities during the execution of projects. They go to companies, they identify the materials, and they buy the material. They know the cost of the material, and they know the properties of the material, and they are selecting the materials and all for their products. So it should start from the college level itself, so that they can easily go for having a startup. Now coming to this, what kind of areas they can choose for having a startup as far as aerospace engineering is concerned. So you take again and again. I'm coming back to this the thrust areas like. Arc jet and magnetoplasma dynamic thrusters and the supersonic combustion and the drone. These are the areas are completely unexplored here. And if you take a drone, if the student is able to design an aerodynamically efficient rotor blades, actually, we are buying it from the abroad, the rotor blades, electric motor frames, and everything. If you are able to design efficient, aerodynamically efficient rotor blades and the student is able to prove himself that he can do that. And of course, he need not even go for requesting companies to give him a job. Instead, the companies would come to the student who establishes himself in designing or model or designing a product pertaining to the aircraft or drones. Okay, so if you ask me, what would be the future of the first point? What would you like to see happen in the next 6 months? Whatever it was happening in the past, in the past, the same thing would happen, but with some kind of impetus. Because as I already told you, whenever you have a challenge, a student, you would be able to explore the possibilities. So that even many innovations have come out only during the crisis. So we have a crisis here, and not only now. In the case of the aerospace field, we have crisis throughout maybe all the time from the past and maybe in the future. Aerospace field needs not only engineers, they need technocrats, they need technologists, they need real scientists who can contribute a lot to the aerospace field. So as I already told you, if the student is able to exhibit himself, that they are talented and they can design a product, they can design and fabricate a product, innovative product, then definitely there won't be any problem in getting jobs for them. They can create a job, thousands of jobs here in India. So as far as this aerospace field is concerned, I positively think that opportunities are plenty. Only thing is that we have to explore the possibilities of choosing the thrust areas and shining well in that chosen field. So this is what my answer for your question.
So to conclude, in my question is, before moving on to participants' questions, it is well addressed rather than discussing in other forums like whether we are going to have a blended learning or not. But here, as Professor Tanigar earlier addressed, conventional learning is a right thing, and we are here talking more on research. Like the requirement itself says that we need to do a lot of research, and the involvement of non-tier 1 colleges should come up. The motivation or a channel of encouragement from government agencies should arise. At the same time, school level awareness to higher education is a very requirement. Also, individuals' interest and entrepreneurship thing, which will only come through how we put up things around an individual when he's going. That will be that is going to play a vital role. And yes, OEMs, MROs, as previous panel said, a lot of opportunity for entrepreneurial thing. Also, the existing focus, what we have grown so far, like in government funding and research, it is also a very big area which is going to happen, and this is very temporary. What especially academics of aerospace have seen in many years, this is not a permanent way, and also conventional education and government funded researchers will play a very big role again. It will become back to normal, and whatever we are thinking is just a temporary solution. That's what we are. That's the outcome, I guess, from our discussion so far. So going to questions from participants. Here I have got a question for Professor Satya. Professor, are you there? Hello,
yes,
Professor.
Yeah.
Innovation at concept level should happen at premier institutions. Manufacturing at established industries and testing and demonstration at large scale should be supported by government at facilities of national importance. Once demonstrated, designs should be auctioned at reasonable prices to develop disruptive technologies for the society. Why such policies are not getting discussed by participation of academic institutions, startups, or industries? what needs to be done to bring in such changes? And who should take the lead role? Question is innovation. Yes, Professor.
Satya, you may want to look at the chat window. It's in that.
I'm reading that, but it doesn't specifically say that I need to answer that question.
It says ask this to IIT Prof Chakravarti.
Ask this to Professor.
Right at the bottom. Okay. Yeah, I can see the plot. That's my former student there.
Right.
So I think the basic problem here is that we are making a lot of assumptions about what is the right thing to do. Right. So and Indians fundamentally are so argumentative. Look at what we are doing. We're just sitting and talking about this, right? So if we had been a foreign country, we're probably doing something rather than talking. Right. So if you now allow all these people, whoever that Sriram Banerjee is talking about, premier institutions and the large scale, what are the lab scale people and the government, there'll be about some 10 different people, 10 different opinions on what's the right thing to do, and then before we converge, it will be 10 more years, right? So I think in a democracy like India, I just let people do what they do. Right. So if somebody is thinking that there is a business case for doing,
most of this research is being supported. Like aerospace manufacturing for years. In international gas turbine is he earned his PhD from Georgia in 2009 and has been at ISC since 2021. He held a string of postdoctoral fellowship with the Institute of Aeronautics.
Satya very nicely pointed out the various kinds of new research problems that things like, and people have started to look at this, which is we had our own ventilator that was IISc, and saying in the market, that we started looking at this device. We realized that they're all used to working in certain flow regimes, doing simulations and certain mainly guided by physics and finding it different this is opened up very interesting challenges for us as a research. So going forward, I think that it will be quite that we will be doing far more of this. There are also something that I like to say about the interesting situation that has come up, especially since
இல்லை அது கரெக்ட் 100% ரைட்டு அவனுக்கு தேவையானது எடுத்துக்கிட்டோம் அப்படின்னு இவரும் சொல்றாரு அவன் வரல நம்ம கான்ஃபரன்ஸ் ரன் பண்ணா கரெக்டா இருக்கணும் அப்படின்னு சொல்லுவோம்
This represents the time focus on key fundamental aspects that will enable development. Now, one of the things that you mentioned in your Q&A was shape optimization. Shape optimization used to be very much, it was used and it continues to be used in the aircraft by airframers to develop airfoil shapes in order to minimize drag. There is some use of shape optimization. So what is shape optimization? Like finding, suppose you have a certain system and you want to optimize a certain performance parameter, then you ask, okay, how do I design the geometry of my system such that I achieve the optimal performance that I'm looking for. So reducing drag for an aircraft is shape optimization came up. A lot of shape optimization with the advent of additive manufacturing. All this stuff is regarded as esoteric mathematics. That's how scientific comparison. Because now, with the constraints of manufacturing, you have the ability to use all the mathematical techniques that have been sitting on shelves and so on to actually discover optimal configurations that can now then be manufactured, which was given to us possible using traditional mathematics. But in order to do this, for the systems that we're talking about in aerospace, there has to be an investment made in developing, like the other thing that suggested, which was like say simulation. You want to be able to simulate complicated flows. You want to be able to simulate realistic situations, realistic devices, aerospace devices. And today, I really think that all of this is possible with cheap availability of unprecedented availability of compute power around the world. We have large complicated simulations. We can capture all the physics that we need, all the physics and get this one insight flows that would be simply possible maybe even 10 years ago. Simply because you go to experiments, tests to actually so that so now when you can do that, you can have opportunities to use things like machine learning, opportunities like neural network, deep learning, etc. to develop low-order models, even physics-based low-order models, stuff that I've been doing, plus these other techniques to develop low-order models that can then be drive with design scale simulation at a cost and time that is reasonable for engineering design, practical engineering design in the industry. So this is something that I think should be the new norm for people like me going forward. Where we know how to do areas. We all have experience writing software. Software rules. We can put more physics into these codes, capture more complicated physics. But if you want to address the key design questions that the industry needs, we have to find a way of using this as a tool, maybe as a replacement for some of the testing that we do, and then building up models using new big data techniques that will then allow us to leverage the power of new advances in technology like additive manufacturing and things going on. So I suppose that's what I had to say. And Professor, was it in a different perspective from the Professor in the same background, later than Professor Satya. Let me introduce Professor
Professor Dr. Aero, who's heading Aerospace Engineering Department at Madras Institute of Technology, Chennai. His areas of interest are in aerospace propulsion, high-speed jet, aerodynamics, and computational heat transfer. At MIT, he was responsible for introducing first one in high-speed jet group, computational heat transfer, and electric propulsion for aviation jets. He has contributed research projects on the role of the innovative vertex generators of high-speed jet controls, impact characterization of laminated and sandwich composite panels, and the strength analysis of laminated composite structures. Before joining MIT in 2005, he worked as assistant system engineer in GE Aircraft in Cincinnati. Studying before that was an assistant system engineer at Nadu for nearly 3 years. He has also worked as contract engineer at the Center for Military Airworthiness and Certification, RCMA in DRDO. He has a PhD from MIT on high-speed jets and an MTech from MIT Madras. And most of these people are in various colleges across Tamil Nadu as professors. So with this, welcome Professor Aero to give this introductory speech. Sorry, you are in mute. Professor, you are in mute. Hello? Professor, you are not audible. Hello, Professor? Professor, you are not audible. Mic is not working. Sorry, your mic is not working. No, sir. Not really. Hello, sir. Hello, Paula. I request the organizers to contact Professor Aero and sort of the victim. Meanwhile, what Professor Aero let me introduce him. Meanwhile, I request the organizers to kindly contact Aero, sir. Try to get his mic connected. We can see him, sir, but audio is not audible. Mic is not working. You can try with another setup also, but you can meanwhile, we introduce Professor Kyriakos. Professor Kyriakos is a senior lecturer and associate professor at the School of Engineering, the University of Utrecht, Ireland. He is the director of the undergraduate and postgraduate programs in Aeronautics at the University of Utrecht. He has nearly 20 years of professional professional and research experience in the field of aeronautics, aircraft maintenance, metal plasticity, and additive manufacturing, has taught on aeronautical engineering and the University Academia in Ireland and in Australia. He is leading metal plasticity and additive manufacturing research in the School of Engineering. He has extensive experience on particle aircraft maintenance, aeronautics, and structural integrity management. He earned from his 12-year career in the Helens Air Force as an aeronautical engineering officer and specialized as Dassault Mirage 2004. His research work has attracted funding from various civil and defense organizations and companies. He has led research consultancy training projects for aeronautics, funded by aviation authorities, defense research organizations, and other defense clients. His work on aerospace materials metals has been primarily focused on the development and implementation of plasticity models for military aircraft life predictions. For applications in life extension and aeronautics, is a chartered engineer registered with the Engineering Council and a fellow of the Royal Aeronautical Society. He is also a member of RAS, Royal Aeronautical Society's Aeronautics and Maintenance and Structures and Material Specialists, and a professional member of the International Federation of Aeronautics. It's a great honor to have Professor who is a director of Aeronautics at the University of Chennai, who is an expert in aviation and aeronautics and maintenance. I welcome Professor. Kindly share your introduction.
Thank you very much for the introduction and for yes. So can you hear me well, first of all?
Yeah.
Okay, excellent. Okay. So thank you very much for the introduction and for kindly inviting me for this online conference. Perhaps the online will become the new norm, first of all, in aerospace and aviation. You know, there was some discussion before all this happens that we have to move to less and less, face-to-face conferences. So that gives us an opportunity, but physical, contact and socializing is important. Nevertheless, we have the opportunity to communicate with our colleagues and friends and collaborators throughout the world. So this conference, I think, is very timely. I will try to talk today about the theme. I will still the theme of this conference. We'll use some presentation which I'm going to share from my computer right now. Give me a second, please.
Sure.
Okay, so can you see the first slide? Just to double check that there's okay, next. So the new normal in aerospace and aviation. So the industry is undergoing drastic changes, and I thought, okay, let's give an overview. It's not going to be a very detailed presentation anyway. We're talking that regards. I think that a lot of previous attendees, the previous speakers, have said very well. The environment have discussed very well the different challenges. Some of the things I'm going to mention that perhaps are repeated over here, or perhaps shown in under a different perspective. Next one. Okay. So the discussion is all about reshaping aerospace and aviation. What I call here is the R3 approach, and the idea was to have something, communicate something simple, something that people will remember. Perhaps the most important thing that comes out of this crisis, the most important lesson, is that the industry is trying to much as possible, given to the high degree of uncertainty, the reshape of the industry. So the reshape of activities, both in terms of the manufacturing and the operations segments, and the operations assets in which we hear about the technical aspects of that. So the industry is the hard already know. It is unknown for how long with this situation. So first of all, the efforts are geared around the restart of the industry. On the activity around flight operations, technical operations. Again, the main focus is the airlines. Without the activity happening within the airlines, and if this activity remains very limited, the demand for new aircraft, new products, and people will be again staying very limited. So engineering professionals are going to be affected directly by this situation. So the first thing that the industry needs to do is to restart, even if restart means that we have to. So even if restart means that we are going to operate under a much restricted portfolio of activities. Another thing which came out of the discussion that is happening as we speak in the industry is that we have to somehow, looking at from the industry perspective again, to rationalize the growth targets and the products. There was a big growth, a large growth trajectory which was provisioned by the industry. There were a lot of plans around that. But right now, the people are, the managing, the executives, managing directors, the executives have to sit down with the engineers and try to find out what is the actual, demand there. So we need to revise the growth target and say that yes. Okay, so here, the role of the engineer is important. To work together with managers and to revise the business model to align with this new reality, how we can create something which can meet the demand, what kind of capabilities we need to have. So both growth targets and products have to be revised. Refocusing, as mentioned before by other speakers, there should be some new investment because the industry has to move forward, but this has to go hand in hand with internationalization. What kind of products, what kind of expertise, what kind of areas are going to invest in? And this would drive the staff expertise that we have to build. And we have to look at 5, 10, 20 years from now. Okay? Maybe 25 or 30 years, someone can say, but it's very hard to predict something what's going to happen in 30 years. So engineering innovation and getting professionals to work towards a vision, whatever this vision is for the different sectors. There may be a different vision for the airlines, a different vision for the manufacturers, a different vision for the space industry, because the space industry is going to grow in the coming years. There is a large demand for fast internet, for example. We need more satellites. More satellites means we need more space vehicles, more space launchers, and so on. So there will be new opportunities over here. And again, the whole aerospace and aviation industry will have to take into consideration when we're designing something, because aerospace engineers cover both sides of the story. Looking at universities, the university level education, one of the things that the universities have to do is to adjust to this new reality, the new normal. And one of the things that comes very high in the priorities is re-education of professionals and graduates. And when we talk about graduates, we mean new graduates, people who are already studying degrees and are graduating very soon, and recent graduates who are looking to find employment, or they're employed in some companies which, for example, they have been doing redundancies and so on. So this is a role that the university have to build upon. That's an opportunity for the universities. We see that happening in other situations where we have, crisis, financial crisis, and there is a limited demand for professionals. And this is where, education has to happen. People are trying to get more skills. So the universities have a strong, position here to educate professionals and graduates at masters, not masters level, research masters, because some skills have to be learned through doing research studies, PhDs, of course, and professional courses for those individuals, for those experienced people from the industry who have to be retrained and have to get additional skills or to broaden their opportunities for employment in other sectors as well. Retaining talent. So the next phase for within this transformation which is happening is to retain the talent within the aerospace and aviation industry. Okay. But for this to happen, you need to have universities who have the opportunity and have the capacity to retain the best possible students coming out of the high schools, for example. Okay. So aerospace and aviation has been a very strong marketing tool for many universities. When these universities were trying to promote their branding or to get very good students throughout the programs, they said, okay, aerospace, because aircraft are fancy. Aircraft are the most technologically advanced product that people have made, perhaps. So with this change that happened to the industry, there will be perhaps a negative impact, because people are going to study in a degree, but it would be much harder for them to find employment in aerospace. So there should be some investment, going into the universities, even promotional investment, put that way, to retain the best talent, both for the students, but both for the academics and the research who are working, in projects in this field. The fact that we need engineers and scientists that have a very, very, specialized knowledge, and perhaps most of them, or some of them, could combine, industry experience and academic experience. It's important to keep this blend, in place for the next generation of engineers to be trained. So that's not trivial, because whenever something happens in the industry, whenever a disruption happens, people will be absorbed by other industries. So in terms of aerospace and aviation, we have to retain this talent, both students and staff. Redesigning the curriculum and the research focus, again, this is something which was discussed before in the other presentations. The curriculum in any aerospace engineering degree, either undergraduate or postgraduate, always align with some demand from the industry. We have seen that with composite materials, for example. Okay? When there is say of the industry required, lighter and more strong aircraft, the whole, metal area was pretty much scrapped. The primary structure of the aircraft has moved more and more composite, and we have seen, programs being aligned to this composite board. That's an example, of course. Every time the change happens in this industry, in aerospace and aviation, there is a change in the curriculum, and that's one of the positives and the negatives of this degree. It's not a traditional, discipline where we'll see, things not changing for 100 years or for 50 years. Some changes happen every 5-10 years. Of course, this disruption is much more intense, but we'll see also in this case the need to readjust the curriculum for all of the programs which are offered. In terms of research, again, there should be some investment in the areas which align with very focused industry needs. Okay, so there should be, again, a synergy with the industry, and this is what the aerospace and aviation focused universities are doing very well. They retain this connection active. Most of the universities have very strong, research programs, working with industrial partners, working with government partners, which are putting down the requirements for certification, like the Clean Sky in the European Union, for example, with the push for more, environmentally sustainable aviation. So we'll see much more of that happening. We may see, the demand for narrow-body aircraft. So there will be new areas for research. The aerospace and aviation universities would have to focus their efforts and their money and their, all their capacity in order to identify these areas very quickly and in collaboration with the industry. So that's also important to have in mind. It's an investment that needs to happen in human capital and equipment at the same time. By equipment, you need the people to operate that, and that expertise cannot be built, within a few days or a few months. It requires many years, and you cannot afford to lose that expertise again. So it goes hand in hand with retainment. So that summarizes my short talk. Thank you again for the opportunity, and of course we can discuss any questions afterwards. That summarizes my
Yes, thank you, Professor. And it's indeed a great insight in aviation and aviation related courses, how it directly and immediately affects from the industry, and also you pointed out how institution requires a quality students also for this thing, and how the student need to invest and we need to invest more time and money so that pursue his skills in aviation. That is very true, and also as you said, 5 to 20 years, how the industry is going to gain and the difference between the research and the aviation industry, especially in terms of academics, because indeed need eye-opening terms. And I believe that it is common across the globe in the country. And I welcome back our Professor Tanigi also. Good evening, sir. Yeah, good evening. Can you hear me, Professor Tanara? Yes, sir. Yes, sir. We can hear you. Oh, great, great. We had some audio problem here, so I could not connect it. Yeah. Can I start? Can I start, sir? Yeah, yes, sir. Sorry that I came in a little bit late to join this kind of thing because of some technical issue I faced here from my end. And actually, being that broad copy of this panel meeting on the kind of normal on higher education, so my topic converges to the impact of normal on the role of the function of universities and colleges and the challenges they are facing this time. Of course, my topic will be slightly generic in nature, and we have some time to converge into space important. And we know that this COVID-19 has placed its leg almost in more than 150 countries in the world. Soon after they realized that the presence of virus or spread of virus is possibly those countries have invariably been imposed lockdown, a complete lockdown, which has already affected the world economy and also made all the educational, all the institutions, irrespective of what type of institution it is. So all the educational institutions and industries and business sectors have completely become a standstill. And of course, this complete lockdown is meant for preventing or containing the spread of virus and through social distancing and all. But the other side of this lockdown has a severe impact on the world economy and also the function of the educational, in particular, the higher education system. The economy directly links to the higher education. Right now, the colleges are being closed and the universities are non-functional because of these complete lockdowns. And of course, this definitely poses a challenge for all of us, including all the stakeholders, students, faculty members, and R&D researchers and scientists. This kind of pandemic is not new. Our forefathers or ancestors have already come across such kind of pandemic. For example, in 1918, Spanish flu almost taken away for about 15 billion lives from us here. And more than 1/3 of population got infected. Of course, the similar kind of situation they have faced, and they also maintain social distancing. They also want to contain them. So now we have almost forgot the effect of the Spanish flu. The reason is that after encountering this kind of economic or world economic the institutional functions that would have been stopped completely. I mean, they took some time. The institutions would have taken some time to come back to its original normal rather than the new normal. So likewise, we came across other kinds of virus like HIV, Ebola, and SARS. Now we are facing the pandemic called COVID-19. So the colleges and the universities are completely now functional, and the students have been asked to go back to their home, and the faculty members have been asked to work at home. So the normal activities in affected completely. So if you take the function of an university or the institutions or the colleges, there are about 5 entities involved. 5 entities operate, not only universities is in mute. Professor, Professor, you are in mute. Hello? Professor, you are in mute.
I think his network is down, I think so, sir. Yes.
Can you hear me? Yes, Professor.
Yes.
Yeah, hear me? Yeah, I'm sorry. Admission into higher education. These entities like spy entities like namely admission process and teaching learning process and examination context of examination and evaluation process and then placement activities and application into higher education. Interlinked with each other. There is a chain among these. Okay, so these chains are now it is so these chains are interrupted temporarily, not permanently. But now the thing is that how to get this situation like it was functioning before the spread of COVID-19. So if you take this entities one by one, like the recent process, okay, some of the developed countries, even if you develop countries, they follow online admission process, okay, like conducting online examinations and conducting interviews online. Maybe the students can sit at their home and then appear for the online examinations. And the important point note here is that those countries, they have complete infrastructures from urban areas to the remote areas. So they were able to complete the admission process or conduct the process. But in the case of countries like developing countries, the admission process is partially online and partially conventional admission process. As far as this developing countries is concerned, I think still we have to make sure that the online admission, to conduct the online admission process, there should be a proper infrastructure that should be developed and see that the students living in the remote areas and irrespective of the poor economy and the students having poor economy, they should get the facilities facilitate this kind of online admission process. Like so only we can come out of this or overcome this challenge now because we do not know the impact of the COVID-19 or the characteristics of the COVID-19 is not yet predicted. Okay, how it is going to be there for that is going to be there for longer period, or it will go away even after or it is going to come in the form of a short wave or a cyclic nature. So these characteristics are not predicted yet. The researchers are working on the characteristics of COVID-19. So if it is going on so much from after a short while, that's no issue on. Okay, after that become more normal from normal. So everything will become normal. And all the institutions will start functioning. But the issue here is that how long it is going to be. So right now, if it exceeds for more than 3 months, obviously we have to go for some other alternative. If the admission process is completed, then only I think we can go for the teaching learning. So my preference to conduct the admission process. Let us have a kind of model to take care of the online admission process completely. Like proper infrastructure, students immediately where is and what kind of condition is having. So next it comes teaching learning process. Of course, it is a very important and longest process of academic institution. That semester it will go for about 8 to 4 months teaching learning. So this teaching learning process, conventional teaching learning process are supposed to be most accepted globally. But of course, unfortunately, we are not able to follow this conventional teaching learning process in this kind of crisis. And we have to adopt
even they dropped out in the science and technology. They started following this move, that is a massive open online courses from since 2012 onward. That means the students who take up the courses online, they cannot go to the institutions or universities. They can sitting at their home, select the they can appear for the assessment test and then semester examination. They can submit the assignments. They can also have direct online interaction with students. Then they started using other chances, the online online teaching process. That is called the SMOOC, that is a self-paced online course, which is relatively friendly as compared to the so one should adopt this kind of online teaching by providing good infrastructure all the students their interest or their needs and all kind of enhancing that. So we should accept that. That only overcome this kind of difficulties better. So then it comes the examination. The examination process is very important because without conducting the examination, you cannot award or not assess the performance of the candidate. So generally, this examination process in the case of universities, I think it is relatively easy to even conduct the examination even during this crisis because the strength of the students from the universities may be relatively less as compared to the colleges affiliated with the universities and all. And the colleges which are affiliated to the universities in terms of the students and in terms of that, and the conducting examinations, especially during this period, is posed a big challenge. But even then, we can even follow certain procedures to conduct examinations with the big institutions. Okay, having more than 9 colleges of colleges. Generally, I'm telling it is also possible because the impact of COVID-19 is not uniform all over the places in a country or in a state. Some very few districts the impact is very severe, and those regions are similar as a red region. And of course, it is classified based on the impact. It is classified as a green region and orange. So what we can do is that in order to complete this process of conducting examination, okay, we can even go for conducting examinations, okay, for the orange zone and green zone. Okay, so that soon after the conduct of the examinations, that evaluation process, so that it will not be any trust. But in the case of red zone itself, I think we have to follow the procedure. Professor, I do have questions, especially conducting this examination online. How to conduct it with the conventional. Before having that discussion, shall we have a question starting from Chakravarti sir, especially in research areas? And to have we are running out of the dialogue. So that particular point, like, we have some sort of questions covering the same aspects what we are discussing, and it was a very great insight indeed. In terms of operations of an academic institution, especially it was described what is can understand the great concern that admission is going to affect the academics, how good an institution is. Rather than that, admission is going to take a major lead. That's what your talk have revealed a lot. And the later part comes an assessment and other. Parallelly, teaching part, how we are going to convey to the students and whether they are having required infrastructures, like without any technical issues. Like even now we face a lot of technical difficulties a very apt point what we were discussing. So with this, I'd like to continue our discussion. Sir, before that, I'd like to hear from Professor Satya. Professor, sir. Satya, sir, are you there? Yes. Yeah. Sir, I'd like to share your question. The question is, it's combined of three. How do you see research focus and funding being affected by this pandemic? One. And where do you see that academic research after 6 months or 1 year or 5 years from now? And also, how do we keep that balance between government initiative, R&D programs, and industry focus efforts? So, very correct. Can you hear me? Yeah, yes. Many times when something like this happens, and typically in aerospace, fortunately or unfortunately, in general in most sectors, but particularly in aerospace, research funding is primarily coming from the government, right? And then in democratic countries like India, US, and so on, what you will find is that the government policies are more or less politically driven. And particularly when you have an unprecedented situation like this, there will always be the emphasis on trying to do something that is specific to this pandemic. So that's exactly why I started saying what I said, which is it possible for aerospace engineers to pivot and use their research to do something that is required for the respiratory tract and modeling those, or doing devices that are useful for ventilators. So these are very, very important. You will find that there is a lot of research efforts that are research funding that is currently focused towards COVID. So if you are now trying to do a lot of research in COVID, can I now do a 1 or 2 years worth of COVID research? Is what I think everybody should be asking themselves. That is number one. The second thing that you also notice is a lot of talk about self-reliance and trying to do things within the country and so on. This is very important because when in our side, for example, this morning there was this article about how the light combat aircraft, the Zulu squadron has started. They are basically saying this is a very nice thing and so on. So, and then they are now talking about an SPA Mark II and a AMCA aircraft coming up. So this is very important because this will fuel a lot of R&D. So there is a lot of defense R&D that you can expect to happen within the country, and a lot of research funding that could be channelized through DRDO. So we need to be keeping our eyes open for those topics. Now the third thing, taking on this momentum, what I would really like to urge is for us to actually think out of the box. Is it possible for us to actually push the limits in trying to do R&D, tying up with academic institutions, with startups and industry, in coming up with new products that are actually more society oriented. One of the major problems with aerospace is everything is big. You are talking about big aircraft, big rockets, all those things are being short. That is what actually makes the entire economy sink to such a small level. What if we actually start making small rockets? Tomorrow, for example, you will find peanuts, talk about actually small rockets. Right? So if we are now going to make satellites, how is it possible for you to actually chop those satellites into a lot of micro satellites and get constellations to work together? There are completely new ways of doing things that will improve the redundancy of aerospace systems. The capital will come down. The amount of hit that you will take with these kinds of pandemics will come down. Aerospace will actually become more commonplace. You will have a lot of engineers that are required for doing all these small things. And so on. So how to actually bring down the size of the product itself is something that's very, very important for us to work on. So the pushing the boundaries part is on that part. Is it possible to come up with new products? The other boundary pushing will be is it possible for us to actually think about hypersonic aircraft, so that we can improve the speed with which we can go from one continent to the other. Right. So these are all things that we will have. So there are 3 levels. One is COVID specific. The second one is defense oriented. The third one is pushing boundaries. These are the three things in which 3 things by which we will be doing research, in my opinion. Because we can understand there would be a future engineering science, where there is a need rather than just to focus on government agencies or depending on the requirement. And moving on, and I like to share the same question to Professor Santosh Yamachandra. So I like to hear how an research professor is seeing this from his perspective. Should I repeat the question, sir? Sir, Professor, you are in your. Yeah. So,
Welcome to KTS Music World. SD card.
I had questions.
Bluetooth.
What the question is. So I would yes, summarize what I understood what Satya is trying to say is that we need to look at different ways of building systems, aerospace systems. We have at this point we have looked at capacity, we have looked at scale up, we have looked at efficiency, we've looked at how to do things with lowering costs, our space missions, etc., being an example of that. But we have to now think about ways of sort of reorienting the aerospace industry in ways that will be more resilient to shocks, sudden shocks. So that's something that people who are looking at aerospace systems and aerospace design methods can look at. That's something that that's something that must be done, and that's typically, in my view, within the realm of this sort of philosophical thinking is something which is in the realm of government research to actually fund. Then the second thing is we need in the Indian context, we lack ownership of key technologies. We don't lack the know-how. We lack the ownership. There's probably people who know enough in this country to put some key technologies together in specifically in propulsion. We've shown that we have a fairly good level of key competence in things like airframes, the LCA being an example of that, and in control. The LCA control laws being an example of a key achievement there. So we need the government to step up. I still think the government has a big role in aerospace. The government has to step up and focus its efforts, and this is within the Indian context, to focus on key developments in propulsion technology. Now we've made a great start with things like certain programs that the DRDO and ISRO have put up. But that needs to be continued. And so, in terms of where industry can come in, is as either bringing in support by way of either in way of actual rupees, or it could even be in kind. For example, if I develop a method to develop, let's say, in the context of what I was saying, suppose we start looking at developing design methods to optimize shapes and all of this. Now, how do I know that works? How do I know whether even additive manufacturing with all its flexibility has constraints? So how do I know what will actually work? So at this time, I'm actually part of an effort. It's an international effort where we are looking at some of these things. But in terms of funding in this country, there has to be the government funding has to continue. That cannot somehow be that cannot somehow disappear, because the bedrock of all aerospace work is a fundamental understanding of physics. That has to be there. Once that is there, products will follow. New ways of doing things will follow. Everything will follow. So you have to keep that stream of government funding alive, for sure. Now, in the short term, the industries this is probably something that crossed my mind when the industry panel was talking. Yes, we've had cancellation of orders. Yes, we've had planes sitting on the ground. But we've also had oil prices fall. Okay, so in the short term, to aid recovery, we have companies that are poised with technologies, especially in the aircraft engine technology, where you have low fuel burn technologies, which can actually help drive recovery in the aerospace, in the airline sector, in my view. I mean, this may be a limited view, but that is my view. So I'm not wholly concerned about that. So industry may want to stop funding. Industry may say, I don't have money now, but I can give you this expertise. I can make this sort of design available to you for you to analyze, and government then has to step in and sort of give us the support that we need to be able to carry this out. And the outcomes of all of this should be towards building systems, because we are fundamentally an engineering discipline. There has to be a final system deliverable at the end, but you're not going to be able to do it without making investments in expanding our fundamental understanding of the physical processes that go on in these systems. That's my view.
So, like as we hear from Professor Santosh, his focus is purely on moreover government supported research funding, rather than thinking about new startups and like the statement trying to make us convey that, rather than trying to start a new research activities. Already focused activities are there, which are on the pipeline and which have already reached an acting.
I just want to be careful here. I'm not saying don't do startups. I'm saying keep the government funding intact.
So it is not going to be there. It's not going to be away. Like fundings from the government are going to continue, and we should focus on that, and also the startups will go.
Yeah. Yeah. Yeah.
So thank you, Professor. Before going to Professor Kyriakos, let me have questions with Professor Thanigere, sir. Professor. How do we prepare our excited students in rural settings, especially, who are relatively unaware of the utilitarian aspects of aeronautics, like who are totally unaware of aerospace and aeronautics? How we are going to invite them to play, and what kind of initiatives would you like to set up awareness campaigns? The state education, science and technology departments, and even the Center for Excellence related thing. How would you initiate? How would you recommend government to take initiative steps in this?
Yeah, actually, Professor Karnar, it's a very nice question, and also it is a useful question. Actually, what I could suggest is that generally the qualifying examinations, getting into higher studies or the engineering studies would be examinations or the qualifying the syllabus content. For example, higher secondary examinations. The syllabus content is basically on completely fundamental subjects like physics, chemistry, mathematics, and then biology and all, medicine. We focus on that. And the point here is that instead of so coming after completing their +2 or higher secondary examinations, maybe they come to know, your point is right, they come to know about the higher education, different types of branches available in the higher, like aeronautical engineering and automobile engineering and maybe instrumentation. These are the unique branches available apart from mechanical and electrical and electronics. So, frankly telling, the students who are in higher secondary examinations are completely unaware of the branches available only after completing their +2, what kind of studies they choose. So they are actually in a dilemma, or they are kept at the top. So what we can do is that we can give some kind of modification of the syllabus, the higher secondary examinations and the curriculum, so that they will also have some kind of knowledge about higher studies. What are the branches available, including engineering as well as medicine, or even the other arts and science. They should be able to understand what are the studies available, so that they can choose on their own, or if they are interested in aeronautics, they they'll definitely choose. And apart from that, what is the job prospects? Okay, so if you choose here, because many people they understand that aeronautics means flying, designing aircraft and all, and easily you can get a job. It actually many people think that the aeronautics is very difficult course and it is very difficult to get job. It is not so, because aeronautics is a unique course. If you excel well, you can even fly, come out with the flying colors. So the prospects of higher education and the job opportunities should be included in the higher secondary examination syllabus, higher secondary syllabus itself, apart from the fundamental studies of physics, chemistry and mathematics. I think this will help the students, before joining their course higher studies, they'll get some kind of knowledge about these branches, job opportunities. Yeah.
So it's a very great answer indeed, compiling both things. Like government should think about, our education board should think about bringing in the awareness in schools, higher education schools itself, about the education, what they are going to have in the higher education, like in that. Then definitely we need to also talk about bringing professors in the board. This should be this is the need for many countries where people, like students are still in a rural based thing. So it faces both the things, like what we are discussing now. Now, like with this, I'm let me call Professor Kyriakos. Professor Kyriakos. Professor, are you there? Professor Kyriakos, are you there? Hello, Professor. Professor Kyriakos.
No, actually, he's there only, but he's in mute.
Okay, let me move on. Let me move on to.
I think Professor.
Yeah, he's Professor Kyriakos. I like organizers to call Professor in WhatsApp. Okay. Professor Satya, again, next question, like, could or should we further encourage the startup or entrepreneurship or incubator culture, or look to more stable or established avenues like government or industries for technology development during these uncertain times? And how do we balance it?
First of all, we have to understand that we are academics and we can only say what we want for what other people to do, and it's for them to do. Right? We can keep saying that government has to fund, we can keep saying startups have to happen, but government has to fund and startups have to happen. There is nothing that we can do about it. Okay. So that said, I think the most important thing that we have to worry about is, why are we actually doing any education to anybody, right? What are these graduates going to do? Are all of them actually going to end up doing research, or are they ending up doing non-aerospace, non-core jobs? When considering that, it seems like startups are a very good option, because clearly government cannot absorb all the aerospace engineers that we are putting out. Or we have to admit that we are not really contributing sufficiently to this, so we should shut down a lot of aerospace engineering departments. So if we don't do that, and we are putting out a lot of aerospace engineers, we have to worry about why they are being put out and what can they do. And the only way I am thinking that these people can gainfully benefit from the education that they have got, hopefully, not still sure about it, is by thinking about startups. And the thing about startups you have to keep in mind, it's not as if like startups are something that you can just put together a bunch of nuts and bolts together and produce a product, and that's a good thing. But because it has to make business sense, it has to have economics in, built into it. It must have customers. A lot of those things are involved. So we have to think about why are we doing engineering education in the first place, particularly for undergrads, and what is the kind of skill sets that we need to impart to them that will make it more commonsensical. It doesn't make sense for us to actually be like the way we used to. The 20th century paradigm was you had all these big companies like GE, Boeing, and so on, and you are, or DRDO, Astro, whatever you want to call them, right? So, and then you are essentially educating people to push them into organizations. But what if those organizations don't have the capacity to absorb all the people that you're putting out, right? What is the kind of education that's required for us to give to those people that will have to still do core jobs and find jobs themselves by developing new products and pushing them into new markets? So there must be a lot of change in the way we are doing the curriculum, not only in aerospace, but in a lot. I think that's something that is at the core of the whole problem.
Yes, I can see drastic two different phases now. Like as previously Professor Taniya also said, we need to bring awareness in school campaigns to make more admission. At the same time, now Professor Satya have said that we need to think why we need to do engineering. So it's two phases of the reality. What we need to think about and address in terms of how research based and unresearch based education is going on. Moving on, yes sir, am I right?
Yeah.
So moving on to next question to Professor Santosh.
For any problem, what I would expect is you try to put yourself personally in that position. If you have a son or daughter, will you actually put them in admission in your own department and figure out what happens after 4 years? Okay, I mean, please think about that first before we can think about evangelizing things and educating other people.
But before accepting that, there are a lot of differences existing in government and private institutions. Why? Because if we see education, especially in country like India, we have more schools, government schools, and which don't have enough quality. All of a sudden, we have very less government institutions with very high quality. So even there is a very big question before asking that whether I put my daughter, rather than that whether government students are joining in government colleges. So that is a very big question. So there private institutions plays a very big role. So we still education, literacy, and we are fighting in between research. I guess so, sir.
You're asking, you're talking to me, or am I supposed to respond? Or
yeah, just shared this thing.
The quick answer is this.
So
right?
Next question.
The quick answer to your point is this, right? So typically the curriculum and the syllabus for even private institutions are set based on what is happening in the government institutions, and we have been taking ourselves for granted, right? We are basically saying that the government will fund this, government will give jobs, and so on. What if that actually doesn't happen? Don't have to worry about whether their syllabus is actually relevant, right? But if you are running a private institution, you have to ask the question: is what you're doing the right thing? Right? Doesn't mean I'm not saying private institutions shouldn't exist. Do the right thing is what I'm trying to say, right? Do the things that will be useful to the students.
Sure. You are right, sir. That's how deemed universities can do that. Whereas affiliated colleges, I don't think. I believe that they are restricted within the constraint of regulatory authorities. Even if they are thinking to do, and as you rightly said. As you rightly said, it is an individual's interest and responsibility. If one individual is ready to do that, definitely nobody is going to stop him or her.
Yep.
So moving on to Professor Santosh. Sir, India has a huge human resource talent.
Karuna,
Yeah.
once again, I think
Three
our
questions is
professor, No, sorry, he has some technical issue with his camera. So he's restarting his PC and coming back.
Okay. Okay, no problem. Meanwhile, we will be having this panel discussion. Once he
Please
joins,
proceed.
Let us know. So we'll have our. Again, back to Professor Santosh. India has a huge human resource talent pool living abroad. How do you tap into that talent pool and encourage them to come back to fill immediate academic policies of several countries to hire their own citizens will eventually mean Indians return home? How should the government prepare itself for such a talent bonanza? Scholarships or postdoctoral fellowships or lateral hiring schemes for researchers and faculty?
Okay, so there is a talent pool of people of Indian origin abroad that is very clearly that cannot be gainsaid. Now, this talent pool has developed skills and abilities in an ecosystem that is very different from ours. So when you hire someone from, when you want to bring someone in from abroad, what must be focused? The focus must be on the fit. Now I'm talking of someone who's got a PhD and who's maybe done a postdoc and who's probably working in a government research lab somewhere, and then you want to bring him back to let's say an institution in India like ISRO or something like that. A very good example of that would be Mr. Shekhar, our very own Sushil Shekhar. So now yes. So a very important thing to do there is fit. At that level, you have to make sure that the person you're hiring fits. Otherwise, you just shouldn't hire, because there's no point just bringing someone over for the sake of saying that you brought someone over, and if it doesn't fit, it will be a problem. So people coming back will find their own. People at the highest level coming back will find a fit in some place within this whole pool. Now now there really doesn't exist a group of students out there who want to come back and join academics. So a more pertinent question would be: how do Indian research institutions sell themselves as potential places for to pursue higher studies? Now that's a very deep question which we have all been pondering. Satya, myself, everybody, we don't really have answers, but we're all doing what we think is right, which is to build good programs, to put together this kitty of funding, whether from VCs or whether from government or whether from the established companies in terms of research, etc. So we've got to keep that going. And eventually, the thing is, if you make good opportunities available, people will come. Okay, and those that don't want to come despite the opportunities probably shouldn't come, because there is some other thing that is holding them back from coming. And even if they come, they will not be successful here. What we want is people who will be successful, right? So we create the environment for opportunities for people to come, and then we wait for it to happen. If it doesn't happen, then we're clearly not in the market, and we need to keep trying. At the same time, it is important to note that we have a very large talent pool of students, okay, who we mustn't ignore within the country. We have to think about selling ourselves even to this young talent pool that is available here as well, so that this can then generate the skill sets that the country needs to achieve all those lofty goals that Sivathanu Pillai and Mr. VASAGAM told us in the morning about. So that's really my take on this. I mean, and the government has things. The government has the DST Inspire program. They have the Spark program, the Gyan program. There are enough programs available. The websites could probably be a little better, well designed and updated with more pertinent, up-to-date information. But we have had people come on the DST Inspire program to IISc, and eventually they've found a fit within the department, and they're doing very well. So this will happen. If you make, it will not happen tomorrow. It will not happen in a year. It will happen over time, and we have to be patient for it to happen.
May I ask a very quick follow-up?
So what we take from this is Sushil sir, let the panel get over so that. So what I have understood is Professor Santosh says that definitely this will happen in a very big time, but he is very apt that the people who if the foreign pool of people come here, they need to establish themselves here and become successful in the arena here.
We have to ensure the people who are doing the hiring have to ensure that will happen. Okay, so you can't bring someone in from
making
you have to ensure that the person coming in you're going to leverage the skills that person has. Like for example, if let's say ISRO hires somebody, okay, who is a trained expert in for the sake of argument composite structures, and then as his first role within ISRO, and I'm not saying that ISRO does this, but it is purely hypothetical. His first role within ISRO is to put him in charge of procurement of parts for the PSLV. How does that make sense? Right? So there has to be a fit. When you're hiring someone with the talent pool of the sort that you're referring to, the most important thing is to find a fit and a role within the business we have here. And as the businesses organically grow, as the startup ecosystem grows, water finds its own level. People will come back and will find their place. Yeah. We just need to grow the ecosystem.
And also, earlier when you were answering, Professor, we also heard that already we are also, like in India, government is also taking many steps to groom those talents.
Personally speaking,
we need to connect them with that.
Personally speaking, I am sitting here as an ISC professor today because Satya Chakravarti made a very strong case for me to do this when he started the NCCRD program. So like you say, I mean, talent will come back.
Okay, good. Thank you, Professor. It's an well answered. I guess Sushil will be connecting you after this, Doctor. And going back to Dr. Tanige also. Before that, back to organizers, whether Professor Kyriakos have joined with us or still he is in issue?
No, he is not joined till now. So let us wait.
So kindly have a WhatsApp call with him so that we can have him on.
No, when he is received, I'll just implement.
About government research programs now. A good percentage of central government projects are not even applied for and end up as underutilized resources. The awareness of such efforts is abysmal outside of familiar circles, and that severely stunts research and talent. Would setting up internship programs at these government labs pull in more talent from across the country? How do we increase involvement from non-tier 1 colleges, like more than IITs and IIScs? How do we make people utilize that government?
Yeah. So it's a right question in the right time, actually. Most of the fundings, actually, faculties, funding to the faculties or R&D projects, only the tier 1 universities are completely getting what we can say. The projects, tier 1 universities are completely getting from maybe close to IITs and IIScs, and only the top universities and institutions these fundings accumulate. The reason here is that there are many reasons, but one reason we can say that there should be a kind of decentralization of these funding agencies' power to respective states, because in India the villages are more, and The only few tier 1 institutions are actually focusing on widespread research in the area of aerospace applications now. But you should, it is our duty, okay, even the responsibility of the tier 1 institutions, okay, to make the non-tier 1 to join in the schemes, and then kind of motivation should be given to the non-tier 1 institutions, so that everyone would take part in this kind of research, and they can be involved in getting projects, writing proposals. I agree with this. Your point is that the non-tier 1 institutions are completely away from getting projects from a funding agency and all. The lack of awareness they have, okay, in getting and writing a proposal and maybe approaching a proper funding agencies, okay, they lack in their knowledge in this kind of area. So the government should be able to actually make awareness. Okay, what are the trust areas available? For example, if you take aerospace applications, the trust areas, okay, or almost all the areas are trust areas. If you take aerospace application, because in India, soon, okay, even after independence, 70 years of independence, we are not able to even manufacture or design a small component pertaining to aerospace or aircraft. Even if you take drones, most of the components are imported from abroad, especially in nearby countries. So this is the chance. Whenever you have a kind of a pandemic situation, whenever you have a kind of crisis, okay, you can explore you can make use of this crisis to explore the talents ranging from maybe from remote areas. Okay, so so that okay, the talent should be coming out, and they can make innovative ideas and innovative products they can make. So this is where we are standing as far as aerospace application is concerned. For example, if you take a LCA, light combat aircraft, we are still struggling to even design and successfully design an engine, which now we are dependent on GE F405 engine. F405 engine is used. Okay, so the what I am trying to tell is that the opportunities are many, and the only thing is that we should make use of it. We should identify the right people, okay, and give them a chance to exhibit their talent, so that even India would definitely shine. Because we know very well, even Dr. Kalam came from our own illustrious alumnus. He came from even a small village, but he had exhibited his talent, and he had proved that he is a very good administrator, a very good scientist. Not only as a very good scientist, he is a very good human being and a very good president, simple people president. So so such kind of the students or the personalities should be identified. They should be given chance, and they should create awareness among these students, so that we can find out many number of public plans from even the villages and all. So the challenges are there. Yeah, okay. And as I already told you, if you take a drone and also take a supersonic aircraft, that is a scramjet, supersonic combustion aircraft, many things are unexplored actually. And even we go for lot of publications and applying for patents and all, but societal application patents, societal application journals are must actually. So we can publish more number of papers, we can publish more number of patents also, but how far your publication and patents are used in one aerospace application is very, very important. So what I suggest is that instead of searching for kind of people only from non-tier 1 colleges, tier 1 colleges, I'm sorry, you can search, okay, the people and the talent from non-tier 1 colleges, so that we can find many number of Abdul Kalams, okay, from even the villages also. Okay, so this is what, and also as I already told you, the funding agencies should actually decentralize their, because most of the the students or the faculty members living in the remote areas, they have to go to one point, maybe the Delhi or Bangalore, and of course the panel also should consist of or represent the faculty members or the experts from all kinds of institutions. The panel members should be there, even not only from IITs and IIScs, The panel members would be there from non-tier 1 colleges like even very good deemed universities are also there. So the representations should be there in the panel from all kind of institutions, so that it will even make the students be aware of such kind of panel is there, such kind of trust areas we can find out, we can apply for project and we can get a project. So these panel members even spread the news that they are the panel members, they can give projects if they do do projects in identified trust area. So the decentralization of the funding agencies, maybe they can make the state level universities as a focal point. The focal point. In turn, the technical universities. For example, Tamil Nadu, the technical universities, Anna University. It can be made as a focal point for distributing projects to and the colleges. The affiliated colleges or even deemed universities. So that I think this would help all kinds of students, to be aware of, faculty members to be aware of the funding agencies and the trust areas. It will also help them to write the proposals, as they can easily contact the panel members as well as the focal. So this is what my hands.
Yes, sir. So from this, the concern, what I can understand is you're trying to state that there is a lack of channel which should motivate non-tier 1 people to public to participate in funding and utilizing funding opportunities, and there is a gap where like the professors or funding agency committee should have professors from other than higher research institutes of India. Also, I like to you can find an aggressive statement that why the engine or not only from the non-tier 1 college professors or academicians or researchers, even industries are failing. But there is differences in way the industries set up culture and also the progress, where we can have ISRO successful and other things. And we do have a lot of OEMs supplying components for aerospace products. And a lot of composite OEMs are existing in India. And we are also having a good number of manufacturing product manufacturer, or even I like to remind you Rajhamsa, which is an Bangalore-based microjet aircraft manufacturer who have manufactured hundreds of microjet aircraft. So who have supplied microjet aircraft to Indian Air Force. So we do have experts here. At the same time, yes, as you said, also Professor Satya states again, and everyone's concern, we need to.
Yeah, I think so you can control all these people in the youth. Somebody laying their hand. Okay. So I'm so happy to welcome all the panelists in this forum. Let me start with our first panelist of Sheena, who's from Agri. So the panelists, I think we can have it like a two session. So the first session is going to be kind of a one round. I think you can able to share your own views and the challenges, or how you have initiated, what made you to initiate such a challenging startup. And it's not so easy to get into aerospace and get lots of funding, and we could not able to make it much more. So it is like pride moment, and definitely and much later. So definitely, I think yesterday you were sharing a lot, and today the students of Second Service will be able to have a startup with much more happy, more than in this conference. So I think Srinath is co-founder of Aviation, and I'll take a lot of contributed for the nation. Introduction about Srinath. Yeah. Srinath is a war shipbuilder turned aerospace engineer with over 10 years of experience in engineering, finance, and project management. He has a bachelor's degree in electrical engineering from Anna University and a master's in financial management. Previously using his multidisciplinary experience for crossing cross-pollinating ideas across various teams of engineering to solve large-scale problems that humanity faces today. He is deeply passionate about space and started Aviation with the simple idea that going to space should not be the hardest part of being in space. The movie industry is unwritten screenplay. So I think some kind of a versatile profile we can say. A person who's been agreeable as well as wanted to screenplay some of the movies. So thank you so much, Srinath. We're so happy to welcome you here. I think you can just give you a big introduction about Agnikul and what made you to start for our audience for 10 to 15 minutes. I think you can mute yourself.
Yeah.
Unmute. Yeah, thank you.
Can you hear me?
Yes.
Yeah. Okay. Thank you. Thank you, Gokul, for the introduction. So good afternoon, everyone. My name is Srinath. I'm one of the co-founders of this aerospace startup called Agnikul. And what we are trying to do at Agnikul is to build a launch vehicle that can take 100 kgs to low Earth orbit. So that is the product itself. So before that, the founding story and what exactly happened is, I was did electrical engineering for my bachelor's, and then I was working in the US in finance. Actually, did a master's degree in financial engineering. I was working there, and this was the time when the space industry in the US was really heating up, and obviously thanks to SpaceX for that. So there was a lot of chat, going on about what can be done in space and so on. My childhood passion was always aerospace engineering. So I was slowly drawn to that automatically, even though I was working on Wall Street and so on. So kind of made a couple of decisions to do a formal degree in aerospace engineering so that I know what exactly I'm getting into and also really understand if I have the passion and the grit to go with it. So did that and also moved to Los Angeles, right, which is where SpaceX was headquartered. So from that, I got a lot of ideas to actually understand where the industry is today, what can be innovated, what could be done, what cannot be done, and so on. And one thing that stood out was this launch vehicle problem, right, which I'll get to. But oh wow, let us launch a rocket. That is how the actual honest idea started. But then lot of people were making satellites in smaller and smaller sizes. We might have seen already about CubeSats, small sats, and so on. However, rockets were still large. And if you look at why rockets were large, it was only because at some point in time, satellites were all really huge. And rockets were just had to accommodate that level of capacity to put a satellite in space. But if satellites start to shrink, why can't rockets shrink? That was the the obvious logic that seemed to be missing at that point in time. So what were these small satellite people doing? They were doing something like a ride share, right? So if you want to launch 10 small satellites, you have to wait most likely for a really big satellite to be launched in a really big rocket, and there'll be space here and there, and you can sort of put your satellite in there somewhere and wait for it to go. The problem here is that you don't get to dictate anything as a small satellite launch, as a small satellite maker. You'll have to be at the mercy of the big satellite. So this was creating problems, literally stifling development in small sat tech, mainly because people were not able to iterate fast enough, and they were not able to make a meaningful business out of it. You could probably be like a university launching one or two whenever you get a slot, but you could not actually have a commercial stream of satellites being launched. So that is where these two things, my own passion for aerospace and sort of this business opportunity, started to add up. Of course, there were other people in the world who were also trying to do something similar. I'm talking about 2016, which is when I was in the US. Then, so once I realized that, decided a better place to do it would be in India. We have a lot of, spacefaring expertise. ISRO is here. We have done a lot. And we are actually no less compared to even the best in the world, at least in a few areas like launch vehicle technology, right? So India seemed like an obvious choice. I started to reach out to people, and as usual, lot of cold calling and one way or the other, after 3 or 4 to support this idea. So also joined by my a friend, long time, Moen is his name. He's my other co-founder. He was also sort of looking for a change in profile. He had an aerospace degree and was managing his family business. He also wanted to switch to something in space. When I told him about all these things happening, he got company in India in 2017. That is the story of Nicholas. So what we're building today is to address this launch vehicle problem, where rockets itself can be made smaller. We wanted to really solve the problem of waiting time, so that there is no question of delays and again waiting. Because if you make a small vehicle and again people have to launch a small satellite, less than maybe a month, 2-3 weeks, maybe max. That is the vision with which we started. Done a couple of things in that regard. One thing is mainly making the manufacturing time itself extremely low, and that one way to do that is 3D rocket engines, right? So just want to share my screen quickly for a second here, just to show you that. Okay, this is not allowing me to share my screen. Never mind, I'll probably fix it out when someone else is speaking and I'll show that later. But it's what we have developed till now is a rocket engine that is basically one piece 3D printed. So all of the complexities of the plumbing with a liquid rocket engine, we could compress it into one piece itself and 3D print the entire structure. So we realized that, and we've done different tests on it with IIT Madras, because we have the Professor Chakravarti sir connection. Through him, we also incubated IIT Madras, and we have been able to use a lot of their facilities for testing. So that has been the big growth journey. Other than that, we have been fortunate enough to raise 2 rounds of funding, right from also seed stage, where Vishesh from Special, who's also here, he led that round. And we've also raised another round of funding with 5 ventures and 6 or 7 other institutional investors who come in. So I think this will give us enough runway to keep our development journey going and probably target a launch with the government support in maybe 2 to 3 years of time. So that is our story, and I'll continue later after other participants talk as well. Thank you.
Thank you, Srinath. I think you had a very good passion on aerospace. That's initiated you to come back India and start this clinical. Definitely, I think ISRO, is already opened up. Government has initiated private player more than 5 years or 10 years. The rocket of Agnikul will be launched in Indian soil. So definitely, we wish us to have fun. I think now I can go with again Nukunj Ravi. So again, he is also from IIT, and same I think his mentor is Professor Ramakrishnan sir. So he also has initiated a Ravi Aerospace, which is a startup, and he also wanted to make a rocket. So I think maybe before let me bring up Ravi into the picture, a small introduction about him. Yeah. Radhi Aerospace Private Limited is an IIT Madras incubated company. So the key product of the company is a wax-based collapsible mandrel, wax-based hybrid rocket, and low-temperature gas generator. Wax-based collapsible mandrel is for the manufacturing of solid propellant with complex grain geometry to eliminate the need for machining, thus reduce the time and cost for the grain realization. So the company has an ongoing project with the DRDO Hyderabad. For this innovative solution, the company has received second prize in DRDO Dare to Dream Innovation Contest in October 2019. So wax-based hybrid rocket is a combination of advantage of both solid and liquid rocket stage. The combination has an ongoing project STSC Shard, Sriharikota, and low temperature gas generation has many applications in areas where instant gas generation is required. So the company also is going ongoing project with VSCC Trivandrum ISRO. So well, I think our Ravi is already connected with ISRO and working projects with Vikram Sarabhai as well as Satish Dhawan Space Center. So let me invite Ravi to the panelist, and he can say about few about himself and also about the company and what made him to start this aerospace startup even after completing his PhD in IIT Chennai.
Thank you, Gokul. You have spoken a lot, I guess, from my part also. So, just to introduce myself, and why aerospace? My BTech is from mechanical engineering. From my BTech time itself, I had this passion for the aerospace, but I could not do it then. So, I did my master's and PhD from IIT Madras in aerospace. And I had a very key interest in doing research in aerospace because if we see not just aerospace, we still import. We don't have it, or we use imported technologies that were imported in 80s or 90s. So I wanted to work on those things to come up with a new technology or to improve the existing one, and to come while I was doing my PhD. And the key product, as Gokul has already told, three of the key products is the wax-based collapsible mantle, the hybrid rocket, and the gas generator. Apart from this, we are also working. We have also developed the igniters to basically replace the BKNO3 igniter system, which is also something for which boron is imported from outside the country, and also to reduce its cost. And in addition to that, we have also just a second. Yeah. We have also developed the wear additive liner, which is actually for the defense application to reduce the wear and tear of the artillery guns. So this we are working with the ordnance factories and HEMRL Hyderabad, HEMRL Pune. So most of our projects are currently looking towards the defense side. Towards the ISRO side, we have two projects. One is the hybrid rocket that we are working with Sriharikota, and another is the low temperature gas generator, which we are working with VSSC, which is basically for inflating a inflatable aerodynamic decelerator. And apart from that, one more gas generator we are in discussion with VSSC for the starting of the GSLV Mark III cryo stage, which is currently being done by using the hydrogen gas. So we are trying to do that also. So this is the overall view of what we are doing. And what motivated me basically was my passion for aerospace engineering from my childhood, and my need for doing some research. That's what made me develop these products during my PhD and after my PhD. So thank you. That's all from my side. Gokul, you are mute.
A short introduction as well as about your company. So definitely, I think GSLV Mark III, which is the India's largest heaviest rocket, which we have already launched, and it has taken 5 tons of payload of Chandrayaan-2. That's the biggest achievement of the rocket. So definitely, I think much more. I think we have another speaker. I think Rohan. Rohan, I think we heard about Bellatrix. Same way. I think Agri-Gold, Bellatrix, and Radhi Aerospace, and one more. I think Skyroot. So they're all southern-based startup who wanted to initiate a rocket. And mostly, the people used to say rocket like a fearless and courageous people who could able to take such a kind of initiation in our country to make it up. So before we bring our Rohan into the picture, we shall have an introduction about Rohan here. Yeah, Rohan is M. Ganapati, is a CEO and CTO of Bellatrix Aerospace. News of advanced in space and propulsion system. He is an aeronautical engineer, and his area of work include electric propulsion, rocket propulsion, and space system engineering. Rohan developed and patented the microwave plasma thruster, an advanced type of electric propulsion system that runs on water as propellant and offers various advantages compared to existing technology. In 2018, Rohan was selected part of Club Young Leaders 2020 by the government of France and was also listed on Deccan Herald Changemakers 2020 list. Bellatrix was awarded PDB National Award 2017 from the Honorable President of India for development of technology with potential for commercialization. Bellatrix has raised £3 million in funding from Indian investors to support space qualifications of its propellant systems. So great, I think a good component with our Agnikul as well as with Aerospace from Bellatrix, which is almost there for 5 years. So another 5 years, it can reach 1 decade. So Rohan, I think you can work on and you can say again about your company. I said much more. So what made you to start, and especially IISc Bangalore? So more than IIT people will think the research generally happens in IISc, and more number of patent innovations comes out from there. So how do you feel, and till now, like Bellatrix, what wanted to make it up in the future?
Thank you, Gokul, for your kind introduction. Before I begin, my congratulations to Team Agnikul for raising their capital and for Nikunj. It's great to hear that, and today only I'm getting to know about Rathi Aerospace. It's very interesting. So we started Bellatrix, myself, my co-founder Yashas, and my friends, two of them from college, Sagar and Vivekin, way back in 2011. So when I was 20 years old, so still in the UG. Space always fascinated us, and we wanted to do something on our own, and propulsion being the key interest to us, we wanted to see what the industry lacks and what is that we can do. And looking at how the global privatization of space ecosystem is going, we were keenly following it. But the main goal was not to start a company back then. The main goal was to do some research and get into some Ivy League universities abroad. So that with that goal only, hybrid rockets for suborbital payloads, but that ended up in a very nasty disaster. As undergraduates, your blood is boiling. You're always very passionate, but you don't know the nitty-gritties, or you don't know what is safety, all these things. So we had a very bad explosion, and seriously, started mastering in every subject possible, other than what college has to offer. So we were able to convince a few of the eminent industrialists in and inside Coimbatore to fund our projects. And I happened to meet Dr. Kalam when I was that technologies like electric propulsion has to come in India. So that was the key starting point of how Bellatrix started. So Srinath actually told about satellites being miniaturized and the need for a small satellite launch vehicle, and how can with something called as in-space propulsion. So that is the engines which work once a rocket puts a satellite in space. As you know, today most of the communication satellites, be it Earth observation or geostationary satellites, they use their onboard propulsion system to do orbit raising and go the propulsion system itself. So that which leaves very less margin for the payload. At the end of the day, it is payload which gives you return on investment. So on board to do orbit raising. Electric propulsion was, the answer. But it's a very, very complex subject in itself, and you need a lot of expertise in deep, high-end mathematics and computation, which we took a challenge that okay, we will read and we'll slowly develop. Of course, we got good advisors who helped us in the subjects, and we developed a propulsion system which runs on water as a fuel. We ionize the water into state of plasma, and we accelerate it, which gives you thrust. So the advantages, say for example, if you have a 3.5 ton satellite where 1.8 tons is fuel only to do orbit raising, here you would require 200 kilograms of fuel, that's it. Because of your specific impulse, the mileage is much higher in electric propulsion. So this project was started in 2011. 2015, it was successful. It yielded its first results. That was when the former chairman of ISRO, Kiran Kumar sir, got to know about the development and gave us our first order to develop and qualify this propulsion system, which we have successfully now delivered to ISRO. So in 2015, we moved to IISc to pursue further education and research, where the team also expanded parallelly. So now we are 30 people, and we started targeting the problems of nano satellites all the way up to bigger satellites. Electronics can scale down, but propulsion cannot scale down. So we worked out a very innovative method of scaling down, which we call as nano propulsion. And we have different classes of propulsion systems for a different weight class of satellites. And we are working to space qualify them this December and next year, March. There are 2 launches which we have signed up. And we also got into DRDO. We work with DRDL to develop green propellants, that is replacing hydrogen next future generation. Propulsion systems company. And we want to make space more accessible by providing better, in-space propulsion products. So that's the short thing from my side.
Yeah. So thank you, Rohan. I think your startup is blessed with our excellent Abdul Kalam sir. Value of next level the electric propulsion, as well as how to connect the solar handled power itself to make some kind of power generation for satellite. So lots of ideas he has given our space firing nations. So definitely the best wishes, I think, almost as I seen, I think you have started 2015, but I think you said 2011. So another one more year to celebrate your 1 decade. So you are the senior most startup in India. So wishing you all the best. Thank you for joining here. I think we have thank you. Next, I think we have Jagadish. I think he's my close friend. I think I visited his company like 2 or 3 times in IIT. So they have an incubator startup. I think I can say that Agnikul, Radhi, and Bellatrix are doing a rocket, and Jagadish is creating an enthu among the youth. Starts from, I think, maybe from first standard to a level of degree holder. What is the space? What is about Aero? What is it about to make a rocket? Lots and lots of more things he's making, and he's inducing them. And I think he's also kind of a associate director and making movies. So I think before he opens up, I think I should read his profile. So just here. Yeah. So Jagadish Khanna is an Indian stage actor, playwright, and film director. And he's also like done Never Give Up a theater inspired by the life of Olympic athlete program. And he is a founder and CEO of Vice Chancellor Aerospace, an educational and research firm combining 2 disciplines, theaters and aeronautics, with the motto of taking aeronautical knowledge to every village across the country. The Vashishtra Aerospace is an incubated and funded under IIT Madras at PBA. So I think he is also an aerospace engineer. Yes, Jagadish, I think people wanted to start a startup based on making a satellite or a rocket. So what has made you to initiate this aeronautical knowledge to travel among the village? And very important, I think now there are so many applications are coming out. We see drone technology. Drone is one of important. It wanted to widespread everywhere, maybe from agricultural or disaster or even our COVID. Much more people, government were taken up drone as one of the key tool in making a social distancing, spreading the disinfectant. So what has what has made you to start a kind of a startup?
So hello everyone. Hi Chennai, Nikunj. Hello Rohan. Hello Vishesh sir. So my name is Jagadish. I have done my master's in aeronautical engineering, and I'm a theatre artist from 2009. So Vayu Shastra is officially incorporated in 2018. The main problem we are addressing is, I'm from a small town, Tanjavur. I am very passionate about aeronautics. From my childhood, say when I was 5 years old, I used to run out and see whenever the aeroplane goes, I just go and look up. So, I am very passionate about theatre, acting, both. So, when I done my UG, I've done my masters in aeronautical engineering, but before that I did my UG. The amount of the knowledge transfer is it's very less. There is a lot of difference. What is needed for the industry and what is delivered in the wherever we study. There is a huge gap, knowledge transfer gap. So accidentally, how this happened is when I was full time into acting. So I finished my masters. After that, I worked in a company as a research and development engineer, building anti-vibration. Got into full time acting. So that time, when I was a full time actor, I get so much free time. So I started conducting workshops for children using paper planes. I know how to make some 50-60 varieties of paper planes with different aerodynamic properties. One goes straight, one goes left, one goes right. So I started conducting workshops. One of my theatre trainer, Yog JP and Krishna Kumar, they told us, why don't you combine theatre arts? So if you take Indian mythology or any mythology, there's a strong connect with flights. Ramayana, Mahabharata, Greek mythology, Daedalus, Icarus, Chinese mythology. If you take any, there's some connect with flights. So they told us, why don't you combine some stories? No, I tried. My first story is Ramayana. Ravana tries to kidnap Sita. I got two actors to act it out, and I was Ravana's pilot. And when Ravana was asking what is left wing, why the left wing is called port, why the right wing is called starboard, there are so many inventors who are trying to invent aeroplanes. Why we call Wright brothers as the inventors of the airplane? So all these small questions have very strong story behind it. So I started to deliver these stories, and I started embedding the science with these stories. So we got very good response from children. So I started these stories first. We started like 8 to 14-year-old children, and very good response from children. And this word of mouth started spreading. Once my movie got released, the one actor is doing this kind of workshops. So it got some media attention. Then now my friend told me, why don't you approach IIT, RTBI? They support this kind of innovative ideas, rural development business incubator. So I approached them. They found it in the first thing they said, this is not scalable. So what I did, I formulated a business plan. Maybe I'll explain that during the next part. So we started in 2018. Then I started designing syllabus. Agnikul, Bellatrix, or any other startups which have funding. So all the startups, maybe in the next 10 years, they're going to be huge. All these companies will be in need of so much of manpower, skilled manpower, not just someone who comes, aeronautical engineer. It should be, if aeronautical engineer comes out of college, he must already know the basics. Okay, what is a hybrid rocket? What is a liquid? What is a solid propellant? They must have some basic knowledge how to do all those things. To be frank, when I was in UG, there was zero exposure. I have no what is a solid propellant rocket. What is a liquid? Once I got into PG, 6 or 7 years old, he has to wait for 12 years to finish his college to study this. He don't have to. It doesn't have to be. Anjuesa, we can tell them the stories at whatever his understanding is. When he's 10 years, I introduce a lot more story with little more technology. So when he's 12, finishes his 12th standard, he's already half aeronautical engineer. So I'm addressing the skill set problem here. So yeah, I will keep telling more about it. So this is a short intro.
Okay, thank you, Jagadish. I think Vayu Shastra, right? Pronounced. Vayu, okay. So I think good. I think you are creating more Elon Musk in our country. So that is the initiation of your aerospace. Definitely, I think, and also supply more manpower for our Agricul and other startups who are already engaged. So happy. And you have taken a different initiative, that is theatre work plus Aero.
So that's important. I think right now. I think.
I'll explain why I'm combining theatre. Maybe in the later part.
Yeah, definitely.
I'll
Yeah,
explain
we
the
will go.
impact. I'll explain the impact of theatre in the second part.
Yes, yes, very important. And also, I think I will want to have some kind of sharing from you about the 90 ml movie, since you are an associate director. So we'll discuss it later on that one. Thank you.
I also am Sarvan Savan. I'm also assistant director.
Oh, okay.
So I usually
90 ml.
choose all the offbeat movies. All the movies I did 4 movies till date. All the 4 movies are offbeat movies.
Okay. Yeah, I know. Why I'm saying 90 ml, we have movie army. So that is what the name is. Triggered up everywhere. Okay, thank you. Yeah, thank you, Jagadish. I think we have a last panelist for our first round. I think Vishesh. I think Vishesh Rajaram. So startups, I think they can able to invest their knowledge, invest their innovations, invest their time. But more important, fund is required. So Vishesh is doing a lot on that, and he is initiating how to make a crowdfunding or like how to invest on the this kind of rocket making startup, because making a rocket is not so easy, and we have to always like think it's true or false or go or not go. Somewhere it fails to invest, it has to be invested. So here we have Vishesh Rajaram, a managing partner. I think some noise is coming up, and other people can mute it. Yeah. So Vishesh is 12 years of investing across the enterprises, technologies, and consumer services. He was crore technology venture fund, where he has made over 8 investment across electronics, hardware, financing, technology, and consumer service and healthcare. So he was a corporate banker at ICICI Bank, managed almost like 320 crores of Indian rupee on the asset portfolio. He has a MBA from Indian School of Business, which is listed up Dean's list top 3% qualified chartered accountant, and Bachelors of Commerce from University of Madras. Invested, advised in his personal capacity in over a dozen startups in India, Israel, and the US. Prior to joining VentureRace, Vishesh has previously built a solid, sold a pharma manufacturing and co. So I think a versatile profile we can see. A commerce person went into banking and then built a pharma manufacturing. And now he's pumping up huge money for so many startups where India needs it. That's what the government is also looking forward. How the Made in India can be brought out, how the young, like almost 130 crore, we have 80 to 90 crores of young Indians, how these people can become an entrepreneur. So let me welcome Vishesh for our panelist. So moreover, all the panelist people are waiting how the Vishesh can help them for making a fun or crowd feeling to get a startup to make it up. Vishesh, you can start up here.
Yeah, thanks, Gokul guys. Pleasure to be here. Always exciting to see some of you guys. I've just been speaking to a lot of the people on the panel before. Know some of them, and pleased to know some of them now. Just a quick background, Gokul. We run a fund, and this is a fund that is sort of registered under SEBI, and it's a closed-ended fund. We don't crowdsource. We sort of have a set of investors whose money we manage, and whom we sort of invest in startup ideas. The focus of our fund primarily is to sort of invest in deep science and deep tech companies. And we've spent the last 2.5 years studying opportunities in, particularly in space. I remember meeting Rohan maybe 18, 20 months ago. Of course, we've invested in Srinath's company, as you all know. And of course, I've also met Jagdish quite often on his ideas. Our interest in space technology simply comes from sort of 2 steps. One, on Earth at a macro and at a micro level. And that access to intelligence and data will allow businesses to conduct themselves for new opportunities to come up. The other aspect that got us interested in space was we felt that the industry was seeing some radical changes. We began to understand that there was a fair amount of miniaturization in satellites. Cost of launch was also coming down quite drastically. And all of this started creating more opportunities for different players in the ecosystem. There are opportunities for space propulsion companies. There are opportunities for ground propulsion companies. There are opportunities for satellite manufacturing companies, all of them in the upstream, and of course on the downstream side, the whole geospatial tech analysis and downstream stack are all extremely valuable opportunities. And we've participated in 3 companies thus far. We're partners with Agnikul, which is a ground propulsion or a launch company. We've also invested in a company called Astro Labs. They are making optical communication terminals for space and ground stations to sort of radically disrupt the satellite communication space. And we're also investors in a company called Kava Space, which is a downstream company focusing on helping businesses make better decisions with space intelligence. So that's our interest and that's our motivation. Do we continue to look at this sector? The answer is yes. Do we continue to look at other sectors? The answer is yes as well. For us, the criteria is that the quantum of innovation needs to be fairly high, and the technology differentiation or the moat that is being created as a result has to be quite strong. And for the other aspiring entrepreneurs out there, we're a seed fund. So we typically invest anywhere between $100,000 to $500,000 in the first check. So that's sort of our size of operations when we make investments in companies. If any of you want to reach us, you've got our email ID on our website. Feel free to drop us a note.
Okay, thank you, Vishesh, for your introduction and also the where your company started investing and how they created. So I will start with you itself. Like, how do you see this new normal? I think the post-COVID. So we have 3 verticals. Before March, I'll complete it. Before March, we see there's something like, and now we are all in the COVID. And I think maybe after August or September, the industry. Generally, I'm asking not only in aerospace, the complete startups. How do you think what's going to happen? And how the government is also helping, like to promote these startups.
So I think it's a complicated answer because it's very case specific. What's important to realize, whether it's pre-COVID or post-COVID, is what has happened to your customer base and that value chain, right? And if, for example, if it's a restaurant business, it's clearly seeing a very new normal because not everybody is going to go to a restaurant and eat immediately. And even if they do, they're going to run at 40-50% capacity. But like I said, we're a deep science, deep tech fund. So all of our investments of the entrepreneurs that we work with are typically those operating in business-to-business environments. And hence the impact has been definitely relatively lower than it is for, let's say, some of the consumer-facing companies. I think our learning has been that there are 2 sides to it. One is the requirements to raise more capital in the market may take longer. It just means that you have to sustain yourself for longer and continue to make progress with your customers. Specific to space, I think there are 2 or 3 moving elements there. There is a supply chain element that may see some issues because if there are companies that are procuring materials from different parts of the world and doing a fair amount of assembling, they may see certain challenges because supply chain may not be working as smoothly as they were 9 or 12 months ago. So there are opportunities there. The second piece is, I think aerospace also has strong elements of nationalism as well as geopolitics involved in it. And just given the recent success of what the Americans have had in the last 24 hours, I think you'll continue to see a lot more of the nations double down their budgets on space. And I would expect similar things to be happening in other countries as well, which means that there is an opportunity for some of the private players to be supporting that journey and being part of that journey. You said they may be stricter on budgets and they may sort of phase it out. So I'm not going to jump up and say the world is a better place to be in. I think there are issues, but there are a lot of bright opportunities out there at the same time.
Okay. what make you to invest much on the space? Because like when we see Elon Musk, the story of Elon Musk, so he is not become so fascinated in the current initial time. He lost so much of money because the rocket has not taken up and lots of blasting has happened. And again, the government of US has pumped up huge money, and they believe that. Tomorrow, I think if they take some rocket, if it is not success, how it can be like correlated with your funding aspect?
So I think different people take different sorts of risks at different points of time. Let's not forget that Elon Musk did what he did at a time where nobody thought about it. Today there are a lot more people who have been sorted for. So nobody's reinventing a lot of what Musk has done. For example, Srinath's going after a very different opportunity. Launch payloads of 100 kgs or less. Rohan's going after very different opportunities, looking at space propulsion for a certain category of satellites. So the opportunities are deeper. A very intuitive way of addressing risk along that process. That I don't think most of the entrepreneurs that we are working with and we've met have a binary strategy. Potential roadblocks that may come along their way. The good part is all of them are very seasoned folks. They know that this is not, this is not writing a single line of code and publishing it on GitHub. It's a lot more than that. And I think they've sort of all of them thought through contingency fairly well. Of course, we're in the risk money business. We're not. We don't have any guarantees of life here. We'll have to see and trade. I think at this point we're very confident with the founders that we're working with.
Okay, thank you, Vishesh. We'll come back to you. Let me start with Srinath. Srinath, Agnikul, I think it's one of the fast-moving. Even I heard it with many of even our recently director VSSC Somnath. He also said about Agnikul and Bellatrix, like much more private players are engaged, and definitely ISRO is going to support them. But how do you see the investment and returns on your startup? Because aero industry, the growth is, we cannot be able to say how far it's going to be grow, especially on the startup base. So companies, many have invested on you in making a rocket, that too like a 100 kg payload. So how do you going to make a return based payload, or how we can able to get profitable on that?
Sure. So we believe there is actually a strong business case for this, right? So we've already been speaking to a lot of customers, about 70, 80 of them now, and we have letters of intent from a few customers. So what that means for us is there is a strong validation for what we are trying to do from a user standpoint, right? So even though we are all enthusiasts and we want to build a rocket first, we do get that constant validation from people who will finally be paying for this even today. So that I think is one, one sense of security that we have, that okay, we are actually solving a problem that people are. Right? So that is number one. Number two is there are other success stories to point to in the world. There have been other companies that have trying, if not exactly the same thing, something similar, and they have raised reasonable amount of money, and their business case seems to be quite strong too. So it is helpful that when you go being in India, being in a place where ISRO has done a lot of these things at a very inexpensive level compared to what others have done, we could do it in a much in a nimble manner too, in an efficient manner too. And so lesser money, probably lesser time, we will get the same thing to happen. So that is how we're looking at it. There is a business case. We talk to customers a lot, and there are other people who are showing strong business cases across the world, and we could do it more efficiently. So that is how we plan to return the investment to our investors.
Okay, okay, that's right. But now ISRO has taken a new, we have a payload of 1.5 ton with PSLV, and even 5 tons with the GSLV on the lower orbit. Much more 8 tons in the GSLV on the lower orbit. So with that, I think now the entire globally, the small satellite is playing a very important role, and ISRO is going to initiate our first rocket maybe by this year end. So the launch of first rocket is going to happen. So how do you feel with your Agnikul and SFLB? So can you able to compete and break down the market and take it to your Agnikul, or ISRO being it will become like a competitor for you in the future?
No, I think you're too small to think of ISRO as a competitor, right? I think it's not even in the same platform, I would say. So I think of that as an extension, right? So there is GSLV, as you said, it's been proven to take up to 5 months to lunar transfer orbit, and then you have the PSLV, then you have the SSLV now, which is, I think, if I'm not mistaken, in the 500 kg to 800 kg range of payloads. We are looking at lesser than 100 kg actually, right? So it's the extreme end of the spectrum, looking at how you could launch, say, just a 20 kg satellite or just a 10 kg satellite, right? And still be profitable as a company, as opposed to even looking at bigger ones. So we think of that as a complementary, additional tool that the country would have to launch even smaller satellites if they have to go immediately for some reason. So that is how I'm viewing the SSLV.
Okay. Yeah. And okay. So now, how do you see your startup from now? I think COVID, there's a new normal changes happened, and now like a big digitalization or many predominant innovations can initiate. People are saying about it. And where do you see Agnikul from now to 6 months, and then 1 year, 5 years?
Yeah. So I think the last 2-3 months has been processes. Usually, as a startup, you're running around trying to do everything, even on the hardware side, without having a very rigid process about it. But I think even Rohan mentioned this sometime before. Focus on safety, focus on process, focus on documentation is very important for an aerospace startup or for any aerospace company. So we've taken this time, and we have done a fair bit of that in the last 2-3 months. So that is how we have actually, gone. I think would be about more engine testing we can do at IIT Madras. So that will be continuing. That will definitely be a plan. And probably a year and a half from now, we might have to raise another round of money, the last bit of money required before we actually attempt an orbital launch. So about 1 year plus, I think that is where we'll be. 1.5 years from now, we'll be again into a little bit of a fundraising mostly. And I think also the key here is by then to have a almost ready vehicle where the last bit of fabrication is what is pending, so that we could just go and launch at that. So that's how the next 6 months and 1 year will look for us.
Okay, thank you, Srinath, for your very wonderful the questions answerable. Now with Radhi, I think Nikunj, so you said about you have been initiating, you have made igniters and also like a wax-based mantle.
Yeah.
So wow, I think I have seen in your profile there are few things about hybrid rocket. So yes. Can you say about like what is that hybrid? Is it like equal to like same solid propellant, or the electrics what they're doing as water as a fuel or propulsion system? So what is it like from your point of view?
Yeah. So hybrid rocket, as the name suggests, it's a combination of a liquid and a solid rocket. In our case, we are using solid fuel, which is wax alone, as well as wax and aluminium to increase the density ISP. And our oxidizer is both liquid oxygen as well as hydrogen peroxide. Hydrogen peroxide is Gokul. If you can mute, there is a lot of sound coming from your side. Yeah. Thank you. So so oxidizer that we are looking at currently is both the LOX as well as the hydrogen peroxide. So LOX we are looking for the ISRO point of. The hydrogen peroxide based system is for Earth storable system, which we are looking for the strategic missiles, upper stage of the strategic missiles, which are currently solid rockets and have a small VTP unit basically to trim the velocity towards the end of the propulsion. So thereby implementing. So in our case, the hybrid is like this, but there are many options in hybrid. There are many fuels and oxidizer combinations that can be used. But what we are using right now is based on what research we have done over the years with our experience in those systems, and in some way or the other, the advantages that we get with Google, you're mute.
Yeah. Thank you, Rajiv. So how do you see the innovations behind these technology? Because I heard this wax-based in ISRO, we have not seen such kind of technology, not in the recent days, maybe 4 decades. Before that, the initial nations are using this technology, or in order to increase the ISP, you have taken this, and how far you have been come up with this?
Yeah, so the reason for choosing the wax based hybrid system is been the research that has been going on in the lab where I have done my PhD. It is a very old thing actually. If you see, it's nearly 30 years old technology, and there are a lot of research publications. If you see all around the world, you remember the name. They make hybrid rockets with wax as a fuel for the US Air Force applications. And in terms of where are we standing right now with this hybrid rocket is, we have initially what we have done is testing at our end, but then we have done testing at the ISRO end, which is currently the user for us based on our projects that are going on. So we have done more than 15 firings in both Sriharikota as well as VSSC Trivandrum, and we have obtained ISPs of almost close to 100% in SHAR. And in VSSC we have done both wax as well as wax and aluminium, where they are looking for making their RS300 into a hybrid system, basically to demonstrate the technology of hybrid system. So they are using LOX and the wax as a fuel for that case.
Okay, good. So do you think that this is going to be used for our RLB, or maybe like for the upper stage of our rocket?
Yes, it is very useful, because if you see in terms of complexity or in terms of cost or in terms of performance, in terms of complexity, it is half than a liquid system because it has only one liquid to be handled. In terms of the advantage, it is having much higher ISP than a solid system, and same ISP as a liquid system. What a LOX kerosene system would give you the ISP, it has the same ISP with half the complexity. And in terms of solid, again, it has the advantage of being throttleable. So you can change the thrust on command like you can do on a liquid system. So it takes the advantages of both the systems and combines it. So since you have only one liquid to handle, you have a lot more less plumbing to be done, a lot more less complexity in the system, which also helps in reducing the cost. So you have the same performance as a liquid system, but half the complexity.
I think I have seen there is some few projects you are doing it for DRDO. So
Yeah.
can you explain about it? What it is? Similar of rocket-based projects or something different? On the same?
Yeah. So the projects that we have with DRDO are morely towards the defense application. We are not limited to just the aerospace application. We are also doing work in defense. The wax-based collectible mandrel which we have, that is basically for the manufacturing of solid propellants which have complex geometries which require machining. And there are some applications in ISRO as well, but a lot more in DRDO side, where there are a lot more complex geometries which requires machining of the propellants, and which is a hazardous and is one of the things. Other is the low temperature gas generator that we have made. That is we are in discussion with the army. That is for the inflatable decoys. Inflatable decoys which can be of any shape of or any system. Let's say a tank. With ISRO, as I mentioned, for this inflatable aerodynamic decelerator that VSSC is trying to do, and also for the starting of the turbo machinery of the JSLV Mark III. So those are the extensions of our defense projects towards the ISRO, and liner, which is for the artillery gun applications. So those are pure defense products. And then another is this the there are some things that can be used for both, and then there are exclusive things for both as well.
Okay. Nukunj, one more. I think, how do you encourage this young aero engineers? Can they have any kind of like an R&Ds with your startup, or what can they do? Because now this COVID is going to have a very big hit in the aerospace sector. So the employability and going for a master's, everything is becoming a question mark. So what is your view on that, and how they can able to overcome?
Yeah, so to the people who are doing this aerospace in their bachelors, as Jagdish said correctly, that they lack a lot of field knowledge or the detailed knowledge that is actually required when you are going into development of a product. They only have a bookish knowledge of the overall idea of how things work or how things are. But when you put them to design something or make something or do some experiment, they lack that. So I guess one of the ways is that they should do their masters in institutes which do practical problems. So that gives them a lot of hands-on experience. And yes, as you said, internships, that is also very useful. The IITM, the research park, actually sends regular invites to all the startups to take up the students for the internships. So that is also a good way in which they can get good hands-on experience on the system as well as designing. Maybe when they are having their vacation of summer vacation of 2-3 months, that is a good time to do that as well.
Okay. Okay, thank you, Nikunj. I think we'll go with Rohan.
Yeah.
Rohan, I think you are there, Rohan?
Yes, I'm here.
Yeah, Rohan. So you set up a green propellant. So what is that, and what you have done it? Because still I think about this chloric acid. So the solid propellant which creates more amount of chloric acid in the atmosphere, and again it's get a big problem. So what is green propellant from your point of view, and what you have discovered, or what you want to bring it to the space station?
Correct. Gokul, as you might know, when you are refueling a satellite, you know is handled, the way UDMX is handled, it's very toxic, it's storage conditions, everything is like very expensive. Even though it's a proven technology, the money which you invest in actually storing and using it is like very crazy. And the performance parameters is also not that easy to handle, and it is not toxic or carcinogenic as hydrogen, which can also be a liquid and a solid. So we work on a compound called as ADN, ammonium dinitramide, which we have a patent for actually producing it both as a solid salt and as well as a liquid. The advantage with this is it offers a higher specific impulse. You can actually fuel the satellite, say for example, if you're building it in Bangalore and then taking it to Sriharikota, it can actually be fueled at site itself, need not be fueled where it's integrated with the rocket. And it has very, the combustion products are basically water, steam in our case, and carbon monoxide, unlike ammonia, which comes as a decomposition product of hydrogen. So this way we call it green, and this way we work with LPSC in Bangalore and DRDO in Hyderabad to make it into a commercial scale. So we actually produce it at lower quantities. Now we are working with them to increase the production quantities.
Okay. Yeah, Rohan. And how do you see this government initiative on the startup? So do you see the encouragement is happening? Still, there is lots of policy level change should be happened, especially on the aerospace and defense sectors.
You're right, Gokul. So we have been talking to government since 4 years, especially my colleague Yashas, regarding with this space policy and space law matters, which I think Srinath is also well aware and they're also part of it. Yeah, you can answer this question in this way. So we didn't face any problem when we came into this industry because we were working on some collaborative technology which ISRO itself took initiative to come out and support. But when you really talk in terms of rocket and all, lot of cost, and rocket is NED missile. Okay, so how do you protect these technologies? And all these questions, policy level answering is required. And it's a very good thing that government has now taken notice of companies coming in India, and they're seeing it as not competition to ISRO. The collective space ecosystem can grow. So in that way, it's a good welcoming move. But again, as I would say, the devil is in the details. So we have to wait and watch when they release the complete document, what is hiding, only then you can come to know. But as of now, it's a very welcoming move. And country.
Okay, Rohan. This is another like. So if a person like a new engineer or who comes out with a fresh, so if he want to start a startup, so how far he can able to enable and how can like the challenges what you have faced is it's going to be similar or they can easily come up and they can have a very good competitive with your level.
It's a good question, Gokul. I think Nikunj Rati also answered this question pretty well. If you look at the undergraduate scenario in the country, and the knowledge is just limited to book knowledge, and exposure to actually what is happening in the industry is very limited. And as you know, Dr. Kalam inspired many students to choose aerospace as a field. And there is good success in that because many students look at him and then choose the field. But after they choose, they really don't know what next to do. And that is where I think institutes of eminence, which has done a good job in aerospace like IITs and IISc, and ISRO and DRDO should open up for internships rather than just a visit, where actually and do their projects there where actually a student can come to know. In our case, we learned it like in a really experiencing, very difficult way we learned it. It was never easy. And finding advisors in the core domain like electric propulsion is very difficult in the country. So our case, we only had perseverance. We didn't want to let go. So we had this fire in us to fight. So the problem is, it took a lot of time for us to realize. So now what you see is there are a lot of advisors and expertise available when you compare it to 2011. So people coming out, they already have people who already have experience or done something. Interacting with them would make things easier for them. That's what I would say.
Okay, so you say that I think a small ignition minds so that they can withstand this startup and they can able to come up. Can you also brief? Yeah. Can you also brief about this your water-based fuel? So what it is like, because it's a new topic. We see that hydrogen-based fuel or something like water is used as hydrogen-based fuel for running and tube, and what it is like.
Correct. So just to be clear here, electric propulsion can't be used for rockets because the thrust which it produces is very less. At the same time, it gives you a good ISP. When you look at space, there is no other force to stop you. There is no drag, right? So Newton's law holds true. So constant acceleration is your engine velocity. And since there is no equal stop you, your acceleration keeps on increasing. So that's why electric propulsion is a hit in space. And basically the choice of fuel for electric propulsion is xenon gas. Xenon is very, very rare and it's extremely expensive. 1 kilogram can cost you up to 20 lakh rupees, just a kilogram. So that's why we wanted to try something very different. And when we talk about going to Moon or Mars, if you want to carry meaningful payload to the lunar orbit and bring back, it makes sense not to carry the return fuel to Earth, because you can carry more payload to Moon. And if ice is available on the Moon, you can refill your engines and come back. So this was the concept. On the other hand, to make it viable, we don't combust water just as you think. So of course, water has hydrogen and oxygen. If you do electrolysis, you split it into two, and then two gases. If you combust, you have a good combustion like a cryogenic engine. The end product is again very clean steam, but it's a very slow process, electrolysis, and the ISP, if you do chemically ignite it, is very low. Instead, what we do is we bombard it with radio frequency waves and convert it into a state of plasma. And as you know, plasma is very responsive to electric and magnetic fields. So using an electromagnetic nozzle, we accelerate this plasma to greater velocities, like around 10 kilometers per second, which gives you thrust. So, and that's where we have been successful and got patents for it. How to actually stabilize the water. It turns into steam. So we then bombard it with radio frequency waves and confine that plasma in electromagnetic fields and accelerate. To it sounds easy by theory, but practically to power becomes lesser and lesser. So you use normally nuclear batteries, as they're called RTGs. But if you want more power, you can carry a to the solar system. So these are very futuristic technologies, but sadly no entrepreneur can lay his hands on, because any atomic technology is very strictly controlled by the government. Only if that is lifted, or actually these technologies should be explored by ISRO, I would say.
Yeah, rightly you said. Okay. I think I can go with Jagadish. So who's ready to supply manpower to all our startup by his more skilled people. Jagadish, we see that 6 months before, when Chandrayaan 2 was launched, I think the entire world, including India, the young people, like in a cricket match, they are all awaiting to see the rover to step inside the moon. And that kind of a curiosity has made in our country, especially the Chandrayaan, I can say. So how do you feel in India, especially on Aero? The curiosity is just like that, going and seeing there is an aeroplane, is there, a moon is there, or I want to become Sunita Williams, something on the base, or really they want to contribute the technical stuff or innovations to develop such kind of rocketry?
There is always so much love, there is always so much curiosity. But the problem is they don't know where to go, how to go, where to study, what to study. So, for example, say 11th standard or 12th standard student, they are very much interested. If they need a certain set of marks to get into tier 1 colleges or tier 2 colleges, they end up entering tier 3. There mostly the interest is getting killed, or not killed, the proper knowledge transfer is not happening. Unless he is a kind of self-motivating student, he himself go and search on YouTube or search in companies which does this thing. So otherwise, basically his passion or curiosity is getting dumped. So he end up joining some call center or something which is not related to his field. Even if he finish aeronautics engineering. This is for 11th and 12th. For others, say for example, if a 5-year-old, 8-year-old, they are interested, so aeronautics flights, even pilots, but there is no proper walkthrough or someone to guide them. So we are addressing that. We discussed. I had a discussion with Srinath Agnikul. They were asking him, why don't we come up with a plan? This is the set of skills I need. So I can get the students and train the students for this set of skills. And we can send it to Agnikul or even Rati Aerospace. Depends on their need, I can supply the manpower. So we were discussing that. He was saying it's a very good idea. In future we will implement this plan. So I'll get in touch with all the startups in aerospace industry. Then I'll collect all their needs, and I'll start in which way they want the manpower to be. So I'm getting in touch with all the colleges, even schools. I have a team of say 8th standard or 7th standard students who are very like above their level. So I found an advanced level team. They are learning how to build cube satellites. They are learning how to build antennas, bipolar antennas. So the curiosity is always there, but they don't have a proper channel.
Okay, Jagadish. So, how do you think that this can be solved? So, you think that they have to get a special skill for this, otherwise, like every school and colleges, they have to change or model the cube syllabus on these areas.
Yeah, that's what we are trying. So, what we are doing is when it comes to air or any other subject, the way they teach or the purpose of their teaching. Say, for example, if they are teaching in maths, say why would they are learning differential calculus? Why they are learning integral calculus in 8th or 9th standard? They are not explaining the practical use of it. So if you start teaching the children, say if they are teaching Newton's third law or a Bernoulli's theorem in 11th or 12th standard, they need to tell the real reason why they are learning this. If they start then I'm like the students who are coming to Vice Chancellor, I usually take them to Agnikul or Fabit. There are few companies we always close we are in touch with. We take them to the company, we show them what's actually happening. So we are trying to show them what the industrial need is. In touch with some 20-25 schools. Most like out of 25, maybe 15 schools reduced as ASA. Some schools taken us as a part of their curriculum. So we feed the knowledge through theatre arts, and we tell them you are learning about aeronautics and you are going to apply everything practically.
Correct. If you see the panelists, I think other than our Vishwesh and venture capitalist, other three people, their return on investment is too risk. But your case is not so. So it is easy that you can able to get a more investment and get a more profit booking also. The modes of our upcoming aerospace startups. So definitely, I think can you able to have a kind of, as you said, I already spoke with Srinath regarding the supply of skilled people in order to develop much more innovations. So do you think much necessary incubation is needed in your sector, as well as you said something theater? So how these can be correlated to bring up more skilled people into the startup?
Okay. When it comes to funding, it's other way. We are a based startup. Investors don't use it always. Manpower has to be pushed in. When it comes to product-based startup, they have to invest till only the product is getting ready. Once the product is ready, it's like replicating. But when it comes to service-based startup, you need to keep running. So investors usually prefer product startup, deep tech startups. Service-based startup, only there are few investors who are looking for like impact investors. And obviously, incubation is a very good platform. Like I'm a normal student with a theatrical background. I had one small idea. As soon as I entered the IIT incubation cell, they provided me with a dedicated mentor who was like Mr. Ravichandra. He's a former MD, TTK Prestige Group. He slowly started telling me do this, do that. He started guiding me how to make a business and how to form a team. I started with one person with almost nothing. So now I have like some 15 full-timers and 20 part-timers working for me. With he generated around like more than 60 lakhs. So within 9 months span. And mostly our growth pattern is word of mouth. And we have our marketing team set now. Now we recently got a funding from IIT. So in service, when it comes to service-based startup, we have to.
Can you explain about your theater? You said you want to say more about the theater combination of this knowledge. So how do you do and how do you grab this young minds into this sector?
When you read about Abdul Kalam sir, when he was 12 years old, one of his teachers told him about the story or any field, anyone. They have one person to trigger the spark. So what we are trying to, I read some say 1,000, 2,000 people. So I started finding all the platforms which trigger the sparks. For example, for every 3 months certification, I'll call from scientists from ISRO or DRDO. Even you were there once or twice and given a speech. When the children get to listen to the scientist talk or founders talk, we never know when the trigger sparks. I will tell them all the stories, mythological stories. I will tell the story Ramayana, Mahabharata. So there's a character called in Ravana's son Meghnad. If you read about his history, he uses stealth technology. He hides and attacks people. Then if you read about Ravana's Vijayadhanushu, it had it has qualities like PSLV or GSLV. So we go in depth into mythology, and when we tell this to children, they start to visual it. And when they visual it, they want to make it. Then they come up with doubts or they draw things. When I taught this to one 7-year-old kid, he started drawing this. Sir, I draw this Vijayadhanushu, it had these qualities. It has a stealth technology, all these things he started telling. So probably he might not understand the technology, but we are creating one folder. The young's mind is like a computer CPU. We just create one small folder. That's enough. Maybe in future he again comes across in TV or sees that drama anywhere, he connected it. He add one more element to the folder. When he meets you, when you say something about hybrid rockets or liquid rockets or chemical rockets, then one more point added to it. This slowly the folder gets heavier and heavier. After a point, it serves the purpose. We have till now we have more than 2,500 students. So if I can able to create one other one, that's going to change entire India.
Yeah, rightly you said. So one. If you put one small song, that is sufficient. It goes inside their brain. Another 3 months or 1 year, it always rotates them, and they keep saying that. So definitely. And how do you see your company like the next 6 months? Whatever I put with Srinath, 6 months and 1 year and 5 years. Because now I think 3 months, other than our Rati or Pelletlex, they need to do a lot of R&Ds and lab to be set up. Our institutions, everything is closed. They would have shut down. But your case is nothing. Now webinar has become very popular. I think now your startup is making a lots of sessions in the online itself. Definitely, this is the right time. I think you would have formulated or you would have stabilized your syllabus or something more. How do you see after 6 months, 1 year, 5 years, the Vaishustra is going to be there?
To be frank, I was against the smart classes at the start. So I want to teach them personally. I want to train them hands-on. But once this COVID got into this thing, I was blank. In February, I was blank. Then our mentor told me, okay, don't worry, because I had like some 15 employees to pay every month. I was blank literally. Then he said, why don't you try some online sessions? Then okay, I started with demo sessions. So I made one syllabus. Earlier we had hands-on models. Now I can't do so much hands-on. So I went in depth into story. I started creating syllabus. I created some 30, 40 session syllabus. So surprisingly, the feedback I got was encouraging, very much encouraging. So we started with a demo free sessions. Then started the word of mouth started to spread across. We within like 45 days we crossed the 1,500 children. So the interest level is more. I talk about mythological stories. the children go crazy. That especially 8 to 13 age group, they are like they love the stories. So now it's like I'm thinking next 6 months. I'm planning to. I already going to set up one unit in Coimbatore with support from Padma University. We are in talks with NIT to set up one unit in Trichy. After setting 2 units and 2 places, then we planning to set one in Mumbai and Bangalore. So which can be virtually controlled by me now. So earlier I didn't have this confidence to control virtually. Now after this COVID, I learned something. I can control everything virtually. I just need few cameras here and there. I just need a few apps to support me. So now my vision is become bigger. See, earlier I was thinking how to go across India, how to go across India. Now it's possible. I can go across India easily. We have a batch from UK. We have students from Australia. So in this last 30-45 days, we got we reached out worldwide. Actually, we almost covered 7 countries. Even though the numbers are small, we reached out. I was myself in I reached out to these countries. So I can able to spread this knowledge across this world now. And there is no difference between UK child and this child. They listen to stories and they love science. When I told them about this Big Bang theory and this how Lord Brahma created from Lord Vishnu's navel, the story is exactly matching with the Big Bang theory. The Brahma is created from the singularity point of Lord Vishnu's navel, and it expands into a lotus flower, and then Brahma comes, he starts to create life forms. Exactly like then atoms start to become molecules, then water, all these things comes. The mythological story exactly matching with these theories. And next 5 years, I want to spread across India. And IITs, they will support us. Yeah, we approached them. I have seen positive thing. Now we are presenting our business plans. Hopefully, they will support us.
Okay, so do you think any competitors there, or you are a mono?
Who teach theater plus aeronautics. There are a lot of companies which teach technology, but not in a theatrical form. They have their own method of teaching. Because this theatrical way of teaching needs, say, at least some 10 to 15 years of theater experience, and they should have done some 200, 300 shows facing the audience, that was especially children. And they must be good at aeronautics, that either masters or PhD. Unless they have both these skill sets, it's tough to replicate this model. Not replicate, it's tough to enact a story in such a way it's engaging for 1 or 1.5 hours. But there are a lot of companies which does even Byju's, there are a lot of platforms. There's like so many platforms, but we are very focused on aeronautics. We don't get diverted. Parents usually ask, why don't you teach maths? Why don't you teach that? We said we are a team of aeronautical engineers. We only do this. So there's a difference when Ramanujam teaching maths and a normal person teaching maths. So there's a difference between aeronautical engineer teaching the basics of aeronautics and a normal person teaching aeronautics. Yeah, that's our idea, and we want to focus only on aeronautics.
Okay, rightly you said. Thank you, Jagadesha. What do you want to say to this IGEN minds, maybe in India? So to come out of this new normal of COVID and place them in the right.
Every second, as you want.
Then I think Vishwesh is there. Vishwesh? Yeah. So it is a long round, I think. Again, I came back with Vishwesh. Vishwesh, what do you say that right now
These kind of startups, I think the young minds can invest or they can step inside. What is the right moment after this COVID-19? Since you have worked in all the areas, including pharma and banking and much more, and you have wide knowledge. So, is it you think 4.0 is going to play a very big role, or digitalization, or virtual world, or which path?
I think one of the byproducts of this pandemic is that technology is increasingly being informed, which means everybody is adopting a lot more tech than ever before. And I think there's a wide opportunity, anywhere ranging from digitization of the nation to then looking at some verticals of saying how does a factory or an industry now operate in the post-COVID environment, following social distancing, following all of that. So I think a broader spectrum of technology is clearly a strong forte for folks to look at building solutions and looking to solve problems. You need to take a problem-solving approach here. You need to find where the problem is and then go look for solutions to it. As against building solutions and then looking for problems.
Okay. Vijay, one important thing, I think you would have heard about our panelists, they're talking about building a rocket and making a propulsion system with a satellite and creating a skilled manpower. So if the three people combine together and form a consortium, so are you ready to fund for them?
Well, other than in parts, if they're able to join together all the momentum, I think there's an opportunity for all of them to integrate, complement their solutions. And what's important is you don't have to necessarily do that by merging the companies. You can, of course, collaborate on the business side of it. The technology of each of these companies are fundamentally different. Some of the DNAs are different, and hence it doesn't make sense to integrate people who are doing complementary things. You can always collaborate because you're complementary. You don't have to necessarily merge. And I think some of them are already doing that.
Yeah, sure. Okay. So how do you see our country after this COVID-19? So much competition is going to come inside. They are talking about China. So many companies, they want to come back to India because of more skilled people and the quality oriented is there. And many sectors they are trying to say. So how do you see that? And whether it is going to increase our economic prosperity or not? Still we have to wait.
So I don't think I'm really qualified to give you a depth answer there. There are a few elements that I'm aware of based on my interactions and dealings. I think there is a lot of geopolitics playing out in our country and in other nations. The people are increasingly going to think what is inside, what sort of competence, right? How can they sort of serve their own requirements from inside and depending on outside? And that will pave way for a lot of opportunities. The part I don't know enough is just for liquidity, growth, manpower, and all of that in the post-COVID situation. Like I said, we operate more in building technologies, and in 8 out of 10 of those folks were less hardware intensive than they can do remotely as well. But the whole nation can't work remote. Some people have to step out, and some things have to happen in the physical world as well. And one has to see how it plays out. I think there is a lot of promise and opportunity in Indianization and opportunities coming out of that. But how and when exactly it play out is, my guess is as good as your guess.
So, okay, rightly said. So what is your advice to the young Indians? How they can able to come back? And moreover, I think these 3 months they have spent lots of time in their mobile phones and gadgets. I think now they have to come back. And what is your encouraging statement to them?
I think you should come out only if you need to. Not everybody needs to step out. I mean, until you have a vaccine, life is not going to be possible. And everybody knows that the vaccine sometimes it is. So I think safety precedes everything else.
Okay, thank you, Vishesh. So one common question to all the panelists, everybody can say that. So what is the challenges and opportunities going to be there? So after this COVID-19.
Hello. Go ahead, Rohan.
Okay, thank you. See, challenges will always remain in aerospace industry when you talk about your what do I call supply chain aspects of it, because certain components which go into technology has to be imported, which is not yet indigenized. So these things, how do you import and what are the lead times? So how these lead times are going to affect your own plans needs to be finalized. I'm getting a background voice. Yeah. So what I was mentioning is that there's definitely going to be a challenge in terms of supply chain aspects, procurement, and again, how team ends up working in your lab and how you are going to allow it, considering all this new safety aspects and social distancing involved. This is a challenge which we are trying to address. And again, if there is a second wave, we don't know, let's hope it doesn't come, but how a hardware company can utilize work from home scenario to deliver best synergies possible. We have to explore and come up with a good solution, like how IT has done. Srinath, you have anything to add?
I think that was a fair point. Supply chain will be definitely looked at that. We'll have to try to work around that part, right? There are challenges though, also in terms of actually how to, or particularly for people like us building hardware, how to stand next to each other and work in a lab. Even those protocols have to be thought through. But I guess people are doing it in other countries at least, so we can learn from that and try to implement something that's what. So those are the challenges. I think so much opportunities available. Like given that there is some positive message from the Indian government in terms of what involving startups and so on, I think this will actually motivate a lot of other people also to come in. This will get the attention of right people in terms of investments as well. So a lot of challenge, a lot of opportunities in multiple areas will open up. You just see this momentum for doing something in space tech, both with established big private players and with more recent companies. I think my view is all of that will get a little more aggressive. The entire momentum will get much better, and I think that we'll all be able to do a lot more. So looks like a very opportune, very, very positive time overall for us. That is my view. Yes, Jagadish, you can also say about your view. Mute, I think you can remove your view. Okay, the view on the COVID situation. Yeah, challenges and opportunity after this COVID-19. On your perspective. For startups, in the service sector or the education sector, there's a huge potential. I just understood, I just realized it. But for industries, it takes time, it will take time, I guess, because there's a lot of restrictions. More than restriction, even though the restriction is removed, people there's a certain uncomfortable or instinctive feel to get out of house. Their mind, it always is what happened, nothing. So they're not free. They feel there's a lot of uncomfortable feelings. With the amount of safety that the companies provide, they can overcome that. Obviously, it will take 6 to 7 months for the hardware companies or manufacturing sector. But the people who are doing this online thing, they had a very good scope for next, I think, 1 or 2 years. They found something new, not new for the companies like us. They found something. And schools, obviously it's going to be like a transformation. I think already most of our friends, they started online classes. So I don't know how this is going. As a after school activity, mind is working good and better with the story. But actual theory class, I have no clue how to do. It's going to happen most of the startups except the very nice. Okay, thank you, Jagadish. Away from Ravi. So I guess most of them have added all the points. There is a lot of challenge. Coming back to the fields is a challenge because being a hardware company
company, and most of the people gone home now. It's difficult to get everybody back here and then start your work, do the testing at your end, at your consumer end. Both the things are challenging from just not our end, but at our customer end as well. So it will take some time, but I guess maybe we'll learn how to manage in such a situation and come up with ways to handle it. So, and in terms of opportunities, because of this situation, government has opened a lot of opportunities for the startups. So let's see how, I guess, all of it will go well finally.
Okay, thank you. I think we got a few questionnaires from our participants. Okay, that's one. I think they've appreciated Jagadish Kumar sir. Your childlike curiosity combined with art is very heterogeneous among the minds in this field of hardcore work, where usually everyone find only the output interesting, except for the people who are actually involved in the process keep doing great. It's from Ramesh, another from Jagadish Kanna. Okay, I think the Jagadish is already given. Okay, fine, thank you. And from Thomas, I think, so shall I ask one doubt? I am a BTech student in mechanical production engineer. Can I continue my studies in aerospace field? So, anybody want to show answer? I think they can.
See, Aerospace is basically a very big ocean in itself, so it doesn't look at what your.
Welcome to Katie's SD card, Bluetooth.
How from an electronics background, finance to again to aerospace. So that doesn't limit if there is passion for the subject, of course they can pursue. But it also depends on certain universities. Abroad, of course, it will be much easier to pursue experience aerospace than in India, because India to admit to certain courses they have restriction that BTech has to be in these categories. But I feel universities abroad, my own experiences, they don't have such restrictions.
Okay, thank you, Rohan. So thank you so much for all the panelists. I think we are on dot. So 14:51. So we planned 3 and 14:51. So 16:51. Sorry. So thank you so much for all the panelists. It's so much thoughtful, encouraging session, I can say, from the youth, maybe less than 35. So they are all more fearless and more courageous. So they want to make our country so proud, especially like an Elon Musk, we say. So I thank Agnikul Srinath from Agnikul, Rohan from Electrics, and Vishesh from the Capital Venture, and Vikanj from Radhi Aerospace, and Jagadish from Vashistra. So definitely, I think my wishes to you for all the upcoming projects, and I also thank all our panelists and from the organizing committee, as well as from Institute of Engineers and Institute of Aeronautics and Astronautics and Aviation. So definitely this would have given a lots of confidence for our younger mind, and they can have that fearless mind to initiate, or boldly they can come out to make an India. So our Prime Minister wants so much of products to be delivered from the soil of our country. Definitely this will give an encouraging point of everybody's thoughts and share. Thank you so much. We will be in touch. Thank you. I think anybody want to conclude, they can conclude it from your panelists.
Thank you, Gokul, for having us.
Thank you. Yeah.
Thanks, Gokul. Thank you very much. Thank you.
Back from Gokul, was really a 2-day wonderful conference with the end of this panel, and we are nearing valedictory now. After the panelists we had from industry, started from space, after that followed by industry, and then academics yesterday, and today we started with again technical talks. Mr. Satish Tokala, who was the manager of MATROS in Defense and Space, he started with his tech talk, and then followed by Dr. Kangareddy sir, Dr. Isham Panigrahi, and again paper presentation, and then again we had a couple of talks from IEEE side, Dr. G. Ramesh, who was the former MAV head of NAL, and also Dr. Satyanarayana Gupta. So that's how it started, and our panel discussion again, the startups joined, and this conference have really given a very big insight in entire aerospace sector, I guess. Today, unfortunately, we missed one startup, main startup, Weekend Aerospace. Unfortunately, he went on emergency. They are doing a great job in aviation sector. Like they are doing NDT for airlines and other. They are into core aviation. And if they might have come, we might have got some more in-depth knowledge about like the startup in aviation sector too. So, but we that was compensated with yesterday's industry sector talk. Their in depth of knowledge about industry, academia, and also research, how it is going in India, and also in relevant to the international community. That's what we had a very big interaction with Dr. Anita Sengupta or Bharat Gopal Swami, and also Dr. Balaji from NASA, and Dr. Sushil, and also Dr. K. Bose from Limerick, and government agencies like P.A. Praveen, who was Director of Aerospace from Government of Telangana, and Dr. S. Pondian, like former director, and also Professor Satish Dhawan from ISRO. And our entire event was inaugurated by Padma Shri and Padma Bhushan Dr. A. Sivathanu Pillai and Padma Shri VASAGAM sir. And earlier to the event, our CAS Kiran Kumar sir have also given his greeting messages through his written statement. We are concluding, and this is how it turned to be a very successful event with turning up more than 1,800 participation registered, especially in the crisis time of pandemic. That too, we did it within 18-19 days. It's a miraculous effort by a team, both IEI backup team, like headed by our Dr. Engineer Ramadas sir, of Chairman of IEI Tamil Nadu State Center, Mr. Dr. Balakumar, Sendil, Tilton, and all along with Gokul, who Prakash, who supported Gokul in the entire team.
I think we have a vote of thanks. We have a vote of thanks in the end.
Yes.
So we can have
okay. With this, I'm concluding and giving it to Mr. Gokul to start this validity function.
Yes, yes. Thank you so much, Karuna, for your highlighting the sessions what we have had for the past 2 days. So we welcome our Dr. D. Vishwanathan sir, who is our former Anna University Vice Chancellor, mentor. So during his period, lots of innovations has happened, and he's also worked very closely with Abdul Kalam sir in missile technology. So, sir, we welcome you, sir.
Good evening.
Good evening, sir. Thank you, sir. Thank you for your presence. Good evening.
Thank you, sir.
Yeah. So, thank you so much for all our speakers, panelists, and the delegates and paper presenters. I think wonderful that 2 days of 30th and 31st of May, we have completely utilized the day with completely on aerospace. I am a chemical engineer, but I'm working in aerospace, but not much more core. So these 2 days has given me lots of knowledge as well as a turn-up point how these aerospace sectors are going up. So definitely, I think there's a large amount of knowledge transfer has happened, and this will boost from Aero. So we, as IGEN, is already having a very huge discipline. So aerospace sector has organized this conference. Now I think it has to go with the next level of discipline, maybe computer science, IT, EEE, and should end up with marine, much more. So I think our Ramadas sir will eagerly waiting for so many sessions to happen. Definitely, we are so happy by the organizing committee of both IEI and IEEE. So as we have come to the validity session, so let me ask our engineer Ramadas sir to have a welcome address for this validity session.
Good evening, one and all. First of all, I welcome today our chief guest for the validity function, Dr. Vishwanath sir. Sir, welcome, sir.
Thank you, sir. Good evening, sir.
And then on behalf of Institution of Engineers, I think you know about the Institution of Engineers.
Yes, yes.
On Tamil Nadu State Center, we are doing a lot of programs regularly.
Yes.
How that we are entering into the centenary year, this thing, 1920 we started, so this year is our centenary year.
Great, great.
So we are, all the centers we are celebrating that centenary year. For that account, this conference also the centenary. Thank you, sir. you are accepting as a validity for the validity function. Thank you, sir. For 2 days, we had a very good, excellent. Yesterday we had 3 panel. This thing, Dr. Pandian, then Dr. Bharat Gopal, Dr. Anita Sita, Balaji, and P. Praveen, Director Aerospace, Telangana State and State. S. Damodaran, Manager Dr. Safran, D. Mageshwar, Aviation, Ms. K. Muniratnam, Dr. S.R. Chakravarti, Professor Aero, IIT Madras, Dr. Santosh Chandra, Assistant Professor IIC Bangalore, Dr. Saniga Arase, Head of Aeronautical MIT Chennai, Dr. Kuriakos from University of Primer. And then today also we had a very good Dr. Satya Pakola from Math Club, and then Dr. N.T. Rangareddy, Dr. Isam Panikra, Dr. D. Muruganandam, and Professor Subraman in coordinating that all the paper presentations, Dr. Ramesh, and Dr. Satyanarayana. Now the men answer from the IIT startup company. Really fantastic, and then amazing. They are doing very well in their respective and all those things. Now we are come to the end of the session. So once again, I welcome Dr. Sir for function, sir. Thank you, sir.
Thank you. Yes, sir. Thank you, Chairman, for your welcome address. As I think we have our committee members other than our Chairman. So can I have 2 people from IEA and IEA to give a feedback of the session? It can be a positive and negative. Can I ask our Ramesh sir, who is there, I think from IEEE, and also Balamurugan from IEA. So both of them can give the feedback. So then we can ask our chief guest to give his valedictory address. They are available?
Yes, Gopal. So yes, Gopal. So this is Dr. Balamurugan.
Yeah. Yes, Balamurugan.
So it was a wonderful session that during this lockdown period. So this IEEE and Institution of Engineers have brought all the engineers in one platform to bring a change to the world. Actually, we are disconnected, but still we are connected for these 2 days. 48 hours we've been tied up with all these technological innovations, with all the participants who are very, it could show the youthness of India actually. So every engineers who has participated are from the age group of the mid-range, and they have exhibited lot of things, and the paper presentations was also very great that they are coming up with new technology, so that is going to bring a change to this world. So it has showcased the innovation that is going around the world with industry 5.0 actually. So the human and mission interface is going to be done through this aeronautical engineering. We are going out of box thinking, like we are traveling beyond the space too. So that is the data that has been collected, and the last one was an exorbitant thing. So as Chairman has told, so the startups, the young people who have come up with the new ideas. So it is a boost for all those people who have participated here. It would really make India to be an investor platform. So where all these brain can be taken into account, and they can come up with their own startup. It was an exorbitant session, and it need to, this platform need to be showcased again. So it is the first of its kind that the lockdown has given an 48 hours international conference to be most successful, with all the stalwarts starting from the day 1 to the end. So thank you so much for the opportunity being a part of it. Thank you so much, sir. Thank you, Google.
Yeah, thank you, Balamurugan, for your wonderful feedback. Can I ask Ramesh, Professor from IEEE, to give his feedback as a part of IEA?
Hello, I'm Ramesh here. Hello.
Yes,
Can,
sir.
can you hear me?
Yes, sir. We can hear you. You're audible.
Fine. Okay. First, my apologies for not having presence right through all sessions. Nevertheless, whatever I could, perhaps in the last 2 days intermittently because I had few other things. I think extremely interesting and useful this conference because the first online conference I ever listened. Whichever session I sat through, definitely I was able to focus and listen to them, and I could grasp something which probably in even a regular conference I would have missed because of various other factors. So I find that way the conference has really delivered. The essence is that wherever we are, if we decide to share knowledge and share our experience, definitely online is the best solution with the kind of tools. And again, I should congratulate IGEN for having taken up this conference, international event of this quantum in a short span of 15-20 days and could muster 1,500 more odd registrants is a thing. Quite a few youngsters from our college, again, they called me today. They told me that our students, they said they found it extremely useful and so much knowledge, they would not have had a chance to have this kind of exposure, wide varieties. In fact, it was a lot of learning for me. In fact, the startup session on space propulsion and all, it's something a good learning for me. So definitely this conference has served its purpose. I'm sure that this tradition should continue. Even if we are out of lockdown also, once in a while we should have this kind of gathering which will help us to share our professional knowledge. And also the youngsters, see, instead of spending all the way coming and it's not affordable to many of them, especially from rural and other places. Definitely this way the conference would has served its purpose. It's also an eye-opener for us that we can do things in a different way. And in fact, if we can have the experimental sessions also online, where certain demonstrations also as a part of this, like you have exhibitions in the regular conferences, you have live demos of certain functioning or certain startup functioning, or in the laboratory demonstration of a certain thing. That also would come very handy for everyone to learn something from the first-hand exposure. So other than that, of course, the kind of plans IEEE and IEI got for the students is something very useful. As I said, internship and exposure, ISRO, somebody was talking. If you allow the students in some way, in a big way, where they have some direct participation in space projects or DRDO projects or aircraft projects and all, that will keep our ecosystem to a different level where, because beyond the academic exposure, if many of the, at least the aerospace students get this kind of exposure to primary contact of space or or through the startups which are doing that, okay, they are not even visiting the campus of DRDO or The next possibility could be to at least work on the startups where DRDO should have should support that activity by terms of some support to the industries which are doing the work of DRDO or space, so that the students will have actual exposure to the realistic problems that are, because there are quite a few problems in DRDO and space. Even for example, even in the CSAR scheme, the National Civil Aircraft Program and all, there are many things which can be broken down to smaller areas where it can go as a undergraduate level problem, honestly to speak, because my exposure after having seen that, if it's only a question of organizing things, that is where we lag. I think that IEEE and IEA should do something about it, where such things are disseminated down the line and reaches the academic community. That is one thing which one has to look at. Other than that, I am in DRDO AR&DB panel. I'll also try to see if we can have a top-down approach on consortium-based projects where DRDO projects on UAVs and all are brought down to academic level by scaling down some of the problems and see it reaches the larger part of academic community where they can work on practical problems. That's my personal thinking from the AR&DB side. So other than that, It's really quite an exciting time and also a lot of learning personally to me also, though I could not attend all the sessions. Definitely, there was a lot of learning. I can congratulate IEEE and also IEA for this excellent effort. It will go a long way with the interest of the community. Thank you.
Thank you so much for your wonderful feedback. We have one participant, I think he said he want to give a feedback. I think he is from US Space Foundation International Teaching License, who is Amajuri Bishwan. So Amajuri Bishwan, you can share your feedback with a couple of minutes alone. Yeah, are you there? You can remove your mute. Amajuri Bishwan?
Yes, he is there. He is in mute.
Yeah, please go ahead. Remove your mute. Yeah, please go ahead, Vishwan. You are hearing us, Vishwan? Vishwan, you are hearing us? Can you talk or? Okay. So, okay, I think he has some technical problem. I think we can see him, but he is not able to talk. Can we have Sriram Banerjee who want to share? If he will. Okay, if.
Okay, leave.
Okay then, yeah, we will. Thank you so much for all the feedbacks, and I think more number of feedback is pouring in our chat box. So I think all our members and panelists can view from there. So thank you so much for all. I think today, I think if you see 31st of May 1981, the SLV launch vehicle was successfully made. So we celebrate almost 49 years of that, and 39 years, sorry. And the same day, 31st of May 2020, this IC AAA 2020 conference was there. And I can proudly say that in the globe, this is the first online virtual mode international conference, making 4 panelists and paper presenting eminent speakers who are a pillar of our nation was being there. So happy. Proudly, we can again say that we didn't use any kind of money except for the certificate registration fees. There's no paper was used, so we made a green conference. And again, there is no wastage in any mode of authority. We have not traveled. We have not taken any kind of food from the home food to hotel food. We have not transferred it. So all we have controlled, but we have learned much more. A good amount of knowledge transfer has happened, and a good amount of contact exploration has happened. I think last panel we see the young entrepreneurs has initiated to make a rocket. It's a big courageous movement in our country is happening. So such a kind of movement is happening, and all the youths of our nation has watched. So this is one of the pride moment we can say. The statistics we see, 1,800 people have registered in our Google form, and 1,200 people we had a direct link in the 5 WhatsApp group, and 1,050 people have viewed it from yesterday to till today, and 35 speakers were there from chief guests till today, our Vishwanathan sir, and 15 papers. I think we received more than 40 papers. We screened in, and today they presented 15 papers. I think wonderfully they presented with all the chairs and vice chairman. So it's a good note that we can able to do whatever we like. So the willingness is very important, and proactive, confident. So we have done that, and we have shown to the world, yes, we can do that. So with all these notations, may I have our Anna University Pro, like former Vice Chancellor
Visaganathan sir, who is very a knowledgeable educationist and much more like his profile. I think we put it in Google, we can see whatever he has carried out. He received so many awards, and he was Vice Chancellor in Anna University. He brought the Anna University in the top 10 in the India. So a lot. So we are so happy your presence for our conference in the validity session. Definitely, I think your thoughts and share will encourage our students, and they can never forget how the sparking has initiated with Sivathanu Pillai. It is going to much more initiate from your words. So it's over to our Vishwanathan sir.
Thank you, Mr. Gokul. I'm extremely delighted. Thank you, Gokul. Distinguished speakers, organizers, participants of this conference, I am extremely delighted to participate in the session for giving this opportunity. University is now going to celebrate a 100th year centenary celebrations, and this conference is part of the centenary activities. Past 2 days, I am also following up all the many speakers, and it is really a great achievement by the organizers of this conference. Practically, if you organize the conference in a conventional format, it's very difficult to accommodate thousands of participants and difficult to bring all the speakers at one platform. Today, the knowledge transformation has taken extremely the grand manner so that it has reaches all the participants and going to reach many thousands of students in the future. And this conference was very useful. We had eminent speakers from India and abroad, and they have shared their experiences and gave useful information and suggestions for the development of the aeronautical field in India. After COVID-19, Indian economy has to be regenerated. Hence, all fields we need to give attention, serious attention. Any nation to be developed, it depends on their knowledge, resource, and technology development indigenously. The past 70 years, we have really done a very good achievement, but that is not sufficient in this technology era. So, we need highly knowledgeable human resource. That has to be achieved only by providing a quality education in the country. If you take the look at the past developments, then we did not have institutions like IITs. Contributions by eminent scientists like Sri Vikram Sarabhai, Sri Sadish Dhawan, Sri Abdul Kalam, these personalities contributed for the development of rockets, satellites, and missiles. So our country has reached top 10 in the world in the space technologies. Hence, what now I look at, even though the light combat aircraft development of the LCA, it took more than 25 years. It's a very long period, but finally we achieved it. I did a small research in the field of missile technology. This project was sponsored by Sri Abdul Kalam in the year 1984. It was a titanium component developed for fission missile, and then we extended the same technology for the other missiles also in collaboration with ISRO. Now, we have many institutions of excellence, but yet to establish specialized institutions like Indian Institute of Space Science and Technology, which is established in Trondheim. Like that, I feel government should establish aeronautical specialized institutions in the country. And research, the dynamic students must be motivated to do research in that field. Now, nearly 200 engineering colleges in the country are offering aeronautical engineering, avionics, aerospace engineering courses. But only around 10 institutions are very high standard. Other institutions are not established in terms of infrastructure, not having qualified teachers. Many thousands of students are learned for this course. Fees are charged from 4 lakhs to 18 lakhs. Finally, students are highly disappointed without getting jobs. So the status of engineering institutions are very sad. Government should invest on producing qualified teachers, and infrastructures should be that this kind of specialized courses. Only government has to establish the infrastructure. Already we have suggested to the government that public-private model, we should establish common research centers in the specialized areas. I hope in the new education policy it will take place. When look at the deemed universities, they are admitting students in even more than 180 students per course. This is very alarming that qualified teachers are not available. We don't have well qualified and trained faculty members in this aerospace field, and hence I request the aerospace industries to offer training and internship for the faculties first and then students. Our government should establish institutions of eminence in the fields of focus on motivating young and dynamic students to pursue their research career. Actually, our country, the admissions in engineering college have come down to 50%. There are 17 lakh admissions seats are sanctioned. Only around 8 lakh students are joining. And out of these 8 lakh students coming out every year, we have only 20% students are employable. So we need to enhance the quality of education, and the employability skill need to be developed. Accordingly, future will be depends upon the quality of education. Otherwise, another 50 years if you go, the quality of education is not taken care of, developments in this field will be standard. So, I would like to congratulate the organizers. Also, with a suggestion that the content of these speakers can be circulated to all engineering colleges, and so that this kind of experts will be available for them at a easy mode. I am really happy, and I would like to again congratulate all the organizers for successfully conducting this conference. Thank you very much. Cool.
So thank you so much, sir, for your informative burst of values you have just given it. Definitely, we will take it up all these informations maybe as well as in the video box. One will be common what we have learned from the panelists, as well as the information and knowledge that the academics people to for these knowledge. Thank you so much, sir, for your presence as well as your participation. So I think we have come to a conclusion. So few announcements for our delegates. Two things: the certificates. So whoever registered, tomorrow IGEN will send a mail to all the registered candidates' mail ID with your name, whatever you have typed. So please correct your name and send it back so that it is a blockchain-based digital certificate. So once your name is imprinted, it will be a unique code will be generated and it cannot be duplicated. So if the name is printed very wrongly, IEA cannot take that responsible because each and every certificate has to be spent a huge amount of fee from your registration fee. So we request all the people to give the correct name with your initial or with your surname, whatever you built. So tomorrow you will receive a mail from IEA. So please give your correct name which to be printed. And same way for our paper presenter, same way you also please try to give your correct name with your paper title. Today I would have shared the certificate format in your group. So please give the complete topic of your paper. So that also will be included
and it will be sent as a soft copy right now. The hard copy, I think Chennai still, I think they have extended the lockdown till June 30th. It may extend it till July also. So maybe when government has lifted up complete lockdown, so you can send a mail to us so that your hard copy can be made it ready and you can collect it from IAE office or through any other mode. So this is for our delegates information so that all the delegates can even pass the same information to your friends. This is I think with this we come to a conclusion to all our conference. So thank you so much for all people. So I would like to call our Honorary Secretary of IEEE, Karnataka, to deliver the vote of thanks.
Thank you, Gokul. I am former secretary. It's a very big privilege to be with all these eminent people and also to share success with youngsters and also to witness this with the seniors. And I like to thank first of all our chief guest, our Dr. D. Vishwanathan sir, who have immediately accepted and have been here for the whole day and have witnessed the entire event, and his words are truly inspiring. As he said, faculty should be first trained. So that's the main motto of IEEE, to be very frank. In IEEE, what you can see in the Institute of Aeronautics, Astronautics and Aviation, right from Dr. G. Ramesh sir, who have gave a talk, is also now connected with the institution. Every engineer, after his successful career, ends on with sharing his knowledge to younger generation in a college. So, but there is a very big gap between current leaders and the coming up leaders, especially in aerospace. As you rightly pointed out, sir, after 2010, as you are probably aware of it, from 2005 to 6, there was no big aerospace colleges. After that, it bursted like anything. And now what the scenario you are saying, like 200 colleges, institutions are there, and only 10 are there. And there is a very big gap. It's true. And the generation gap is like below 35 years of faculty and then above 55. After 5 years, we don't know where it will end up in. So we took it up as a challenge to share them what is the industry. Unlike mechanical or unlike automobile or unlike electrical or anything, but aerospace industry is from the basic itself, operations or degree holders or graduates are not connected with operations or aviation. They were only having an opportunity in core research so far. And only for less than a decade, we are having an opportunity in aerospace sector too. So we want to address this issue and we want to make students, as one of the panelists today, the startup panel, he said in UG what happened to him like that. But that is also a reason because of the faculty's awareness and the connection with the industry and the networking of the faculty and their experience level also. That was the time when he graduated, more number of young faculties joined. Exactly you want to say. So this is what the challenge we took up. Yes, if there is a challenge, definitely there will be hurdles. And yes, in these 3 years, we have passed a lot of hurdles. And as a team across India, right from IIT Guwahati to Kanyakumari, we have members who are supporting us and contributing to the association. And this time, with the support of our chairman of IEA Tamil Nadu State Center, Ramdas sir, this event have happened. I never imagined. I just even recollecting the first meeting when we had in Zoom, and I was wondering whether sir will accept. Why? Because we proposed a course less than 20 days. It was only 18 or 19 days, and he was also surprised. But I thought, okay, as usual, like other professional bodies, there will be lot of bottlenecks, questions, but he gave fully on our hand, and he worked along with us in our team as our own age group like that. But it really inspired. And he done a lot of backup work, his support, especially in this kind of certification, blockchain certification is his idea, and that have brought really a value for the conference, more than what the speaker or anyone have spoke. Like IE, ML, A, artificial intelligence and blockchain are the future. And students, even institutions, and this conference have become an example for other organization and association for utilizing blockchain for certification purpose. That goes to that appreciation and credit goes to Ramdas sir only.
So we have already thanked a lot, everyone. I need to thank. It's my duty to thank IT Professor Dr. Satya Chakravarti, IAC Professor Santosh Hemachandra, and Dr. Taniyar sir, who was really, he came up with a lot of well and good points yesterday, and it was critically acclaimed. A lot of professors called me yesterday evening after that panel session, and also today Dr. Isham Pandegrehi and other panel members. And the team of faculties worked with Dr. Satyanarayana Gupta of MLRT Hyderabad, especially Mrs. Uday Deepika and team, who have worked a lot in evaluating papers. They did a great work. And moreover, last but not least, as always, Mr. Gokul and Dr. Sushil have made a tremendous effort. They are the pillars of the conference. Like Ramdas sir had the reason behind it, but they have really stood for the conference and have did everything. And if I have missed someone else, please pardon me. And really, this have set a very big milestone and mark for everyone. We need to come up with the souvenir, and also, as sir mentioned, Mr. Sir mentioned, we need to write down and circulate the things. And I like to suggest that as this is the first Aerospace International Conference in the lockdown, we should also apply for a India Book of Records or something to mark this event. Participated and everything that will become like ever long lasting documentation on our part. Thank you.
Yeah, thank you, Karuna, for the vote of thanks. I think we also should thank few of our partners, IELC, IGEN, and IEA, and a few backup paper, Dr. Balagunagan, Professor Ramesh, Prakash, Sendil, Hilton, and Abhishek. I think they people are background worked on the preparing the posters and reaching the content to the audience completely in the board level. So we thank all our people. So also the IEA and IEA for their
also Muthuraman, Professor Muthuraman and Muruganandam, Dr. Muruganandam, principal of SVCT.
Yes, and Gupta sir who have taken, and the Professor Deepika. So she was completely assisting on technical paper, also the debate session, connecting from Hyderabad. So that is what this conference, people sitting in various locations, they have connected it and they have made it. So that is the one big appreciation we can give. So with that, I think we come to close of the conference. I again repeat the announcement. People are sending me a WhatsApp. So people need not to worry about the certificate. Tomorrow you will receive a mail from IGEN. That is, whoever registered mail ID to IEA for your payment, you will receive a mail from IEA for your certification. Please correct your name and send it back, so that it will take 3 days. So it will take Wednesday or Thursday to make your certificate ready. Once it is ready, a mail will be sent. So need not to worry about it. There is an announcement. So thank you so much. I think with that, Ramdas sir, you want to say anything?
I thank all everybody is the backbone of the entire this conference. Really, it is a wonderful conference. I thank IEEE, Nagaran sir, and other. Really, I am amazed 2 days. Really, the 8 days work. So really, thank you. And then and Ramesh, you and other Sendil Kumar and other people. Thanks.
Thank you, sir. Thank you. So we are getting a lot of feedback from the audience in the chat box also. I think people can see that. So stay tuned. I think IEA with other one more conference will be planned up. I think this year it is not a lockdown only for the going out, not for our brain and knowledge. So definitely this is going to prove a green conference without any wasting of even a paper. So we are returning back to the environment. We are again say that environment, you are protecting us. Definitely we will also protect you by not wasting any kind of resources.
Everything is available in the YouTube channel.
Yeah. So even we will try to put it up this conference in the IEA website and IEEE website. Once the video is recorded and edited, so people can utilize it. And very soon we will release souvenir book with the complete paper also within 15 days of time. So that also will be uploaded and sent in a mail. So people can utilize. And we got a message from Kiran Kumar sir. So that is one big applause, who is a former chairman of ISRO for this conference. even his presence could not able to give. He has given a wonderful message to us. So thank you, Vishwanathan sir, for your presence at this evening. So
Thank you,
definitely,
sir.
I think lockdown 5.0 entered, and unlock 1.0 have started. So the conference also ended. So hope so. Everybody stay safe. COVID is in war. So we will be back again to make our nation proud. Thank you so much.
Thank you so much.
Thank you, sir. Thank you. Thank you so much for your. இல்லை இல்லை அதுதான் இப்போ இது பண்ணியிருப்பீங்க சார். இல்லைங்க சார், யூடியூப் ஒரு சேனல்,